In 1977, humanity embarked on a remarkable journey into the cosmos with the launch of the Voyager spacecraft. Among the many wonders contained within these interstellar probes was a unique artifact known as the Golden Record. This seemingly ordinary phonograph record is a time capsule of sorts, designed to convey the essence of life on Earth to potential extraterrestrial civilizations. The Golden Record is a fascinating compilation of sounds and images that represent our planet's diverse cultures, languages, and natural wonders. Encased in gold-plated copper, the record is built to last billions of years and serves as a bridge between worlds. But what exactly is on this remarkable disk? First, let's consider the sounds. The Golden Record features a collection of greetings in 55 different languages, showcasing our planet's linguistic beauty. Imagine the warmth of a human voice, each one representing a unique culture and perspective of life on Earth. Alongside these greetings are sounds that echo the life we experience daily, such as the song of a whale, the rustle of leaves, and the laughter of children. Each sound captures a moment of connection to our world, illustrating the rich tapestry of existence. Now let's shift our focus to the images included on the record. The Golden Record contains 116 photographs and diagrams, representing various aspects of humanity and the Earth itself. These images offer glimpses into our history, showing everything from the vast landscapes of our planet to the bustling activities of life in a city. There are images of families, animals, and significant landmarks, creating a visual narrative that reveals the diversity and beauty of life. Each picture serves as a silent ambassador of what it means to be human. The significance of the Golden Record extends far beyond mere curiosity. It is an act of hope, a hopeful message to the universe that we exist. Embedded in the vinyl is the spirit of exploration and a desire to connect with others, regardless of the cosmic distance that may lie between us. The record acknowledges our shared existence and demonstrates our capacity for creativity and communication. Voyager's Golden Record is not just a physical object. It is a representation of humanity's unique perspective within the vast universe. As it travels further from Earth, it carries with it the dreams, joys, and wonders of our world. It is a legacy that symbolizes the profound questions we ask about existence and our place in the cosmos. In the grand tapestry of infinite stars and galaxies, the Golden Record stands as a beacon of our experience, a testament to who we are and what we hold dear. So as we imagine the distant future, we can picture the Voyager spacecraft gliding silently through the void, carrying our stories far beyond the reaches of our own solar system. In its journey, it reaches toward the stars, inviting others to listen, reflect, and perhaps share in the incredible adventure of life. In the vast expanse of the universe, there exists a mysterious substance known as dark matter. This intriguing concept makes up about 27% of the total mass and energy in the universe, yet it remains invisible and undetectable by traditional means. Imagine a giant cosmic puzzle where most of the pieces are missing, and dark matter is one of those elusive pieces that scientists are striving to comprehend. Unlike ordinary matter, which includes everything we can see, touch, and interact with, such as stars, planets, and even ourselves, dark matter does not emit, absorb, or reflect light. This is why it is so challenging to observe directly. Instead, it is detected through its gravitational effects on visible matter. Picture a galaxy swirling in the cosmic dark, with stars spinning around a central point. Although we can observe the stars, dark matter is what provides the gravitational pull to keep them in place, allowing galaxies to form and hold together. One striking example of dark matter's influence is the way galaxies rotate. Researchers have measured the speeds at which stars orbit the center of galaxies, and surprisingly, they found that the outer stars move much faster than current models of gravity would predict. Without the presence of dark matter, these stars would be flung away into the cosmos. Dark matter's invisible halo envelops galaxies, exerting a gravitational force that keeps them stable and intact. The implications of dark matter stretch far beyond individual galaxies. It plays a significant role in the large-scale structure of the universe and affects how galaxies cluster together. Consider the universe as a grand web of interconnected galaxies, with dark matter acting as the threads that hold the structure together. By studying the distribution of galaxies and their movements, astrophysicists derive insights about dark matter's existence and its properties. To delve deeper into this enigma, scientists use various methods. One approach involves observing cosmic phenomena, such as gravitational lensing. When light from distant galaxies passes through a massive object, like a galaxy cluster, it bends and distorts due to gravity. This effect allows researchers to map out the presence of dark matter, revealing how it interacts with light and visible mass. In addition to gravitational effects, scientists are also investigating possible particles that could make up dark matter. The leading candidates include weakly interacting massive particles, or WIMPs, which, if they exist, would interact with normal matter only through gravity and the weak nuclear force. Experiments are ongoing in laboratories around the world, attempting to detect these particles and unlock the secrets they hold. Despite its elusive nature, dark matter has opened up a fascinating realm of inquiry about the universe. It challenges our understanding of physics and invites us to ask questions that stretch the boundaries of our knowledge. Each new piece of evidence about dark matter not only brings us closer to a clearer picture of the universe, but also ignites our curiosity about the fundamental questions of existence. As we continue to explore the dark corners of the cosmos, we may find that this invisible substance is key to unraveling some of the universe's greatest mysteries. Imagine a place in the universe where gravity is so strong that nothing can escape, not even light. These extraordinary regions are known as black holes. They capture everything that ventures too close, creating a dark gravity well that swallows stars and clouds of gas. But what if I told you that these mysterious giants are not merely cosmic vacuum cleaners? They might actually be capable of emitting particles. This intriguing idea is known as Hawking radiation, named after the brilliant physicist Stephen Hawking. In the early 1970s, Hawking combined principles of quantum mechanics and general relativity to reveal a fascinating phenomenon. According to his theory, black holes aren't entirely black. Instead, they can emit tiny particles, suggesting that they are not permanent fixtures in the universe. To understand how this happens, we must explore a little further. At the heart of the quantum world lies a grand dance of subatomic particles. According to quantum mechanics, pairs of particles and antiparticles constantly pop in and out of existence throughout space. This phenomenon occurs even in the vacuum of a black hole. When one of these particle-antiparticle pairs forms at the event horizon, the edge of the black hole, a curious event can take place. If one particle falls into the black hole while the other escapes, the escaping particle becomes detectable. This emitted particle is what we refer to as Hawking radiation. You might wonder how a black hole can lose anything when its gravitational grip is so fierce. However, this radiation suggests that black holes can actually lose energy over time. If a black hole continues to emit Hawking radiation without gaining more mass, it can gradually shrink in size, leading to its eventual disappearance. Picture a massive star that reaches the end of its fuel. Just as it collapses under its own gravity, a black hole too can undergo a similar kind of transformation, but through this unique mechanism of particle emission. This has profound implications for our understanding of the universe. If black holes can evaporate, it raises questions about what happens to the information they contain. The idea of information loss in black holes has captivated theorists and led to engaging debates among physicists. Some suggest that information may be preserved in a holographic manner, while others believe it is lost altogether. This ongoing discussion exemplifies how Hawking radiation has become a cornerstone in modern physics, stimulating thoughts about the fabric of reality itself. As we explore the cosmos, we find that black holes are not merely destructive entities. They embody a paradox and challenge our comprehension of nature's laws. The idea that they can emit radiation and possibly fade away adds a layer of complexity to our understanding of these immense cosmic phenomena. Stephen Hawking's insights into black holes and Hawking radiation open doors to new knowledge and inspire us to continue unraveling the mysteries of our universe, inviting us to ponder the delicate balance between creation and destruction in the grand tapestry of existence. Through this intriguing lens, we can view black holes not only as endpoints of gravity, but as dynamic players in the cosmic drama. Imagine holding a tiny sugar cube in your hand. Now, picture that this small piece of matter, just a few centimeters across, weighs about 6 billion tons if it were part of a neutron star. This astonishing fact highlights the incredible density of neutron stars, which are among the strangest objects in the universe. Neutron stars are formed from the remnants of massive stars after they have gone through a supernova explosion. During this explosive death, the outer layers of the star are ejected into space, leaving behind a core that collapses under the force of gravity. The conditions in this core are extreme, with temperatures soaring to millions of degrees and pressures greater than anything we experience on Earth. In this chaotic environment, protons and electrons combine to form neutrons, resulting in a star that is primarily made up of these densely packed neutrons. To put this density into perspective, consider how ordinary materials behave on our planet. For example, a piece of iron, which is known for its heaviness, is substantially less dense compared to a neutron star. While iron has a density of about 7,800 kilograms per cubic meter, neutron stars can reach densities of roughly 400 million grams per cubic centimeter. This means that a neutron star is not just heavier, but incomprehensibly more compact than anything we encounter in our day-to-day lives. The strength of gravity on a neutron star is another mind-blowing concept. If you were to find yourself on the surface of one of these stars, the force of gravity would be around 2 billion times stronger than what we experience here on Earth. If you were to drop an object, it would hit the surface in a fraction of a second, illustrating just how extreme the conditions are. Despite their small size, which is about the diameter of a city, neutron stars can pack in more mass than our Sun. A typical neutron star might have a mass about 1.4 times that of the Sun, yet it is only about 20 kilometers across. This immense compression leads to some fascinating physical phenomena, including the fact that neutron stars can rotate at staggering speeds. Some rotate several hundred times per second, creating beams of radiation that sweep through space, which we can detect as pulsars. The study of neutron stars continues to reveal new insights into the fundamental laws of physics. Scientists are particularly intrigued by their behavior under such extreme conditions, which could help improve our understanding of matter itself. The incredible density of neutron stars challenges our knowledge of how matter can exist, raising questions about the limits of the universe and its underlying forces. As you marvel at the wonders of the cosmos, take a moment to appreciate these fantastic celestial objects. The density of a neutron star serves as a reminder of how extraordinary the universe can be, filled with phenomena that stretch our imagination and challenge our understanding of the laws of nature. The very fabric of existence is woven with these stars, creating an awe-inspiring tapestry of cosmic events. In October 2017, astronomers captured a glimpse of a remarkable visitor from beyond our solar system. This object, named Oumuamua, which means scout or messenger in Hawaiian, is the first known interstellar object to traverse our cosmic neighborhood. Its arrival sent waves of excitement through the scientific community and sparked a multitude of questions about its nature, origin, and the secrets it might reveal about the universe. Oumuamua is unlike anything we have encountered before. It measures approximately 800 meters long and has a cigar-like shape, making it appear quite distinctive compared to the rounder, more familiar comets and asteroids that orbit our Sun. Its unusual form attracted immediate attention, with scientists eager to understand why it looks so different. The object is also uniquely colored, with a reddish hue, indicating that it contains a mix of organic materials and possibly metals. One of the most intriguing aspects of Oumuamua is its trajectory. It entered our solar system at a high velocity, traveling at about 315,000 kilometers per hour, and it is now thought to be heading back towards the depths of interstellar space. This high speed suggests that it is not bound by the Sun's gravitational pull, further confirming its status as an interstellar traveler. Its journey may have begun in another star system, but just what that star system is remains a mystery. The discussions surrounding, quote, Oumuamua's origin have sparked a lively debate among astronomers. Some propose that it could have originated from a large planetary system, where gravitational interactions with other objects ejected it into interstellar space. Others speculate that it might be a fragment from a protoplanetary disk, a remnant of the early formation of a solar system. Each theory opens a new window into understanding how different celestial bodies form and evolve in the galaxy. Adding to the complexity of its story, Oumuamua exhibited unusual acceleration as it moved through our solar system. This acceleration did not follow the expected patterns of gravitational interactions alone, leading some scientists to propose that outgassing, similar to what comets experience, could be at play. However, no visible tail or coma was observed, which is typical of comets. This has led to even more speculation about the object's composition and behavior, raising questions about what we really know about interstellar wanderers. To complicate matters even further, some researchers have even postulated that Oumuamua could be artificial in nature, suggesting that it might be a probe sent by an advanced civilization. While many in the scientific community regard this idea as speculation, the very thought opens our imaginations to the cosmic possibilities of life beyond Earth. As we continue to study, Oumuamua and the data it has provided, we are reminded of the vastness of the universe and how little we still understand. Every new discovery can bring us closer to answering profound questions about the cosmos and our place within it. Whether it was simply a wandering stone or something that hints at deeper mysteries, Oumuamua will remain a symbol of our quest for knowledge and understanding in the boundless universe. In the vastness of the universe, there exists a collection of mysterious regions known as supervoids. These are enormous areas of space that contain significantly less matter than what we find in the average region of the cosmos. While the majority of the universe is filled with galaxies, stars, and planets, supervoids stand out as strikingly empty expanses that intrigue astronomers and cosmologists alike. Imagine a giant bubble in a sea of cosmic activity, where the usual players, clusters of galaxies, nebula, and dark matter, are noticeably absent. Some of these supervoids can stretch over 1 billion light-years across, showcasing the sheer scale and complexity of the universe. One of the most well-known supervoids is the Giant Void, located in the constellation Eridanus. This region challenges our understanding of cosmic structure and formation. To visualize a supervoid, think of a vast desert amid a thriving metropolis. While the city is bustling with life and activity, the desert is serene and empty, providing an intriguing contrast. In the same way, supervoids are surrounded by the rich tapestry of galaxy clusters and filaments that make up the large-scale structure of the universe. This juxtaposition raises many questions about how these voids formed and what role they play in the evolution of the cosmos. Cosmologists have been trying to understand the significance of supervoids for many years. Some theories suggest that these empty regions might give us insights into dark energy, the mysterious force that drives the acceleration of the universe's expansion. As researchers explore these vast areas, they look for clues that might help unravel the puzzle of dark energy and its impact on cosmic evolution. Interestingly, supervoids can also influence the way we observe distant galaxies within and beyond them. When light from a galaxy passes through a supervoid, it can be altered by the underdensity of matter. This results in a phenomenon known as gravitational lensing, where the light bends around massive objects. As a result, distant galaxies appear distorted or magnified, providing valuable information about the structure of the universe. The study of supervoids also leads to broader inquiries about the nature of space itself. Some scientists speculate that these gigantic voids could offer insights into the fabric of the cosmos. Are they a necessary part of cosmic evolution, or do they arise from peculiar conditions during the universe's formation? Each supervoid holds potential answers that could reshape our understanding of reality. As we continue to explore the universe, the mysterious nature of supervoids captures our imagination. Each discovery brings us one step closer to unraveling the complexities that govern our existence and the infinite cosmos beyond. The journey through these enormous emptiness is not just about understanding voids, but also about grasping the magnificent and intricate web of the universe that we are a part of. The cosmic microwave background, often referred to as the CMB, is an extraordinary remnant of the early universe. It is a faint glow of radiation that fills the entire universe, a relic from the time just after the Big Bang when the universe was still in its infancy. Imagine being able to look back in time, peering into the moment when the universe was merely a hot, dense soup composed of particles and energy. The CMB is that glimpse, providing vital clues about the universe's birth and evolution. To understand the significance of the CMB, let's travel back approximately 13.8 billion years to the moment of the Big Bang. The universe, at this point, was a swirling cauldron of extreme temperatures and energy. As it began to expand, it cooled, allowing particles to combine and form hydrogen and helium. This period is crucial, as it paved the way for the formation of the first atoms. Around 380,000 years after the Big Bang, the universe had cooled enough for these atoms to form and for light to travel freely. Prior to this moment, the universe was opaque, filled with a hot fog of charged particles. However, as the first atoms took shape, photons, packets of light, were released. These photons have been traveling through space ever since, and they provide us with a snapshot of the universe at that very early stage, a treasure trove of data waiting to be understood. The radiation we observe today as the CMB exists in the microwave spectrum. Though it is invisible to the naked eye, it can be detected by sensitive instruments. The CMB is remarkably uniform, but it does possess slight fluctuations. These tiny variations are key, as they correspond to regions of different density in the early universe. Over billions of years, these small differences in density led to the formation of galaxies, clusters, and the vast structure we see today. By studying the CMB, scientists can unravel the mysteries of the cosmos. From it, we learn about the age and composition of the universe. It offers insights into its rate of expansion and the presence of mysterious phenomena like dark matter and dark energy. The patterns imprinted in the CMB serve as a cosmic map of the early universe, revealing how it evolved into the rich tapestry of galaxies, stars, and planets we see now. Numerous missions have been dedicated to observing and analyzing the CMB. Notable among these is the Wilkinson Microwave Anisotropy Probe, or WMAP, and the more recent Planck satellite. These instruments have carefully measured the CMB's temperature and its fluctuations, providing an incredibly detailed picture of the universe's early state. In essence, the cosmic microwave background is more than just radiation. It is a bridge to our past, a testament to the origins of the cosmos, painting a vivid picture of the universe's history. This fascinating afterglow not only illuminates the conditions that governed the early universe, but continues to challenge and refine our understanding of the cosmos, reminding us of the immense scale and complexity of everything that surrounds us. Gamma-ray bursts, often referred to as GRBs, are some of the most extraordinary events observed in the universe. Imagine the immense energy released during one of these bursts, which can be 1,000,000 times more powerful than the energy emitted by the sun over its entire lifetime. Consequently, these intense bursts of gamma rays are considered the brightest electromagnetic events known to exist. Most gamma-ray bursts occur far across the cosmos, typically at distances greater than 4 billion light-years from Earth. This means when we observe them, we are looking back in time, catching a glimpse of the primordial universe. GRBs are thought to occur during cataclysmic events, such as the collapse of massive stars or the collision of neutron stars. When a star that is at least 20 times more massive than our Sun exhausts its nuclear fuel, it can no longer sustain itself against gravity. As a result, the core collapses, leading to a supernova explosion. This process can produce a jet of gamma rays that is launched into space at nearly the speed of light. Interestingly, GRBs can be classified into two main categories: long-duration and short-duration bursts. Long-duration bursts typically last from seconds to several minutes and are associated with massive stellar explosions, while short-duration bursts last less than 2 seconds and are thought to arise from the merging of compact objects, such as neutron stars. This categorization helps astronomers better understand the mechanisms driving these immense releases of energy. When we detect a GRB, it can cause ripples throughout the universe, affecting entire galaxies. Probing these powerful bursts provides insight not only into the life cycles of stars, but also into the conditions of the early universe. The light emitted during a GRB can be studied to reveal information about the elements present in corresponding galaxies, their distances, and their formations. The study of gamma-ray bursts is not just a scientific endeavor. It captivates the imagination of astronomy enthusiasts and casual stargazers alike. Researchers rely on advanced telescopes and satellites to observe and analyze these bursts, using data to unravel mysteries buried deep in space. The SWIFT satellite, for instance, was specifically designed to detect GRBs and can quickly adjust its instruments to capture follow-up observations, providing a wealth of information about these cosmic phenomena. As we continue to explore the universe and unravel the secrets of GRBs, the potential discoveries are endless. These ferocious bursts remind us of the incredible forces at play in the cosmos and how much we have yet to learn about the nature of our universe. With each new observation, we take a step closer to understanding the universe's most awe-inspiring events, igniting our curiosity and sparking a sense of wonder about the world beyond our own. Saturn's moon Titan is one of the most fascinating celestial bodies in our solar system. Unlike any other place we know, Titan boasts vast lakes of liquid methane and ethane, creating a unique landscape that has captivated scientists and space enthusiasts alike. Imagine standing on the shores of a dark, shimmering lake with the thick and hazy atmosphere surrounding you, while the distant glow of Saturn looms in the sky. This scene is not just a figment of science fiction, but a reality on Titan. One of the most striking characteristics of Titan is its surface, which is covered in rivers, lakes, and seas made primarily of methane. While we tend to think of methane as a gas that is found in our own atmosphere, Titan's frigid temperatures allow it to exist in liquid form. The temperatures on Titan hover around -290 degrees Fahrenheit, creating an environment where methane and ethane take center stage. These lakes provide a stark contrast to the icy terrain around them and evoke curiosity about the moon's geological processes. Moreover, Titan is a world with an atmosphere that is thicker than Earth's and is composed of nitrogen, just like ours, but it contains a mix of hydrocarbons too. This complex atmospheric chemistry leads to a series of processes that have terrestrial analogs, making Titan a potential laboratory for prebiotic chemistry. As we delve into the study of its methane lakes, scientists hope to uncover clues about the building blocks of life and the origins of organic compounds. The exploration of Titan and its lakes began with the Cassini-Huygens mission, which revealed many secrets about this enigmatic moon. The Huygens probe, which descended to Titan's surface, provided stunning images of its lakes and intricate river systems. One of the most astounding features observed was the presence of clouds and rain, composed of methane instead of water. The rain causes a cycle of evaporation and precipitation that shapes Titan's landscape, much as water does on Earth. In addition to its intriguing lakes, Titan also presents opportunities for astrobiology research. Although the temperatures are far too cold for life as we know it, the presence of organic molecules and the mechanisms for complex chemistry suggest that there may be unknown processes at work that could hint at life forms vastly different from those on our planet. It poses questions about how life might exist in environments that are entirely different from our own. The vast lakes of methane and ethane on Titan also inspire imaginative speculation about future exploration. Engineers and scientists are excited about the possibility of sending missions to Titan that could explore its lakes and atmosphere in greater detail. Perhaps one day, we will deploy autonomous submarines to navigate its liquid depths, searching for signs of chemistry that illuminate the processes of life's origins throughout the cosmos. As we continue to study Titan, we are reminded of the vast diversity of worlds in our solar system. This icy moon, with its lakes of liquid methane, challenges our understanding of life and chemistry, making it a key focus in the quest to understand the universe around us. Titan, with its unique features, invites us to look beyond what we know and to imagine what wonders may still lie hidden in the dark, mysterious expanse of space. Pulsars are one of the most fascinating phenomena in the universe. Imagine a highly magnetized, rotating neutron star, incredibly dense and compact, spinning rapidly on its axis. These cosmic giants can rotate multiple times per second and are known to emit beams of radiation that sweep across the cosmos like lighthouse beams. The term pulsar comes from the combination of pulsating and star, describing how these stars emit periodic bursts of energy. From Earth, a pulsar appears to flash in a regular pattern, much like the way a lighthouse signals ships at sea. This unique flashing occurs because the pulsar's radiation is emitted from its magnetic poles. As the neutron star rotates, these beams of radiation become visible to observers when they sweep across our line of sight, creating the effect of pulsating light. These compact stars are born from the explosive deaths of massive stars during supernova events. After exhausting their nuclear fuel, the core collapses under gravity, resulting in a neutron star. Despite being only about 20 kilometers in diameter, pulsars can have more mass than the Sun, leading to extreme densities where a sugar cube-sized amount of neutron star material would weigh as much as several billion tons on Earth. One of the remarkable aspects of pulsars is their precision. Some pulsars are so regular in their rotation that they can be used as cosmic clocks, with timing stability that rivals atomic clocks. For example, the millisecond pulsars, which rotate hundreds of times per second, are especially noteworthy for their regularity. They are so precise that scientists can measure shifts in their pulses due to the effects of gravity, an experimental verification of Einstein's theory of general relativity. Pulsars also provide insights into the fundamental laws of physics. Studying their emissions helps researchers understand the behavior of matter under extreme conditions. Pulsars have extremely strong gravitational and magnetic fields, making them natural laboratories for testing theories in both astrophysics and quantum mechanics. Moreover, these stellar beacons help astronomers map the intervening space by revealing information about the interstellar medium, which can influence the signals they emit. Recent discoveries have highlighted fascinating phenomena related to pulsars. such as the detection of pulsar systems where two pulsars orbit each other. This interaction has allowed scientists to obtain valuable data on gravitational waves, expanding our understanding of the universe. The energetic beacons have also been involved in discoveries related to the mysteries of dark matter and the evolution of stars. In summary, pulsars are intriguing celestial objects that serve as both cosmic lighthouses and vital tools for scientists seeking to unlock the secrets of the universe. Their remarkable attributes and behaviors not only capture our imagination, but also deepen our understanding of the laws governing the cosmos. As we continue to explore these cosmic mysteries, pulsars will likely remain pivotal in the journey of discovery, illuminating the vastness of space in spectacular fashion. The heliosphere is an incredible region that encapsulates our solar system, extending in a bubble-like formation that creates an intriguing environment influenced by the sun. Picture this immense bubble, formed by the constant flow of solar wind, which is a stream of charged particles continuously emitted by the sun. This wind travels through space, carrying with it magnetic fields and energy that shape our cosmic neighborhood. As one moves away from the sun, the solar wind interacts with interstellar medium, a diffuse collection of gas, dust, and cosmic rays that exist in the space between stars. This interaction creates a dynamic boundary, known as the Heliosphere Boundary. At this boundary, the solar wind begins to slow down significantly, leading to various fascinating phenomena. Imagine the heliopause, the point where the solar wind's strength is no longer enough to push back against the pressure of the interstellar medium. It marks a significant transition in the journey through space, introducing a more stable environment where the density of particles around us changes dramatically. Beyond this boundary, the interstellar medium rules the roost, with a different composition and energy dynamics compared to the solar wind. The heliosphere itself plays a protective role for our solar system. Its magnetic field creates a shield that helps block harmful cosmic rays from distant supernovae and other violent celestial events. This protection is crucial for the stability of life on Earth, and it underscores the importance of the heliosphere in our cosmic neighborhood. Scientists have been working diligently to understand this mysterious boundary. Missions like Voyager 1 and Voyager 2 have traveled far beyond the influence of the solar wind and have provided invaluable insights into this region. They have sent back information about the behavior of particles and magnetic fields, offering a glimpse into what lies beyond our solar bubble. As we study the heliosphere boundary, we gain not only knowledge about our solar system, but also about the broader universe. For instance, understanding how solar and interstellar winds interact helps us learn about other star systems and their potential to support life. The heliosphere acts as a cosmic laboratory, where we witness the interplay of forces that shape the environment of countless other planetary systems. In contemplating the heliosphere boundary, one cannot help but be struck by the sheer scale of the universe and our place within it. This bubble, while representing a protective haven, also serves as a reminder of the vastness and complexity of space, where countless interactions occur, shaping the fate of celestial bodies and the formation of stars. So as we look beyond the sun's glowing presence, we can appreciate the heliosphere boundary for the fascinating zone it is, bridging our solar system with the unknown expanse of the cosmos beyond. It urges us to continue exploring and uncovering the mysteries of the universe, discovering not just where we come from, but where we might go in this ever-expanding universe. Population 3 stars are a fascinating topic in the study of the cosmos, representing the very first generation of stars that formed in the universe after the Big Bang. Unlike the stars we see today, these ancient giants were composed almost entirely of hydrogen and helium, lacking any heavier elements. This absence of metals is significant, as it means that population 3 stars were born in a pristine environment, devoid of the chemical enrichments that later stars would have. Imagine the universe just a few 100 million years post-Big Bang. At this time, the cosmos was a vast and dark expanse, filled only with the simple light gases of hydrogen and helium. It is thought that the first stars ignited in this environment, catalyzing a series of cosmic events that would shape the universe as we know it. These stars are believed to have been incredibly massive, possibly several times the mass of our Sun. Their immense gravitational forces drew in surrounding gas, leading to rapid growth and extreme temperatures in their cores. When population 3 stars formed, they acted as the universe's nuclear furnaces. In their hearts, the processes of nuclear fusion began, converting hydrogen into helium and, eventually, forging heavier elements. This stellar alchemy is crucial in understanding the evolution of the universe. As these stars lived their short but intense lives, they produced carbon, oxygen, nitrogen, and other heavy elements necessary for planetary formation and life itself. Some theories suggest that these stars could have been up to several hundred times the mass of our Sun, rapidly burning through their fuel and ending in spectacular supernova explosions. These supernovae not only marked the death of these first stars, but also seeded the universe with heavy elements, enriching the surrounding gas clouds. This process laid the groundwork for the formation of subsequent generations of stars, known as population II stars, which contained heavier elements created by their predecessors. The cycle continued, leading to the diverse array of stars and galaxies we observe today. Understanding population III stars helps astronomers piece together the early cosmic history, providing insight into the formation of galaxies and the eventual development of planets. Though no population III stars have been directly observed yet, astronomers search for their signatures in the light from distant galaxies. By studying the composition of ancient starlight, researchers hope to glimpse the characteristics of these majestic giants and their role in cosmic evolution. The quest for knowledge about population III stars is like peering into a cosmic time machine. It tells us about the universe's infancy and the celestial processes that birthed the elements crucial for life. Each new discovery brings us closer to understanding the intricate tapestry of our universe, weaving together threads of gas, light, and energy that have existed for billions of years. The story of population III stars is not just about the stars themselves, it's about the very foundation of everything we see around us today, a reminder of the brilliance and complexity woven into the fabric of space and time. In the vastness of the universe, there are many wonders, but few are as intriguing as the Great Attractor. Imagine a massive gravitational force, a sort of cosmic magnet, drawing countless galaxies toward itself. This phenomenon is known as the Great Attractor, and it lies in a region of space that is shrouded in mystery and hidden from our direct view by the Milky Way galaxy itself. To understand the Great Attractor, we first need to grasp the scale of our universe. Galaxies are not just scattered randomly, but are organized into clusters and superclusters. The Great Attractor resides within a large supercluster called the Laniakea supercluster, which is home to our Milky Way and many other galaxies. Just as a spider weaves a web to catch its prey, the Great Attractor holds a secret gravitational pull that influences the motion of our galaxy and its neighbors. Located about 150 million light-years away, the Great Attractor is situated in a part of the sky we call the zone of avoidance. This is because interstellar dust and gas within the Milky Way obstruct our view of this mysterious region. Scientists have had to use advanced techniques and indirect observations to infer its existence and properties. One of the remarkable aspects of the Great Attractor is that it appears to be pulling our galaxy, along with countless others, toward itself at an astonishing speed. The gravitational effects of the Great Attractor are a reminder of the interconnectedness of galaxies. This force is not acting alone. It is part of an even larger structure known as the Virgo supercluster, influencing the motion of all nearby galaxies. The interplay of gravity on such grand scales creates a dynamic dance of galaxies, all moving through the cosmic sea. The nature of the Great Attractor raises numerous questions. What exactly is it? Some scientists hypothesize that it could be composed of vast amounts of unseen dark matter, which interacts with normal matter through gravity but remains invisible to our current observational methods. Others believe it might harbor other significant cosmic structures, such as massive galaxy clusters, that contribute to its immense gravitational pull. As we observe the cosmos, the mysteries of the Great Attractor remind us of how much we still have to learn. It stands as a testament to the vast, complex web of forces that shape our universe. With advances in telescope technology and methods of observation, we may one day uncover the true nature of this enigmatic entity, shedding light on the mechanics of the universe and our place within it. Exploring the Great Attractor also compels us to ponder the larger questions of existence. What more lies beyond what we can currently observe? As we continue our cosmic journey, understanding phenomena like the Great Attractor could lead us closer to uncovering the fundamental truths about the universe and its mysterious paths. The dance of galaxies, shaped by forces we are only beginning to grasp, is a reminder of the grandeur that exists beyond our little planet. In the vast, dusty landscape of Mars, scientists have discovered something intriguing, known as Martian blueberries. These small, spherical formations, which measure about a few millimeters in diameter, are captivating not just because of their unique shape, but also because of what they reveal about the planet's history. Imagine walking on a crimson landscape, where the ground is peppered with tiny, round objects that glint in the sunlight. These intriguing spheres are actually iron-rich mineral deposits called hematite, but their appearance and formation tell a much larger story than just their mineral makeup. They hint at a time when water flowed on the Martian surface, enabling the formation of these peculiar structures. To picture how these blueberries came to be, think about molten rock cooling slowly over time. As it began to solidify, various minerals crystallized, including hematite. Over millions of years, as winds whipped across the Martian landscape and the temperature fluctuated, these minerals were shaped into the small, round formations we see today. If you dig a little deeper, you'll find that this process suggests that water must have existed at some point in Mars' history, nurturing an environment quite different from the one we see now. The discovery of Martian blueberries was made by NASA's Opportunity rover in 2004. As it scoured the Meridiani Planum region, it encountered clusters of these spherical formations, leading scientists to hypothesize that they formed in the presence of water. This revelation is significant because it provides insight into the planet's climatic past, suggesting that Mars was once warmer and wetter, potentially allowing for conditions amenable to life. Moreover, these formations are not merely geological curiosities. They raise questions about the potential for ancient microbial life on Mars. If water was prevalent enough to form these blueberries, it stands to reason that life, in some form, may have thrived there. The investigation into Martian blueberries has spurred further exploration of the red planet, fueling our curiosity about what other secrets it holds. The Martian blueberries, with their intriguing origin story, represent much more than simple rocks. They are evidence of a dynamic planet that has undergone drastic changes over billions of years. As we study them, we unravel the complex narrative of Mars, shedding light on past environments and the possibility of life beyond our own world. So, the next time you think about Mars, visualize those tiny blue spheres on the dusty red terrain. They are a reminder of the planet's mysterious past and a beacon of hope for future exploration and discovery. Who knows what other stories await us on this enigmatic neighbor of Earth? As we continue to explore, the quest for knowledge about Mars and its wonders will inspire generations to come. Somewhere in the vastness of our universe lies a region known as the Eridanus Supervoid. Picture this enormous, mysterious expanse, a staggering area of space that is devoid of the galaxies and matter we typically observe. It stands out in a peculiar way, particularly in the context of cosmic microwave background radiation, which is the afterglow of the Big Bang. This cold spot, with its intriguing characteristics, captivates astronomers and astrophysicists alike. The Eridanus Supervoid measures approximately 1 billion light-years across, making it one of the largest known voids in the universe. To put this into perspective, imagine the vastness of space, filled with galaxies, gas, and stars. Now envision a colossal hole where little to no matter exists. This extraordinary emptiness can leave one pondering the nature of our universe and the forces shaping it. In the realm of cosmology, the cosmic microwave background radiation serves as a relic from the early universe, offering a snapshot that tells us about the conditions shortly after the Big Bang. This radiation fills the universe uniformly, with temperature variations here and there. However, the Eridanus Supervoid showcases a distinct cold spot within this radiation, hinting at the fascinating interplay between matter and cosmic structures. So what might cause this massive emptiness? Scientists have proposed that the Eridanus Supervoid is a supervoid, an area much larger than typical voids, which can lead to significant fluctuations in the cosmic microwave background radiation. These fluctuations are theorized to occur due to the gravitational effects of matter surrounding the void. Essentially, a supervoid can bend light from distant galaxies, influencing the way we perceive the universe around it. Imagine for a moment standing in a dense forest, surrounded by the towering trees. The trees are analogous to the galaxies that populate our universe. Now envision an expansive clearing where those trees are absent, the supervoid. The absence of trees not only changes your view, but also the light filtering through. This is a simplified metaphor for what occurs in the Eridanus Supervoid. The lack of matter leads to a drop in the radiation temperature, contrasting with nearby regions filled with galaxies. Exploring the Eridanus Supervoid allows us to delve deep into the mysteries of cosmic evolution. It helps researchers understand how structures formed over billions of years and how the universe's fabric is woven together. Each cold spot and fluctuation adds to the narrative of how galaxies cluster and what role dark matter may play in structuring our cosmos. By studying the Eridanus Supervoid, scientists hope to uncover not only the dynamics of these massive voids, but also what they can reveal about the fundamental nature of our universe. The intricate and vast dance of cosmic forces continues to amaze and inspire as we learn more about these enigmatic cold spots that challenge our understanding of space and matter. Hot Jupiters are an intriguing category of exoplanets that have captured the attention of astronomers and space enthusiasts alike. These gas giants, similar in composition to Jupiter, orbit very close to their stars, often completing a full orbit in just a few days. This close proximity to their host stars results in extreme atmospheric conditions, making them some of the most fascinating objects in the universe. To understand hot Jupiters, it's important to grasp how they differ from the planets in our own solar system. In our solar system, gas giants like Jupiter and Saturn are located far from the Sun, allowing them to maintain cooler temperatures and retain their gaseous atmospheres. However, hot Jupiters challenge this notion because they exist where it would seem impossible for such massive planets to survive. Imagine a colossal planet, made mostly of gas, swirling around its star at a blistering speed, enveloped in temperatures that can exceed 2,000 degrees Fahrenheit. This creates a hostile environment where winds can travel at incredible speeds, sometimes reaching thousands of miles per hour. One of the primary reasons scientists are fascinated by hot Jupiters is that their existence prompts a reevaluation of our understanding of planetary formation and migration. Traditional models suggest that gas giants form far from their stars, where it is cool enough to gather and hold onto gases. However, many hot Jupiters seem to have formed much farther away and then migrated inward over time. This migration raises important questions about the dynamics of planetary systems and the forces at play that allow these massive planets to travel such great distances. Observation techniques have contributed significantly to our knowledge of hot Jupiters. One popular method involves using the transit method, which detects a dip in brightness when a planet passes in front of its star. This has led to the discovery of many hot Jupiters, expanding our understanding of the variety of planetary systems that exist beyond our own. Each discovery adds a piece to the puzzle of planetary systems and how they evolve. Hot Jupiters also offer scientists the exciting opportunity to study their atmospheric compositions. By analyzing the light that filters through these planets' atmospheres during transits, researchers can identify different molecules and elements present, such as water vapor, sodium, or even carbon monoxide. This information can shed light on the processes that govern atmospheric dynamics and thermal structures in extreme environments. The study of hot Jupiters is not just an academic exercise. It has implications for our search for life beyond Earth. Understanding how different planetary systems operate, and why some planets can thrive while others cannot, may eventually inform our models of habitability. As we refine our knowledge of these gas giants, we may unlock secrets to the formation of not just our solar system, but of countless others swirling in the vast universe. As we continue to explore the cosmos, the enigma of hot Jupiter serves as a vivid reminder of how much there is still to learn about our universe and the diverse worlds it contains. In the vast expanse of our atmosphere, there exists a fascinating phenomenon that looks like something straight out of a science fiction tale. High above thunderstorm clouds, in what some might call the boundary between Earth and space, an extraordinary occurrence takes place. These events are known as transient luminous events, and they are often described as resembling ethereal jellyfish gliding gracefully through the sky. Imagine the scene: a darkened sky, lit intermittently by flashes of lightning. Amidst this turmoil, delicate glowing shapes emerge, pulsing and shimmering, much like the gentle undulations of jellyfish in the ocean. These luminous marvels can be seen at altitudes ranging from about 30 to 100 kilometers, well above the turbulent weather below. They are thought to be caused by the interaction of lightning with the atmosphere, creating bursts of energy that ionize the surrounding air. One of the most beautiful types of these transient luminous events is known as a sprite. Sprites are large-scale electrical discharges that happen above thunderstorm clouds, often appearing as vibrant red or blue flashes. Their structure is intricate, resembling jellyfish, with long tendrils flowing downwards, glowing brilliantly against the dark backdrop of the night. It is as if the sky has transformed into an underwater world, with jellyfish floating serenely in a realm where we seldom gaze. Another intriguing phenomenon is the blue jet, which resembles an upward-moving coral reef. Blue jets shoot upwards from the top of thunderclouds and can reach impressive heights, illuminating the sky in streaks of intense blue. These jets are thought to be the result of strong electrical fields during thunderstorms, propelling lifelike shapes into the atmosphere. This dynamic interplay between the forces of nature creates a spectacle that is both awe-inspiring and beautiful. These transient luminous events are fleeting, lasting only mere moments. However, they present a unique opportunity for scientists to study the complex interactions between lightning and the upper atmosphere. Researchers use high-speed cameras and specialized instruments to capture these events, gaining insights into the electrical processes that govern them. With each observation, they piece together a clearer picture of our planet's atmosphere and the phenomena that exist beyond our everyday understanding. Despite being a natural occurrence, the jellyfish-like shapes that flicker momentarily in the sky can evoke a sense of wonder and curiosity about the boundless realms above us. They remind us of the mysteries that still exist in our world and the beauty that can be found in unexpected places. Next time a storm brews, imagine the dance of these luminous jellyfish high above, a delicate ballet of energy and light in the atmospheric ocean. Let the thought of these extraordinary sights spark your imagination and remind you of the wonders that await just beyond the horizon. The universe, vast and enigmatic, holds many wonders that have fascinated scientists and explorers for centuries. One of its most intriguing features is the cosmic web structure. Imagine standing on the edge of a serene lake, watching the gentle ripples spread across the surface. The cosmic web is similar in that it forms a delicate, interconnected tapestry that stretches across the cosmos. At the grandest scale, the universe is not just a random collection of stars and galaxies. Instead, it forms an intricate network of filaments made up of gas, dark matter, and galaxies. Picture this network as a spider's web, where the intersection points are clusters of galaxies, and the strands that stretch between them are vast cosmic filaments. These filaments contain the gravitational pull that draws galaxies toward one another, shaping the universe's structure as we understand it today. One fascinating aspect of the cosmic web is how galaxies are not evenly distributed throughout space, but are often found in clusters and superclusters. This clustering phenomenon can be visualized by considering a bustling city where numerous neighborhoods converge around parks and landmarks. In the cosmos, galaxies gather in similar patterns, forming groups that can contain hundreds or thousands of members. Dark matter plays a crucial role in this cosmic architecture. Although it is invisible and cannot be observed directly, dark matter is believed to account for a significant portion of the universe's total mass. Its gravitational influence is what helps the cosmic web maintain its structure. Think of dark matter as the invisible threads that hold a beautiful tapestry together, providing support and shape even when it's unseen. Additionally, cosmic voids are just as vital to this web-like structure. They are vast, empty regions between the filaments where relatively few galaxies can be found. These voids can be likened to open spaces in a garden, highlighting the beauty of organized growth and connection around them. This contrast between dense clusters and expansive emptiness illustrates the universe's sophisticated design. As we delve deeper into understanding this structure, astronomers utilize advanced tools and telescopes to observe the universe in great detail. By mapping the positions and movements of galaxies, scientists can unveil the dynamics of the cosmic web, opening the door to discoveries about the origins and evolution of our universe. Imagine exploring an ever-changing map, where locations are constantly reshaped by unseen forces, presenting an illustration of cosmic evolution. The cosmic web not only tells us about the distribution of galaxies, but also aids in comprehending the universe's history and future. It inspires wonder, prompting questions about the nature of existence, the fabric of space, and the forces that unveil our reality. With ongoing research and exploration, the mystery of the cosmic web continues to beckon, encouraging us to look up and ponder the vastness that surrounds our small yet significant place in the universe. The Red Rectangle Nebula is a captivating celestial feature located approximately 2,000 light-years away from Earth in the constellation Monoceros. This nebula has a distinct and unusual geometry, which sets it apart from other stellar formations we observe in the universe. Its striking red coloration is a result of the complex interactions between light and the materials present in the nebula, creating a visual spectacle that has puzzled astronomers for years. What makes the Red Rectangle Nebula particularly intriguing is its unique shape. Rather than the typical spherical or elliptical shapes often seen in other nebulae, the red rectangle exhibits a nearly rectangular form. This unusual geometry is a subject of ongoing research, as scientists strive to unravel the mysteries surrounding its formation and evolution. The precise mechanisms that have led to this distinct shape are still being explored, driving interest and curiosity in the astronomical community. The colors within the nebula range from deep crimson to softer pink hues, giving it a magnificent appearance. These vibrant red shades arise mainly due to the presence of hydrogen gas, which emits light in the red spectrum when energized. Additionally, the dust grains interspersed within the nebula contribute to its color, as they scatter light in various ways, enhancing the overall visual effect. Observers often find themselves captivated by the striking contrast of colors, which adds an ethereal quality to the nebula. Surrounding the Red Rectangle Nebula is a fascinating environment. The nebula is part of a larger stellar evolution story, particularly related to the death of a star. It is thought to be the result of a dying star shedding its outer layers, creating beautiful patterns and structures that can be seen in the region surrounding it. As the star expels its materials, the surrounding gas and dust are illuminated by the light emitted from the core, giving rise to the mesmerizing nebula we see today. One of the most extraordinary aspects of the Red Rectangle Nebula is the presence of a binary star system at its center. This pair of stars interacts with each other in a way that contributes to the nebula's irregular shape and dynamics. The gravitational pull between the two stars influences the movement of gas and dust, which in turn affects the shape of the nebula. This interplay of celestial forces introduces a layer of complexity to the formation and behavior of the red rectangle. Scientists continue to study this nebula with ever-evolving technology, using powerful telescopes and advanced imaging techniques to gather more information. As researchers delve deeper into the red rectangle, new discoveries emerge, further enhancing our understanding of the intricate relationships between stars, nebulae, and the evolution of galaxies. Each finding reveals a little more about the universe and our place in it, igniting the curiosity of both seasoned astronomers and those just starting to explore the wonders of the cosmos. The Red Rectangle Nebula stands as a shining example of the beauty and complexity present in the universe, inviting all to gaze upward and wonder at the grandeur of space. Imagine a dark, silent expanse of space, where the stars glimmer faintly in the distance. Amid this cosmic backdrop, there exists a mysterious class of celestial bodies known as rogue planets. These are not your typical planets, the ones that orbit around stars and bask in their light. Instead, rogue planets wander aimlessly through the vastness of the galaxy, untethered and free from the grasp of any particular star. Rogue planets come in various sizes and compositions. Some may resemble the gas giants of our solar system, like Jupiter or Saturn, with swirling clouds and immense pressure in their cores. Others might be rocky and small, akin to Earth or Mars, but without the warmth of a sun to sustain life as we know it. Scientists believe that these planets may have formed around stars in the past, only to be ejected due to gravitational interactions or dynamic events within their solar systems. It's fascinating to think that there could be more rogue planets than there are stars in the universe. Estimates suggest that our galaxy alone could harbor billions of these wandering worlds, a few even drifting close to Earth. This seemingly endless variety of planets raises intriguing questions about their characteristics and potential habitats. Without the warmth of a nearby star, rogue planets face incredibly frigid conditions. Temperatures plummet, creating an environment that seems inhospitable to life. Yet, the absence of a star does not mean complete desolation. Some researchers speculate that rogue planets may still possess subsurface oceans, kept from freezing by the heat generated from their own internal processes. This intriguing possibility suggests that these isolated worlds could hold unique ecosystems, thriving in total darkness. In our quest to explore the universe, rogue planets offer a tantalizing challenge. Their elusive nature makes them difficult to detect and study. However, ongoing advancements in telescope technology are enabling astronomers to identify these wandering planets, allowing us to glimpse their secrets. By studying the infrared radiation emitted by these celestial wanderers, scientists seek to uncover the mysteries of their atmospheres and compositions. Moreover, rogue planets spur the imagination about the possibilities of life beyond our solar system. Could they host unique forms of life, adapted to extreme conditions? What would their ecosystems look like? The answers remain uncertain, yet the very existence of these planets expands our understanding of the potential for life in the universe. Rogue planets are a reminder of the sheer diversity and complexity of the cosmos. They journey through space, bearing silent witness to the dynamic processes that shape galaxies. Each one tells a tale of formation, ejection, and isolation, beckoning us to ponder what lies beyond our familiar surroundings. In the grand narrative of the universe, rogue planets are enigmatic protagonists, their stories woven into the fabric of the cosmic tapestry, waiting for explorers to uncover their secrets. In the vast expanse of our universe, there are countless celestial wonders that invite our curiosity and imagination. Among these is Fomalhaut, a bright star located approximately 25 light-years away in the constellation Pisces Austrinus. Fomalhaut is not just notable for its brilliance in the night sky, but also for its fascinating surrounding features, particularly its dust ring. This stellar belt of debris is reminiscent of our own solar system's Kuiper belt, and it presents a unique opportunity to explore the processes that shape planetary systems. Fomalhaut's dust ring is composed of a diverse array of materials, including ice, dust, and rocky debris. Scientists believe that this ring acts as a reservoir for materials that might eventually coalesce to form new celestial bodies. Just as the Kuiper belt contains remnants from the early solar system, the Kuiper belt, located beyond Neptune, is home to a variety of icy objects, including dwarf planets like Pluto. Similarly, the dust ring around Fomalhaut offers insights into the evolution of planetary systems beyond our own. One of the most intriguing aspects of Fomalhaut's dust ring is the presence of gravitational influences that shape its structure. Just as the gravity of Neptune governs the Kuiper belt, the dynamics of the system around Fomalhaut are affected by the interactions of its planets. Observations reveal a gap in the dust ring, indicating the likely presence of an unseen planet. This invisible body may be exerting gravitational forces, sculpting the ring, and creating a fascinating dynamic analogous to what we see in our solar system. Additionally, the dust ring around Fomalhaut exhibits characteristics such as a lopsided shape and density variations that intrigue astronomers. These features provide clues about the formation and evolution of planetary systems. Variations in density could suggest the presence of additional material being pulled into the ring, or even the remnants of collisions between larger bodies. Through these observations, scientists can piece together a broader narrative about the life cycle of stars and their planetary systems. As we explore Fomalhaut and its surrounding dust ring, we gain valuable insights into the processes that govern the cosmos. The study of these celestial phenomena helps us understand how stars form, evolve, and interact with their environments. Fomalhaut serves as a shining example of our universe's complexity, allowing us a glimpse into the nature of planetary formation that could very well mirror the history of our own solar system. In this grand cosmic tapestry, Fomalhaut's dust ring stands out as a key element that connects our understanding of different star systems. By investigating its characteristics, we can not only expand our knowledge of Fomalhaut itself, but also draw parallels with our own solar journey. The universe is a treasure chest of enigmas waiting to be explored, and Fomalhaut invites us to ponder the mysteries of its dust ring and what lies beyond. In the vast expanse of our universe, some of the most intriguing phenomena occur when black holes collide. These massive entities, formed from the remnants of giant stars, possess gravitational forces so strong that nothing, not even light, can escape their grasp. When two black holes approach each other and eventually merge, they create ripples in the fabric of space-time. This incredible cosmic event is what the Laser Interferometer Gravitational Wave Observatory, known as LIGO, has been designed to observe. LIGO, located in the United States, consists of two large interferometers, one in Louisiana and the other in Washington state, working in unison to detect the faintest vibrations caused by these cosmic events. Each arm of the interferometer stretches about 4 kilometers, and inside, a laser beam travels back and forth. This setup allows scientists to measure incredibly tiny changes in distance, as small as a fraction of the diameter of a proton. When two black holes collide, the energy released is so immense that it creates gravitational waves, which travel across the universe and cause minute disturbances in spacetime. Understanding the merging of black holes is akin to listening for the faint sound of a raindrop falling in a thunderstorm. The gravitational waves provide us with a unique opportunity to study these dark, invisible giants. In 2015, LIGO made history by detecting its first ever gravitational waves, originating from a merger of two black holes located about 1.3 billion light-years away. This groundbreaking discovery confirmed some predictions made by Albert Einstein in his theory of general relativity and opened up a new field of astronomy. Each time LIGO detects these ripples in spacetime, it allows scientists to glean information about the properties of the black holes involved. For instance, they can determine their masses, spins, and even the distance from Earth. Additionally, observing multiple black hole mergers helps researchers understand how these colossal structures form and evolve. It raises exciting questions about the population of black holes in our universe and the environments in which they exist. In a recent observation, LIGO captured a particularly powerful merger involving black holes with significantly different masses. This event has sparked interest in studying asymmetric mergers and their implications for our understanding of black hole formation. Researchers are eager to discover if such collisions are common or rare. Each new event detected not only enhances our knowledge of black holes, but also gives us deeper insights into the fundamental workings of the universe. With ongoing advancements in technology and new observatories being developed around the world, such as Virgo in Europe, the ability to listen to the universe will only improve. Scientists anticipate unveiling even more mysteries hidden within the cosmos, inspiring future generations to look beyond the stars and ponder the vast unknown that surrounds us. As we continue to observe these extraordinary events, we step further into the realm of gravitational wave astronomy, forever changing our perception of the universe and its remarkable dynamics. In the vastness of our universe, among countless stars, there lies a peculiar one known as Tabby's star, or KIC 8,462,852. Discovered by astronomers using the Kepler Space Telescope, it has garnered immense attention not only for its brightness, but for its baffling behavior. Unlike most stars, which have predictable and steady brightness levels, Tabby's star presents irregular dimming patterns that leave scientists scratching their heads. Imagine looking up at the night sky and observing a star that flickers unexpectedly, dimming for days, then weeks, only to brighten again. Such behavior challenges our understanding of stellar phenomena. Researchers first noticed these unusual changes in brightness back in 2015, and since then, many theories have emerged to explain what could be happening. One of the most talked about ideas centers around the possibility that an alien civilization might be constructing gigantic structures around the star. The sheer scale of these hypothetical constructions, often referred to as megastructures, suggests they could harness the star's energy, much like we might build solar panels on Earth. This intriguing possibility has captured the imagination of both scientists and the general public alike, evoking thoughts of advanced extraterrestrial technology. However, before jumping to conclusions about alien involvement, astronomers have explored numerous natural explanations. One theory posits that a swarm of comets could be passing by the star, creating significant dust clouds. As these clouds orbit, they might block the star's light at irregular intervals, resulting in unpredictable dimming. Another suggestion is that large planetary bodies, or even a planet with a peculiar orbit, could be responsible for the drastic changes in brightness. Despite the many hypotheses, none have fully resolved the mystery. This ongoing quest to understand Tabby's star speaks to our insatiable curiosity about the universe. It reminds us of how much we still do not know about the cosmos and the forces at play within it. Every flicker in the night sky can spark questions that lead us to explore further, making discoveries along the way. In 2018, researchers conducted an extensive study using various telescopes across the globe. They aimed to capture more data about Tabby's star to see if they could reveal its secrets. The results from these observations were astonishing, but did not provide the definitive answer the scientific community seeks. Instead, they opened up further discussions and considerations, leaving room for more imaginative interpretations and theories. As we continue to investigate Tabby's star and its intriguing dimming patterns, we gaze into the cosmos and ponder what else lies beyond our current understanding. This star challenges us not only to seek the truth behind its mysteries, but also to reflect on our place within this vast universe. Whether it is a natural phenomenon or something more extraordinary, Tabby's star inspires wonder and curiosity, inviting us to share in the adventure of discovery among the stars. Quasars are some of the most fascinating and luminous objects in the universe. They can outshine entire galaxies, making them stand out in the vastness of space. But what exactly causes these powerful bursts of energy? The answer lies in the supermassive black holes that sit at the centers of distant galaxies. To understand quasars, imagine a giant cosmic energy factory. At the heart of each quasar is a supermassive black hole, which can be millions to billions of times the mass of our Sun. As surrounding gas and dust fall into the black hole, they form an accretion disk, spiraling in closer and closer. This process generates tremendous amounts of energy, much more than we typically see in standard stars. The energy produced by these accretion processes is released in the form of radiation, which can include everything from radio waves to visible light and even X-rays. This powerful emission is what makes quasars visible across immense distances. In fact, quasars can be located billions of light-years away from Earth, and their light travels through space for eons before reaching us. An interesting aspect of quasars is their variability. The brightness of a quasar can change over time, sometimes dramatically. Astronomers have observed that these changes can occur within just a few days or weeks, indicating that the source of the energy output is extremely compact. This rapid variability suggests that the energy comes from a relatively small region around the black hole, giving us clues about the size of the emitting area. Scientists also categorize quasars based on their brightness and the specific wavelengths of light they emit. Some quasars are classified as radio-loud, meaning they emit strong radio waves, while others are radio-quiet. This distinction may be linked to the orientation of the quasar and the amount of material available to feed the black hole, leading to different observational characteristics. Quasars are not just remarkable for their sheer brightness, they also serve as beacons for studying the early universe. Since they can be seen from vast distances, observing quasars provides valuable information about how galaxies evolved over billions of years. Researchers have been able to glean insights into the formation of galaxies, the behavior of dark matter, and the development of large-scale structures. As we continue to explore the cosmos, quasars remain a hot topic of research. They challenge our understanding of astrophysics and the fundamental processes that drive the growth of supermassive black holes. Each quasar represents not only a spectacular display of energy and light, but also a window into the history and evolution of the universe itself. In summary, quasars are remarkable entities fueled by the immense gravitational pull of supermassive black holes, producing energy outputs that illuminate the universe. Their study not only enhances our understanding of these celestial phenomena, but also the very fabric of cosmic history. Triton, one of Neptune's most intriguing moons, has captured the attention of scientists and space enthusiasts alike. What makes Triton particularly fascinating are its cryovolcanoes, which are not your typical volcanoes. Instead of spewing molten rock, these extraordinary geological features release a cocktail of water, ammonia, and other substances. This activity hints at the possibility of a subsurface ocean beneath the icy crust, raising exciting questions about the moon's potential for harboring life. Cryovolcanoes are remarkable in that they operate at much lower temperatures than their terrestrial counterparts. On Earth, volcanoes erupt with lava that can reach thousands of degrees Celsius. In contrast, the eruptions on Triton can occur at frigid temperatures, below the freezing point of water, making for a unique and fascinating spectacle. Scientists believe that when the internal heat generated by Triton's unique geological processes builds up pressure beneath the surface, it can force a mixture of water, ammonia, and possibly other compounds to burst through the ice crust, creating spectacular geysers that can shoot material high into the thin atmosphere. One of the most compelling pieces of evidence for this activity is the so-called, quote, cantaloupe terrain. This region on Triton's surface is characterized by a pockmarked landscape that resembles the texture of a cantaloupe melon. These features are thought to be created by the process of cryovolcanism, as subsurface materials rise and interact with the icy surface, leading to fascinating geological formations. The presence of such textures suggests that Triton is not a stagnant, dead moon, but a dynamic body with ongoing geological processes. Furthermore, the composition of Triton's plumes provides insights into its possible subsurface ocean. The combination of water and ammonia is particularly intriguing because ammonia acts as an antifreeze, which could help liquid water persist beneath the icy shell. This raises the tantalizing possibility that, lurking beneath the frozen exterior, there might be an environment conducive to life. The conditions that allow for cryovolcanoes indicate that Triton is not just a distant satellite. It could be a candidate for astrobiological exploration. Understanding Triton's cryovolcanoes also sheds light on the broader dynamics of our solar system's icy bodies. The processes observed on Triton may be similar to those found on other moons, such as Enceladus or Europa, where scientists also suspect the existence of subsurface oceans. By studying these peculiar geological features, we can gain valuable insights into the potential for life beyond Earth. In summary, Triton's cryovolcanoes serve as a captivating reminder of the dynamic nature of our universe. They bridge the gap between the cold, distant worlds we perceive and the active, changing environments that may hold secrets waiting to be revealed. As we continue to explore and understand Triton and its cryovolcanic activity, we inch closer to unraveling the mysteries of our solar system and the potential for life beyond our planet. This icy moon is not only a beautiful part of Neptune's family, but also a treasure trove of information about the possibilities that exist in the vastness of space. Fast radio bursts, often abbreviated as FRBs, are a fascinating phenomenon in the realm of astronomy. Discovered relatively recently, these powerful bursts of radio waves have captured the attention of scientists and enthusiasts alike due to their mysterious nature and the questions they raise about our universe. What exactly are these bursts? Imagine standing in a vast, quiet field when suddenly you hear a loud clap of thunder. This noise, brief and intense, leaves you wondering about the storm that must have caused it. Fast radio bursts are somewhat analogous to this experience, but instead of thunder, they are pulses of radio waves, each lasting just a few milliseconds. Despite their fleeting nature, they can release as much energy in that short span as our sun does in an entire day. The first FRB was detected in 2007, and since then, a myriad of these bursts has been identified. They originate from deep space, often billions of light years away from Earth. This gives scientists a glimpse into the distant past, revealing information about cosmic events that occurred long ago. The challenge lies in their unpredictability. They don't follow a regular pattern, making them hard to study. Some have even been observed repeating, leading to further intrigue about their source and nature. The possible origins of FRBs are still a topic of intense research. Some theories propose that they could be linked to neutron stars, particularly those known as magnetars. These incredibly dense remnants of massive stars possess intense magnetic fields and might emit energy bursts due to their extreme conditions. Imagine a pinball machine where a fast-moving ball hits bumpers, creating a series of energetic blips. In a similar vein, a magnetar could release bursts of energy as it spins and changes activity levels. Another explanation for these bursts involves exotic phenomena such as black holes, or even interactions with theoretical cosmic strings. Picture a massive black hole consuming material at high speeds and creating whirlwinds of energy and radiation. These interactions might manifest as rapid bursts, crossing vast distances through the cosmos to land in our telescopes. The intrigue surrounding FRBs does not stop at their origins. In 2020, astronomers detected an FRB coming from a galaxy similar to our Milky Way, which raised even more questions. What could these bursts tell us about the environments of different galaxies? Could they point to the existence of advanced civilizations harnessing massive energy resources? The excitement and speculation are endless as each discovery sheds light on how our universe operates. As scientists continue to monitor the skies, they are employing cutting-edge technology to capture and analyze these fleeting signals. What once was a curious discovery has now sparked global collaboration among astronomers, each striving to unlock the secrets held within these cosmic phenomena. With every burst detected, we inch closer to unraveling the mysteries of the universe and understanding our place within it. The journey into the depths of space holds endless possibilities, and fast radio bursts may just be a key that unlocks a new chapter in our understanding of the cosmos. Imagine a world where the temperatures soar higher than you could ever imagine, where the air is thick and heavy, almost suffocating. This is Venus, often referred to as Earth's twin, yet its conditions are anything but friendly. Venus presents a unique case known as the Runaway greenhouse effect, a phenomenon that has created one of the harshest environments in our solar system. To understand this, let's first delve into the basic idea of a greenhouse effect. On Earth, certain gases in the atmosphere trap the sun's warmth, creating a cozy environment that supports life. However, on Venus, this process has spiraled out of control. The atmosphere of Venus is composed of over 96% carbon dioxide, with clouds of sulfuric acid, creating a thick layer that retains heat efficiently. The story began millions of years ago when scientists believed Venus was more Earth-like, potentially with oceans and a milder climate. However, a series of events transformed this lush world into a scorching hot desert. As the sun's energy warmed the planet, some of the water would evaporate, increasing the concentration of greenhouse gases in the atmosphere. In turn, these gases trapped even more heat, creating a feedback loop that escalated the temperatures. Today, temperatures on Venus reach around 900 degrees Fahrenheit, hot enough to melt lead. Imagine standing on a surface where the heat feels as if it is penetrating your very bones, turning everything around you into molten rock. This extreme heat creates a surface pressure 92 times greater than Earth's, equivalent to being nearly a mile beneath the ocean. This means that even the most durable of spacecraft must be specifically designed to withstand such punishing conditions. Clouds on Venus are not fluffy and beautiful like those on Earth. Instead, they are thick and oppressive, composed of sulfuric acid droplets. This creates a toxic environment where sunlight is filtered and scattered in such a way that the planet remains shrouded in a permanent haze. If you could rise above this blanket, the view would reveal a sun blazed against a backdrop of a thick, yellowish sky. The geology of Venus is equally fascinating. The surface is dotted with vast volcanic plains, massive volcanoes, and mountain ranges. Some scientists believe that Venus is still geologically active, possibly hinting at processes similar to those on Earth. Despite appearances, this planet is dynamic, with features that tell stories of intense volcanic activity and tectonic movement. The runaway greenhouse effect on Venus serves as a cautionary tale. It reminds us of the delicate balance that exists within our own atmosphere and the consequences of excessive greenhouse gas emissions. Observations from missions such as NASA's Magellan and the more recent European Space Agency's Akatsuki have provided valuable insights into this mesmerizing yet hostile world. In every corner of our solar system, planets like Venus teach us lessons about climate, evolution, and the potential futures awaiting different worlds. Understanding these other planets deepens our appreciation of Earth and the intricate balance that sustains us. As we explore the mysteries of Venus, we venture into the wonders of our universe, revealing the extremes and complexities that exist among the stars. The Great Red Spot is one of the most fascinating phenomena in our solar system. Located on Jupiter, it is a colossal storm that has been raging for centuries, and it is so large that it could easily contain 2 or even 3 Earths within its swirling clouds. The sight of this enormous storm, with its reddish hue standing out against the deep orange and brown bands of Jupiter's atmosphere, is a spectacular cosmic feature. One of the most intriguing aspects of the Great Red Spot is its longevity. It has been observed since at least the 17th century, with records dating back to 1830. The persistence of this storm raises questions about the mechanisms that keep it going. Unlike storms on Earth, which are driven primarily by variations in temperature and moisture, the Great Red Spot operates under conditions that are vastly different. Jupiter, being a gas giant, has a thick atmosphere composed mainly of hydrogen and helium, and it lacks a solid surface. The storm is believed to be fueled by the planet's internal heat and the complex interactions of its atmospheric layers. This eternal whirlwind is maintained without any of the dissipating factors that typically weaken storms on our planet. Scientists have noted that the Great Red Spot has been shrinking in recent years, but it remains a colossal force, measuring over 16,000 kilometers across at its widest point. The color of the Great Red Spot is another captivating element of its story. The rich crimson and orange tones of the storm are thought to arise from the chemical composition of Jupiter's atmosphere. Various compounds, such as phosphine and ammonia, react in unexpected ways when exposed to ultraviolet light from the sun, generating distinct colors. However, the precise mixture of substances and how they contribute to the vibrant hues is still an area of research and debate among scientists. Despite the available data, many enigmas remain regarding the Great Red Spot, including why it has lasted so long and what changes may occur in the future. Scientists are using advanced telescopes and spacecraft, such as the Juno mission, to gather detailed information about this massive storm. Observations have revealed that the Great Red Spot is not only enormous but also dynamic, with ever-changing wind patterns and intricate cloud formations. In this ever-evolving atmosphere, storms can vary in size, shape, and intensity. The Great Red Spot's complexity exemplifies the chaotic nature of planetary weather systems. As researchers continue to study this great marvel of our solar system, they hope to unlock the secrets it hides and gain deeper insights into Jupiter's history and atmospheric processes. The Great Red Spot remains a symbol of the mysteries that still exist in our understanding of the universe, a vivid reminder of the powers of nature in the vast expanse of space. Europa, one of Jupiter's most fascinating moons, has captured the interest of scientists and space enthusiasts alike. It is not simply a frozen world. Beneath its icy surface lies an environment that may harbor the building blocks for life. One of the most intriguing phenomena associated with Europa is its ice geysers, which send plumes of water vapor shooting into space. Imagine a vast, frozen surface stretching out as far as the eye can see, with a crust of ice several miles thick. Beneath this ice shell, researchers believe there exists a deep ocean, warmed by the gravitational tug-of-war with Jupiter. This dynamic interaction is thought to create heat, leading to geological activity that manifests itself as geysers. These geysers have been detected by various spacecraft, including the Galileo orbiter, which observed hints of these plumes back in the late 1990s. More recently, data from the Hubble Space Telescope revealed more compelling evidence. Bursts of water vapor were seen erupting from Europa's surface, rising upwards like a fountain and forming elongated plumes that can reach kilometers in height. The significance of these geysers cannot be overstated. They not only provide evidence of a subsurface ocean, but also present a unique opportunity for exploration. As the plumes shoot water vapor and possibly organic materials into space, they become accessible to study without having to land on Europa itself. This is akin to a cosmic fountain, where scientists can analyze the water and gain insights into the moon's hidden ocean and potential habitability. The composition of these geysers is of great interest. Studies suggest that the water is likely salty, indicating interaction with Europa's rocky mantle underneath the ice. The presence of salts, along with organic molecules, raises the possibility of environments that could support life, even deeper beneath the icy crust. Think about the potential microbial ecosystems thriving in complete darkness, nourished by the chemicals from the moon's interior. As we look to the future, missions like NASA's Europa Clipper are set to explore this moon further. Equipped with advanced instruments, the spacecraft will fly by Europa, conducting detailed analyses of the geysers and the surface. This mission aims to uncover whether Europa's ocean has the right conditions for life and what secrets lie beneath its icy exterior. In many ways, Europa represents a tantalizing mystery in our solar system. Its ice geysers are just the beginning of a deeper exploration of a world that may not only be geologically active, but also alive in a way we have yet to comprehend. As we study these remarkable plumes, we edge closer to answering one of humanity's most profound questions: are we alone in the universe? The journey into the hidden depths of Europa is just beginning, and the wonders that await us are boundless. The moon, our closest celestial neighbor, has always fascinated humankind. One of the more intriguing phenomena associated with its surface is known as ephemeral lunar transients. These are short-lived changes in brightness that appear and disappear on the moon's surface, without any clear explanation. Though these occurrences have perplexed scientists for decades, they offer a captivating insight into the lunar environment. Imagine gazing up at the moon on a clear night, and suddenly you notice a brief flash of light. This is not just a trick of your imagination. Rather, it could be one of these ephemeral transients. Reported observations date back to the mid-20th century, with astronomers documenting bright spots and dark patches that vanish in mere hours or even minutes. Various telescopes and lunar missions have recorded these mysterious changes, sparking curiosity and debate among scientists. One of the notable characteristics of these transients is their unpredictable nature. Some events have been captured when the moon was full, while others occurred during a new moon phase. This randomness makes it challenging to study them consistently. The transient events can also vary widely in brightness and appearance, with some reportedly appearing as bright spots, while others could manifest as subtle color changes. Theories abound regarding the causes of these transients. Some researchers suggest that they could arise from geological activity on the moon, such as moonquakes or volcanic eruptions. This theory aligns with the notion that the moon is not as geologically inactive as once thought. Other hypotheses propose that these bright phenomena may be caused by the release of gas or the exposure of previously hidden materials on the lunar surface. Additionally, impacts from micrometeorites have been theorized to play a role. When small celestial objects collide with the moon, they can disturb the lunar dust, resulting in temporary changes in surface reflectivity. This impact-induced phenomenon could explain why some transient events seem to have a direct correlation with meteor showers observed from Earth. The lack of definitive explanations means that researchers are continually investigating these lunar enigmas. Some scientists have even utilized sophisticated imaging technology to capture real-time phenomena. Lunar missions and telescopes are now equipped with advanced sensors to monitor changes over time, providing hope that future studies may unlock the mystery behind these brief, fascinating events. As we look back at the Moon, remember that beneath its serene appearance lies a dynamic environment, experiencing changes that challenge our understanding. The ephemeral lunar transients serve as a reminder of how much there still is to learn about our nearest neighbor. While the exact reasons for these changes remain elusive, they add an element of mystery to our perception of space, urging us to keep looking up and exploring the wonders of the universe. The Voyager probes, Voyager 1 and Voyager 2, are remarkable achievements in human exploration. Launched in 1977, they were initially designed for the primary mission of exploring the outer planets of our solar system, such as Jupiter and Saturn. However, their journey took them far beyond what their creators could have imagined. Voyager 1, which is now the most distant human-made object from Earth, reached the edge of our solar system in 2012, becoming the first spacecraft to enter interstellar space. This achievement marks a significant milestone in human exploration, as it allows us to gather invaluable data about an area never before reached by humanity. Voyager 2 followed suit, crossing into interstellar space in 2018, making it the second probe to cross this cosmic boundary. As both Voyager probes journey beyond the heliosphere, they provide scientists with critical information about the region where the solar wind slows down and eventually ceases to have a significant effect, giving way to the interstellar medium. This area, known as the Heliosphere Boundary, serves as a protective bubble around our solar system, created by the sun's solar wind. One of the fascinating aspects of the Voyager missions is how they have continued to send back data long after their original missions were completed. The probes are equipped with instruments that measure magnetic fields, cosmic rays, and the plasma density in the interstellar medium. These measurements help to improve our understanding of the environment outside our solar system and provide insights into the interactions between solar and interstellar winds. Imagine the journey these spacecraft have undertaken. They are traveling at speeds of over 38,000 miles per hour, carrying with them not just instruments, but also a message about humanity. Each probe carries a golden record containing sounds and images from Earth. This includes greetings in multiple languages, music from different cultures, and images depicting human life, making these probes messengers of our existence to potential extraterrestrial civilizations. As Voyager continues its journey, it faces the challenges of extreme temperatures and the vast emptiness of space. Scientists anticipate that it will continue to send valuable data for years to come, providing insights that could reshape our understanding of the universe. One day, Voyager will reach the Oort cloud, a vast region of icy bodies that surrounds the solar system, further enhancing our knowledge of the fringes of our cosmic neighborhood. The Voyager probes symbolize the spirit of exploration and curiosity that defines humanity. They remind us of the importance of pushing boundaries and the thirst for knowledge that drives us. By venturing into interstellar space, these spacecraft have not only expanded our understanding of the cosmos, but have also left an enduring legacy of exploration for future generations. Each transmission from Voyager enriches our understanding of the universe and reinforces the idea that there is so much more to discover beyond our planet. The universe is filled with mysteries, and one of the most fascinating is the concept of white holes. Imagine a space-time region that acts as the opposite of a black hole. While black holes are known for their powerful gravitational pull, capable of drawing in everything around them, white holes hypothetically expel matter and energy, making them impossible to enter from the outside. To better understand white holes, consider how black holes function. When a star runs out of fuel, it can collapse under its own gravity, leading to the creation of a black hole. Once something crosses the event horizon of a black hole, it cannot escape, disappearing from our universe. In contrast, a white hole represents the outward flow of material, as if it were a cosmic fountain, projecting matter into the universe rather than sucking it in. Theoretical physics describes these white holes using general relativity, Einstein's framework for understanding gravity. According to this theory, a black hole is a point in space where the gravitational field becomes so strong that not even light can escape. A white hole, therefore, would be a region of space with gravitational properties that force everything to flow outwards. Yet, the intriguing nature of white holes isn't limited to their theoretical existence alone. They challenge our understanding of the cosmos, provoking thought about the life cycle of matter in the universe. Imagine if black holes serve as storage for mass and energy, while white holes are the cosmic release valves. This scenario stirs the question, what happens to the matter swallowed by black holes? Could it eventually emerge through a white hole, perhaps in another part of the universe, or even in an alternate dimension? Additionally, the concept connects to ideas like the Big Bang. Some scientists theorize that the Big Bang could have been a gigantic white hole event, an explosive outflow of energy and matter that marked the beginning of our universe. This fascinating connection reveals a possible continuity where black holes and white holes intermingle, creating a cycle of cosmic regeneration. Although no observational evidence of white holes exists, their theoretical implications are captivating. They offer a glimpse into the possibilities that the universe might hold, suggesting hidden relationships between seemingly opposite phenomena. Throughout the cosmos, the interplay of black and white holes could point toward deeper truths about our reality, opening doors to new realms of understanding. In exploring these concepts further, one might find wonderment in the symmetry of the universe. For every force that pulls us in, there may be an equal and opposite force that pushes us out. This delicate balance might be woven into the fabric of space-time itself, where black holes and white holes dance on the edge of existence, enriching the tapestry of the cosmos. As we ponder these celestial curiosities, we deepen our knowledge of the universe's intricate design. Whether white holes are mere theoretical constructs or indicative of hidden cosmic mechanisms, they encourage us to keep looking up, sparking curiosity and the desire to explore the great unknown. The universe is vast, and our understanding of it is ever evolving, pushing us to imagine the extraordinary possibilities that lie beyond our current grasp. Imagine standing under a vast night sky, surrounded by stars. Now, imagine for a moment that you receive a mysterious signal, one that echoes through the cosmos, with an intensity far beyond what scientists anticipated. This signal, known as the space roar, has intrigued astronomers and astrophysicists alike since its discovery. The space roar is not just a faint whisper of the universe. It is a powerful, unexplained radio signal that resonates with a richness and volume that seems to defy the known laws of cosmic sounds. Detected by advanced radio telescopes, this unusual signal has left scientists scratching their heads. We've come to expect certain levels of cosmic noise, produced by phenomena such as pulsars, quasars, and the remnants of ancient supernovae. However, the space roar has managed to rise above the expected celestial symphony, creating a crescendo that captures attention in a way that few cosmic phenomena can. Scientists first stumbled upon this phenomenon while analyzing data collected from the first deep-field radio survey. They were prepared to hear the usual sounds, the gentle hum of the universe's light flickering in the void, but the space roar stood out. It was as if someone turned up the volume on the nighttime canvas of the universe, amplifying its mysterious melody. To understand this further, consider the way sounds propagate through different environments. On Earth, if you were placed in a vast, empty canyon, your voice can carry with incredible clarity. In the same way, the space roar seems to reflect travels through the immense expanses of the universe, echoing off cosmic structures we are only beginning to comprehend. What is particularly fascinating about this signal is the sheer volume. While the detection of weak radio signals from distant galaxies follows the expected patterns, the space roar has an energetic punch. Its strength suggests that it originates from much closer sources than initially imagined, possibly from within our own cosmic neighborhood. Is it a new breed of astronomical event, a signature from previously unknown celestial objects? The scientific community is eager to uncover the truth. Theories abound regarding its origin. Some researchers theorize that it may be the collective noise generated by many galaxies, or black holes interacting and colliding in a dramatic ballet of physics. Others speculate about the possibility of unknown cosmic events that challenge our understanding of the universe's standard behavior. It's this very uncertainty that keeps scientists curious and engaged in their pursuit of knowledge. The excitement surrounding the space roar serves as a reminder of the vast mysteries still waiting to be revealed in the universe. Each breakthrough in understanding brings us closer to answering foundational questions about how the cosmos operates. The roar of space continues to inspire not just scientists, but anyone who gazes up in wonder at the cosmos, reminding us how much there is left to explore and understand in the depths of the universe. With every discovery, we step further into the unknown, unveiling the secrets hidden among the stars. The Kuiper belt is a fascinating region of our solar system that lies just beyond the orbit of Neptune. Imagine a vast, icy expanse stretching out for billions of kilometers, filled with a myriad of small celestial bodies. This area is like a cosmic treasure chest, containing remnants from the early days of our solar system. It serves as a window into our past, offering clues about how planets and other celestial objects came to be. The Kuiper Belt is home to many intriguing structures, including dwarf planets such as Pluto, Haumea, and Makemake. Pluto was once classified as the 9th planet of our solar system, but was redefined as a dwarf planet in 2006. The debate around Pluto's status has sparked much interest and curiosity about this distant world. Pluto is not alone. It resides in a neighborhood filled with icy bodies, some larger, some smaller, all contributing to our understanding of this unique region. These icy worlds are primarily composed of frozen gases, such as methane, ammonia, and water ice. The temperatures in the Kuiper Belt are incredibly low, often reaching -200 degrees Celsius. This extreme cold preserves the ancient materials from the time when the solar system was forming, making these objects like time capsules that scientists are eager to explore. One of the most significant missions to the Kuiper Belt was NASA's New Horizons, which conducted a historic flyby of Pluto in 2015. This mission drastically changed our understanding of Pluto and its moons, revealing complex geology, frozen mountains, and even vast plains. The data collected from New Horizons opened up a whole new field of study focused on the Kuiper Belt, leading scientists to rethink what they know about these distant bodies. Beyond Pluto, the Kuiper Belt continues to unfold its mysteries. The objects in this region can vary greatly in size and shape, with some being just a few kilometers across, while others can be hundreds of kilometers wide. Their orbits can also be quite eccentric, meaning they do not follow a perfectly circular path around the Sun, which adds complexity to our studies. Researchers are eager to identify more about these distant objects. They often use telescopes to detect new Kuiper Belt objects, or KBOs, many of which remain unnamed and little known. Each new discovery contributes to our understanding of the solar system's formation and evolution. The exploration of the Kuiper Belt is akin to unwinding a cosmic mystery, where every new finding reveals a piece of the grand puzzle of our solar system. As we continue to study this remote region, the potential for groundbreaking discoveries is immense. From learning about the building blocks of planets to understanding more about the origins of water on Earth, the Kuiper Belt remains an essential focus in the field of astronomy. Discoveries in this icy realm can challenge our thoughts about where we fit in the grand tapestry of the universe. Scientists are just beginning to scratch the surface of what the Kuiper Belt has to offer, and with each new mission and observation, the stories of these distant worlds become ever more compelling. Galactic cannibalism is a fascinating phenomenon that occurs in the vast expanse of our universe. Imagine, if you will, that galaxies are like great cosmic cities. They each have their own unique characteristics, populations, and histories. Sometimes, larger galaxies engage in a process akin to cannibalism, where they absorb smaller galaxies, reshaping the cosmic landscape in remarkable ways. When a large galaxy approaches a smaller neighbor, the gravitational forces at play come into action. As the larger galaxy's immense mass draws the smaller galaxy closer, a dramatic cosmic dance begins. Tidal forces stretch and pull at the smaller galaxy, often distorting its shape. These interactions can stir up a flurry of activity in both galaxies, sparking the birth of new stars and triggering the formation of intricate nebulae. For instance, imagine the Milky Way, our own galaxy, having a meal. Picture it reaching out to a smaller galaxy, perhaps one similar to the Magellanic Clouds, which are satellite galaxies of the Milky Way. As the Milky Way pulls these smaller structures closer, a cascade of events unfolds. Stars from the smaller galaxy get drawn into the gravitational embrace of the Milky Way, merging their fates. This exchange not only alters the smaller galaxy, but also influences the larger one, adding new stars and material to its already vast landscape. As a result of galactic cannibalism, the structure of the larger galaxy may be transformed. It may take on new spiral arms or increase its brightness as fresh stars ignite in its core. Meanwhile, the smaller galaxy experiences a very different fate. It loses its identity, its stars and gas slowly becoming part of the larger galaxy. This interaction can often lead to dramatic changes in the smaller galaxy's star formation activity, influencing its evolution for billions of years. The aftermath of this cosmic event can often be seen in the form of tidal tails, streams of stars, and gas that trail away from the smaller galaxy, a reminder of its once distinct existence. Over time, the larger galaxy becomes richer and more complex, weaving in elements from the galaxies it has consumed. Studies of galactic cannibalism provide astronomers with valuable insights into the history and evolution of the universe. By observing these interactions, scientists can piece together a cosmic timeline that reveals how galaxies evolve, grow, and interact over billions of years. Each act of galactic cannibalism is a chapter in a grand story, illustrating the ever-changing dynamics of the cosmos. In the end, our universe is a tapestry woven from the fates of countless galaxies, each contributing to the magnificent story of our cosmic environment. The dance of galactic cannibalism remains one of the most captivating aspects of this ongoing tale, revealing the intricate relationships between galaxies and the forces that shape their destinies. So, the next time you gaze up at the stars, remember that these vast structures are not just stationary, they are alive with history, transformation, and connection. Abell 1689 is a fascinating galaxy cluster located about 2.2 billion light-years away from Earth. What sets this cluster apart is its remarkable ability to bend light from objects that lie behind it, a phenomenon known as gravitational lensing. This effect is a direct demonstration of one of the key principles of Einstein's theory of general relativity. To understand this concept, consider how light travels through space. Generally, light moves in straight lines, but when it encounters a massive object, such as a galaxy cluster, the gravity of that object can warp the fabric of space around it. Imagine placing a heavy ball on a stretched sheet of rubber. The ball creates a dip in the sheet, and if you roll a smaller ball near it, the smaller ball will curve towards the heavier one. Similarly, the intense gravitational field of Abell 1689 acts like a giant cosmic lens, bending and distorting the light from galaxies located behind it. As light from these distant galaxies passes by Abell 1689, it follows the curves created by the gravity of the cluster. This bending of light allows astronomers to observe galaxies that would otherwise be too faint or far away to see. In fact, this cluster has allowed scientists to detect objects that are billions of light-years distant and even study their properties. Abell 1689 itself is a massive collection of hundreds of galaxies, with a total mass that is estimated to be several times that of the Milky Way. This mass is not just from the visible matter, such as stars and gas, but also includes a significant amount of dark matter, which does not emit light and cannot be seen directly. Dark matter is thought to account for the majority of the mass in the universe, and its presence can be inferred from the way it influences the motion of galaxies and light around it. Many images of Abell 1689 showcase the stunning arcs and distortions of light that result from gravitational lensing. These remarkable visual effects are not just beautiful, they also provide vital information about the distribution of both ordinary and dark matter within the cluster. By studying how light bends around Abell 1689, scientists can map the gravitational field of the cluster and gain deeper insights into the nature of the universe. Gravitational lensing also opens up new avenues for research in cosmology. In addition to revealing details about distant galaxies, it can help measure the expansion rate of the universe and provide clues about its overall composition. This phenomenon reflects the interconnectedness of space and time, showcasing how massive objects can influence light and the way we perceive the cosmos. In summary, Abell 1689 stands as a striking testament to the wonders of our universe, illustrating the profound effects of gravity on light. The bending of light around such a massive galaxy cluster not only uplifts our understanding of Einstein's theories, but also enriches our appreciation for the complexity and beauty of the cosmos. Through this cosmic lens, we gain a clearer view of the distant galaxies and the mysterious dark matter that permeates our universe. The sun is a familiar sight in our sky, a brilliant ball of light and heat that sustains life on Earth. But have you ever wondered what will become of our sun in the far future? To understand this, we need to delve into the fascinating life cycle of stars, particularly our own. Currently, the sun is in a stable phase known as the main sequence, where it has spent about 4.6 billion years of its life. During this stage, it fuses hydrogen into helium at its core, producing the energy that powers it. This process creates an outward pressure that balances the gravitational pull, trying to compress the sun into an even denser object. However, like all stars, the sun has a limited supply of fuel. In approximately 5 billion years, it will exhaust its hydrogen fuel. When this happens, the core will contract under gravity, which increases the core's temperature. The outer layers of the sun will respond dramatically. Instead of continuing in a stable state, These layers will expand immensely, transforming the Sun into a red giant. Imagine a fiery balloon swelling and growing, engulfing inner planets, possibly including Earth. During this red giant phase, which will last several 100 million years, the Sun will not be the same. It will be larger and cooler on the surface, but much brighter overall. As it expands, it will shed a significant amount of its outer material, creating a beautiful cloud of gas and dust known as a planetary nebula. This cosmic spectacle would be a sight to behold, with vibrant colors and intricate patterns, lighting up the surroundings as it winds its way through space. As the outer layers drift off, the core remains. Eventually, this core will be left with no further fuel for nuclear fusion. With no pressure to counteract gravity's pull, it will collapse into a white dwarf. Picture a small, dense star about the size of Earth but incredibly heavy, as it retains a mass similar to that of the Sun itself. This white dwarf will not shine as brightly as it once did, but will still emit a soft glow from the residual heat. Over trillions of years, this white dwarf will gradually cool down, fading into the darkness of space. It will become a cold, dark stellar remnant, a ghost of the vibrant star it once was. The fascinating journey of the Sun reminds us of the dynamic and ever-changing nature of the universe. This cosmic evolution will continue, with our Sun serving as just one of countless stars participating in the grand tapestry of the cosmos. Each phase of a star's life cycle contributes to the creation of new elements, eventually playing a vital role in the formation of planets, other stars, and even life itself. So the next time you gaze up at the Sun, remember that it is not a static object, but a dynamic star with an incredible story that stretches far beyond our lifetimes. The future of the Sun is a testament to the incredible forces at work in our universe, a reminder that even the most familiar sights have fascinating journeys ahead. The Fermi Paradox is an intriguing concept that sparks the imagination and raises profound questions about our place in the universe. It originates from a simple question posed by physicist Enrico Fermi, who famously asked, "Where is everybody?" This wonder arises from the astonishing scale of the cosmos and the probability of life elsewhere beyond Earth. Given the vast number of stars, many of which have planets in their orbit, it seems reasonable to assume that intelligent civilizations could exist somewhere in the universe. For perspective, the Milky Way galaxy alone contains around 100 billion stars. Many of these stars have their own planetary systems, making it a reasonable assumption that there are potentially trillions of planets out there. With such a multitude of possibilities, the idea that Earth is the only planet with intelligent life seems improbable. In fact, scientists have calculated that there could be millions of Earth-like planets in our galaxy alone, which raises significant questions about why we haven't encountered evidence of their inhabitants. Despite the scientific community's confidence in the potential for life, we find ourselves searching the skies, still waiting for a signal or a sign. Various theories attempt to explain this paradox. One suggestion is that intelligent civilizations tend to destroy themselves before they can venture into the cosmos. Perhaps self-destruction through technological advancement, resource depletion, or warfare is a common fate for intelligent life. Another theory is based on the idea that civilizations are exceedingly rare and that the window of time during which they can communicate or explore is significantly short. This means that even if intelligent life arises, it may not overlap with our own time. By the time they develop technology capable of interstellar communication, they could already be gone. Additionally, some propose that advanced civilizations are intentionally avoiding contact with us. This idea leans on the notion of a zoo hypothesis, suggesting that extraterrestrial civilizations might be observing us from afar, much like zookeepers watching animals in a natural habitat, allowing us to evolve without interference. Furthermore, we might simply be overlooking the signs. Our current understanding of life and communication is rooted in what we know on Earth. Extraterrestrial life might use forms of communication we cannot fathom or detect. Their technology might be so advanced or so different from our own that we fail to recognize their attempts at communication. There is also a possibility that intelligent life forms exist and have advanced far beyond what we can imagine, but they choose to remain hidden. This supposition raises fascinating ideas about the nature of existence and whether there are reasons we have yet to comprehend. In conclusion, the Fermi Paradox serves not only as a perplexing conundrum, but also as a catalyst for exploration and discovery. It invites us to ask deeper questions about the universe, the nature of life, and our role within this magnificent expanse. The search for answers to these questions continues to inspire scientists, astronomers, and dreamers alike as we ponder the mysteries of what lies beyond our world. The Indigo Cross of Centaurus is a captivating sight nestled within the magnificent Centaurus constellation. This prominent arrangement of young stars showcases the beauty of the night sky, especially when viewed from locations with minimal light pollution. As you gaze up into the vast expanse, the Indigo Cross stands out, drawing the eye toward its unique formation. Situated in one of the richest star fields in the Milky Way, the stars that make up the Indigo Cross are relatively young, characterized by their bright blue and white hues. These colors indicate that they are hot, massive stars, still in the early stages of their stellar life cycle. The vibrant tones are a stark contrast to the deeper, darker voids of space surrounding them, creating an extraordinary visual spectacle. One of the primary stars in this remarkable arrangement is Alpha Centauri, which is one of the closest star systems to Earth. This system is composed of 3 stars, including Proxima Centauri, which is known for having at least one exoplanet orbiting in its habitable zone. The fact that these celestial bodies are situated just a stone's throw away, in cosmic terms, invites exciting possibilities about the secrets they might hold, even if they remain distant from human reach. When you look at the Indigo Cross, it serves as a reminder of the incredible processes that occur in the universe. Each star you see has a story, from its fiery birth in massive clouds of gas and dust, to the journey it undertakes through time and space. They are a testament to the dynamic life cycle of stars, as some will eventually explode in supernovae, enriching the surrounding cosmos with heavy elements, while others may end their lives as quiet white dwarfs. As you observe this beautiful star formation, allow your imagination to wander through the universe's intricacies. Picture the vast stretches of time it took for these stars to form and shine. Contemplate how civilizations across millennia have looked up at the same stars, perhaps marveling at their brilliance and weaving stories around their shapes and positions. The Indigo Cross of Centaurus is not just a collection of stars, but also a bridge connecting human curiosity with the awe of the cosmos. Whether you are an amateur stargazer or a seasoned astronomer, this striking pattern invites you to explore the stories of the universe written in the language of light. As you trace the lines of this cross with your eyes, let the wonder of the infinite universe envelop you, inspiring dreams and reflections that transcend the ordinary. The beauty of the Indigo Cross lies not only in its vivid stars, but in the endless possibilities that arise from gazing into the night sky. Jupiter's moon Io is a fascinating and dynamic world, renowned for being the most volcanically active body in our solar system. A key feature of this moon is its sulfur volcanoes, which create dramatic plumes that can be seen erupting into space. The landscape of Io is unlike any other, marked by lava lakes and vast plains covered in colorful sulfur deposits. The intense volcanic activity on Io can be attributed primarily to the gravitational forces exerted by Jupiter. Io is in a unique orbital dance with its neighboring moons, Europa and Ganymede. This interaction generates significant tidal heating as Io's shape is distorted, causing the interior to remain molten. The constant ebb and flow of these gravitational forces prevent Io from cooling down, resulting in a world that seems to be alive with movement. When a sulfur volcano erupts, it ejects material into the atmosphere at astonishing heights, sometimes reaching 300 kilometers or more. These plumes can contain a mix of sulfur and sulfur dioxide, creating a colorful display that may even be visible from space. When observed close-up, the surface of Io is resplendent with hues of yellow, orange, and red, painting a picture of a volcanic landscape in constant flux. One of the most famous volcanoes on Io is known as Pele. This volcano is particularly remarkable due to its lava lake, a rare feature not commonly found on other celestial bodies. The lava on Io is primarily composed of basalt, similar to what we see on Earth, but the addition of sulfur gives it a unique appearance. The eruptions of Pele have been tracked by both ground-based telescopes and spacecraft, providing valuable insight into the violent processes taking place on this intriguing moon. The atmosphere of Io is incredibly thin and lacks sufficient pressure for humans to survive. However, this precarious environment allows scientists to study the interactions of volcanic materials with the moon's surface and how these processes shape the landscape. The sulfur that rains back down can create an array of geological features, including smooth plains and rugged mountains, all artifacts of Io's volcanic activity. Moreover, the presence of sulfur compounds contributes not only to the vibrant colors seen on the surface, but also to the creation of a faint, tenuous atmosphere. The eruptions release sulfur dioxide gas, which can escape into space but also condenses on the surface, creating a cycle that fuels further volcanic activity. Exploring Io provides a window into the complexities of planetary geology and volcanism. Each eruption tells a story of the forces at work beneath the surface and the dynamic nature of this celestial body. As we continue to learn more about Io, it enriches our understanding of how planets evolve and interact within our solar system. With each new discovery, we uncover yet another layer of the mysteries that make up the universe we inhabit. The Santa Maria crater is one of the intriguing geological features on the surface of Mars, particularly known for the insights it offers into the planet's history. This crater, which has a diameter of about 90 meters, is located in the Meridiani Planum region, an area that has captivated scientists and space enthusiasts alike. The Opportunity rover, part of NASA's Mars Exploration Rover mission, played a pivotal role in unraveling the secrets held within this fascinating crater. As Opportunity approached the Santa Maria crater, it was immediately clear that this location was special. The rim of the crater presented a diverse array of rocks and geological features, offering a unique window into the Martian past. Scientists believe that understanding these rocks can help reconstruct the environmental conditions of Mars long ago. Notably, some of these rocks displayed evidence that water, in some form, once flowed in this region. What makes the exploration of Santa Maria particularly exciting is the discovery of hematite, a mineral that typically forms under aqueous conditions. This finding suggests that at some point in Mars' history, there was indeed water present, which could have shaped the surface and contributed to the minerals we see today. The discovery of such minerals provides crucial information about the ancient climate and possibly habitable conditions on the planet. The crater's formation itself is a testament to the violent processes that have shaped Mars over millions of years. Impact craters are created when meteoroids collide with a planetary surface, and Santa Maria is no exception. The impact that created this crater exposed layers of rock beneath the surface, allowing scientists to study materials that might still retain clues about the presence of water. As Opportunity roamed the crater, it captured countless images and gathered data that would fuel scientific inquiries for years to come. The rover's panoramic cameras provided stunning views of the crater's interior. The rover examined the texture of the rocks, looking for signs of erosion and alteration that can indicate the presence of water. The exploration of Santa Maria crater has implications that stretch beyond just this one site. The findings help paint a broader picture of the Martian environment, helping researchers understand the planet's potential for life and the processes that have shaped its landscape. From the evidence gathered, scientists are not just piecing together the history of Santa Maria, but are also inferring the climatic shifts of Mars over epochs. So the Santa Maria crater serves as a gateway to the past, a place where the serene Martian landscape hides stories of water and ancient conditions. Through the eyes of the Opportunity rover, we are afforded a glimpse into Mars's geological narrative, enhancing our understanding of one of our closest planetary neighbors. As we continue to analyze the data and images sent back from this remarkable crater, the story of Mars and its watery past becomes richer and more compelling. Io, one of Jupiter's largest moons, is an extraordinary celestial body known for its remarkable geological activity. This vibrant moon is not just a simple rock orbiting the gas giant. It is a world shaped by powerful tidal forces, resulting from the gravitational dance with Jupiter. Imagine standing on Io as it orbits a colossal planet. Because Jupiter is so massive, its gravitational pull on Io is incredibly strong. But what's fascinating is that Io is not alone in this dance. It is accompanied by two other significant moons, Europa and Ganymede, which also orbit Jupiter. As these moons move through space, their gravitational fields interact with one another, creating a tug-of-war effect that is felt by Io. This gravitational interaction causes a phenomenon known as tidal heating. Tidal heating occurs when the pull of gravity stretches and compresses a moon. In Io's case, the gravity from Jupiter causes constant flexing of its surface as it gets pulled in different directions. This continuous flexing generates immense amounts of heat within Io's interior, much like the way the friction of bending and twisting a rubber band warms it up. The result of this tidal heating is a world of constant geological activity. Io is dotted with active volcanoes, some of the most powerful in the solar system. When these volcanoes erupt, they can spew plumes of sulfur and sulfur dioxide high into the thin atmosphere, creating colorful landscapes that resemble something from a science fiction novel. In fact, some of Io's volcanic eruptions can reach heights of over 400 kilometers, sending material far above the surface. The heat produced by tidal forces also affects Io's surface, contributing to a complex landscape consisting of vast lava fields, towering mountains, and deep pits. The volcanic eruptions play a significant role in reshaping this landscape over time. As lava flows cool and solidify, they create new terrain while older features are eroded away. This process means that Io is one of the youngest surfaces in the solar system, continually refreshing itself through the relentless activity of its volcanism. What makes Io particularly fascinating is its extreme diversity. It possesses a colorful surface, ranging from yellows and reds to greens, owing to its unique composition of sulfur and silicate rock. The constant transformation of Io's surface provides a stunning vista that showcases the raw power of nature, influenced by gravitational forces. In conclusion, Io serves as a compelling example of how celestial mechanics can breathe life into an otherwise desolate moon. Its dynamic environment is a direct reflection of the immense tidal forces exerted by its parent planet, Jupiter, resulting in one of the most geologically active bodies in our solar system. As we continue to explore and study Io, we unravel the secrets of its fiery nature and its place in the grander tapestry of the universe. Imagine a world where atoms lose their individual identity and merge into a collective state, behaving as if they are one entity. This fascinating phenomenon occurs at extremely low temperatures, close to absolute zero. In this state, which physicists call Bose-Einstein condensate, matter takes on an entirely new set of behaviors, challenging our conventional understanding of how particles interact. To grasp the concept of Bose-Einstein condensate, we must first understand the basics of temperature and atomic motion. At higher temperatures, atoms vibrate and move around energetically, bouncing off one another in an unpredictable manner. However, when temperatures approach absolute zero, which is around minus 273 degrees Celsius or minus 460 degrees Fahrenheit, things change dramatically. The particles slow down, and their behavior becomes profoundly different. Bose-Einstein condensate is named after two prominent physicists, Satyendra Nath Bose and Albert Einstein. In the early 20th century, Bose proposed a statistical model for a group of indistinguishable particles that would eventually lay the groundwork for this extraordinary state of matter. Later, Einstein expanded on Bose's ideas, predicting that, under the right conditions, a group of bosons, particles that can occupy the same quantum state, would condense into a single quantum entity. This remarkable state of matter was first achieved in a laboratory setting in 1995 when scientists managed to cool rubidium atoms to mere fractions above absolute zero. At this temperature, the atoms lost their distinct boundaries, merging together into a coherent wave-like state. This formation allows researchers to probe the strange and fascinating properties that emerge in such conditions. One of the most astonishing characteristics of Bose-Einstein condensate is the phenomenon of superfluidity. When certain materials reach this state, they can flow without viscosity, meaning they experience no friction. Imagine water flowing through a pipe without any resistance. That is comparable to how a superfluid behaves. This can lead to unexpected outcomes, such as the ability of superfluids to climb the walls of their container, defying the force of gravity. Furthermore, the study of Bose-Einstein condensates opens up windows into the quantum world, providing insights into fundamental questions about the nature of matter in the universe. Researchers are exploring applications in various fields, including quantum computing, where the peculiar properties of these condensates may lead to breakthroughs in technology far beyond our current capabilities. As we delve deeper into the nature of Bose-Einstein condensate, we uncover the underlying principles that govern the universe itself. It reminds us just how perplexing and beautiful the world of physics can be, where particles can unite in such a profound way that they bend the very rules we thought we understood. Exploring this extraordinary state of matter not only challenges our perceptions, but also paints a picture of a universe that is interconnected and teeming with possibilities. In the vast expanse of our solar system, scientists continuously strive to uncover the secrets held within its depths. One of the most intriguing concepts that has captivated astronomers is the Planet 9 hypothesis. Imagine a looming, unseen giant lurking beyond Pluto, influencing the orbits of distant celestial objects. This idea, though unproven, has sparked a fascinating wave of research and debate. Planet 9 is posited to be an enormous planet, perhaps 10 times the mass of Earth. Its hypothetical location could be somewhere in the outer reaches of our solar system, far beyond the known planets. Researchers are convinced that the peculiar orbits of several trans-Neptunian objects, those distant bodies that orbit the Sun beyond Neptune, strongly suggest the presence of a massive, unseen companion. Observations reveal that some of these objects have highly elliptical orbits and are clustered in paths that seem to align in a way that cannot be easily explained by the gravitational influences of known planets. To illustrate this, consider a group of marbles rolling across a table. If there is nothing influencing their paths, they will scatter evenly. However, if a hidden force, like an invisible weight, pulls on some of the marbles, they may begin to move in unusual patterns. In the solar system, Planet 9 is envisioned as that hidden influence, subtly guiding these far-flung bodies through the gravitational dance of the cosmos. The quest for Planet 9 has invigorated astronomers in a substantial way. Observatories around the world utilize advanced telescopes to search for any signs of this potential world. However, looking for something that is purposefully elusive is no easy task. Researchers highlight that the planet could be so far away that it reflects very little sunlight, making it exceptionally dim and difficult to identify. Some hypothesize that it may even be surrounded by a thick atmosphere, further complicating detection. Various theories have emerged regarding the planet's nature. Could it be a gas giant, similar to Saturn or Jupiter, or perhaps a frozen world like Neptune? Speculating about its composition opens a window into possibilities for the types of environments that could exist in the outer solar system. The Planet 9 hypothesis is not just a scientific endeavor, it has sparked imagination and curiosity. It challenges how we perceive our solar system and encourages us to think beyond what we already know. The potential discovery of this mysterious planet would not only reshape our understanding of planetary formation and dynamics, but also ignite a sense of wonder about what else might be lurking undiscovered in the shrouded regions of space. As astronomers continue their search, the mystery of Planet 9 serves as a reminder of the boundless possibilities inherent in the universe. Each tiny advancement in technology and understanding brings us closer to unveiling the secrets of our celestial neighborhood. Who knows what other enigmas await us, hidden in the cosmic shadows, just waiting to be uncovered. The adventure of exploration is never-ending, and each day in the study of our solar system brings with it the hope of new discoveries that could transform our perception of the cosmos forever. In our fascinating exploration of the cosmos, one of the most intriguing discoveries has come from the Centaur asteroid known as Chariklo. Discovered in 1997, Chariklo orbits the Sun between Saturn and Uranus, and at first glance, it may seem like just another rocky body in the vast expanse of space. However, it has something unique that sets it apart from many of its celestial neighbors. Chariklo boasts a dazzling system of rings, making it the first non-planetary object identified with such an extraordinary feature. The discovery of these rings in 2013 was a landmark moment for astronomers and researchers. Observations conducted using a technique called stellar occultation, where the asteroid passes in front of a distant star, revealed the unexpected presence of these rings. As Chariklo occluded the light from the star, scientists noticed a series of dips and rises in brightness. This indicated that something was surrounding Chariklo, leading to the revelation of its rings. Chariklo's rings are composed primarily of water ice and dust particles, which are believed to come from the gravitational interactions between the asteroid and its surroundings. The rings are thought to be relatively narrow and well-defined, with a total width of just a few kilometers. This allows them to maintain a distinct presence around the asteroid, even from a great distance. Scientists have identified two main rings, known as the outer and inner rings. The outer ring appears to be thicker, while the inner ring is narrower, creating a striking contrast against the dark backdrop of space. One of the most captivating aspects of Chariklo's rings is their stability. Unlike rings found around giant planets like Saturn, which are influenced by complex gravitational effects, Chariklo's rings are thought to be maintained by the gravitational pull of the asteroid itself. This stability opens up fascinating questions about how such structures can form and persist around smaller celestial bodies. Chariklo is not an isolated case in the world of rings. The discovery has sparked interest in studying other Centaur asteroids, as well as Kuiper belt objects, to see if this phenomenon is more common than previously thought. After Chariklo, researchers have begun to look for ring systems around these smaller bodies, pondering if they too might conceal their own circling rings. As we delve deeper into the wonders of our solar system, Chariklo serves as a reminder of the countless mysteries that remain to be uncovered. Its rings stand as a testament to the dynamic nature of celestial bodies and the processes that govern their formation. They invite us to ponder the intricate dance of materials, gravitational forces, and the ever-evolving story of our universe, encouraging further exploration into the vast cosmos that surrounds us. The story of Chariklo and its remarkable rings continues, and with each new discovery, we gain a deeper appreciation for the complexity and beauty of the universe we inhabit. Imagine a future where spaceships can venture farther into the cosmos, powered by fuel produced in the vastness of space itself. This is not just a distant fantasy, but a proposal delving into the feasibility of manufacturing rocket fuel from local materials available on celestial bodies like the Moon, Mars, and asteroids. Harnessing these resources could significantly ease the constant dependency on Earth for fuel resupply and open up new frontiers in space exploration. One main idea is to utilize the abundant resources found on the Moon. Scientists believe the Moon has vast deposits of a substance called regolith, which is a mixture of dust and broken rock. Within this regolith, researchers have discovered traces of water ice, particularly in permanently shadowed regions. By applying simple chemical processes, this water can be split into hydrogen and oxygen, both essential components for rocket fuel. Imagine a lunar base housing machines that extract ice, convert it into hydrogen and oxygen, and produce fuel for missions deep into the solar system. This would allow for semi-permanent human presence on the Moon, reducing the hefty logistics of transporting fuel from Earth. Mars, with its vast landscapes and rich mineral content, also presents a treasure trove of possibilities. The thin atmosphere of Mars is composed mainly of carbon dioxide. Innovative proposals have suggested utilizing this carbon dioxide to produce methane, another key ingredient for rocket fuel. By combining it with hydrogen, which can be extracted from Martian water, or from resources like regolith, engineers could create a sustainable fuel production system on Mars. Imagine spacecraft departing from Mars, bound for the asteroid belt or even beyond, all fueled by materials harvested from the planet itself. Asteroids offer yet another promising avenue for fuel generation. Many asteroids are made up of metals and icy materials, including water and hydrocarbons. Mining these objects with robotic spacecraft could yield the necessary components for fuel production. Within the depths of these celestial bodies, water and other organic materials could be converted into hydrogen, oxygen, and other fuels like kerosene. The proposition is not merely theoretical. Missions aimed to collect samples from asteroids are already underway, laying the groundwork for future resource utilization. This endeavor of producing rocket fuel in space can radically change the way we explore. Freed from the gravitational pull of Earth and the costly delivery of fuel supplies, spacecraft could embark on long-duration voyages across the solar system. Imagine a future where scientists can send ambitious missions to distant planets, investigate the outer reaches of our solar system, or even launch crewed missions to the moons of Jupiter or Saturn with ease, all powered by fuel made from local sources. In the grand tapestry of human exploration, manufacturing rocket fuel in space represents a bold leap towards independence and sustainability beyond our planet. By tapping into the resources available around us, we are not only enabling humans to explore further, but are also paving the way for a new era of extraterrestrial habitation and discovery. With every step forward, we venture deeper into the unknown, armed with ingenuity, resilience, and the limitless potential of local materials. In the vast toolkit of modern astronomy, one of the most captivating images ever captured is known as the Hubble Ultra Deep Field. This extraordinary photograph offers us a glimpse into the distant past, taking us back billions of years to a time when the universe was still young. As we explore this remarkable image, we dive into the heart of cosmic history. The Hubble Ultra Deep Field was produced by the Hubble Space Telescope, which was launched into orbit in 1990. This telescope has become a powerful instrument for astronomers, providing insights that were once unimaginable. To create this particular image, Hubble focused on a seemingly empty patch of sky in a direction within the constellation Fornax. This area, which was thought to be devoid of galaxies, was observed for an extended time, highlighting just how much we still have to learn about the universe. What astronomers discovered was astonishing. Within this tiny slice of the universe, they found thousands of galaxies, stretching back in time to just a few 100 million years after the Big Bang. Each point of light in the image represents a galaxy, many of which are far more ancient than our own Milky Way. Some of these galaxies are so distant that their light has taken over 13 billion years to reach us. This is not just a snapshot. It is a window into a previously unseen era, allowing us to witness the formation and evolution of galaxies. The colors in the Hubble Ultra Deep Field provide information about the nature of these galaxies. The light emitted by distant galaxies is often shifted toward the red end of the spectrum due to the expansion of the universe. This phenomenon, known as redshift, helps astronomers determine how far away these galaxies are and how long their light has been traveling across the cosmos. For instance, when we see a galaxy that appears red, it often indicates that it is moving away from us, a fundamental principle that also supports the idea that the universe is continuously expanding. Research based on this image has significantly impacted our understanding of galaxy formation. The Hubble Ultra Deep Field has revealed that galaxies come in a variety of shapes and sizes, from spiral formations to more irregular structures. This diversity confirms that the processes that govern the birth and evolution of galaxies are complex and dynamic. As we contemplate the Hubble Ultra Deep Field, we are reminded of our place in the universe. The countless galaxies represented in this image remind us that we are part of something much larger than ourselves. It is a humbling thought to consider that we are viewing stars and structures that existed billions of years ago, long before our own planet took shape. In summary, the Hubble Ultra Deep Field is more than just a photograph. It is a testament to human curiosity and the pursuit of knowledge. As we gaze at this stunning depiction of the universe, we find ourselves connected to the past, present, and future of cosmic exploration. Each galaxy tells a story, and each story enriches our understanding of the universe, encouraging us to look deeper and ask more questions about our remarkable existence among the stars. At the very heart of our Milky Way galaxy lies an extraordinary entity known as Sagittarius A. This mysterious object is a supermassive black hole, one of the most fascinating features of our cosmic neighborhood. Located about 26,000 light-years away from Earth, Sagittarius A captures the imagination of astronomers and scientists alike. What makes Sagittarius A so intriguing? First, let's consider its immense size. It is estimated to have a mass equivalent to roughly 4 million suns. Imagine compressing the mass of 4 million of our solar systems into a single point in space. This extraordinary concentration of mass creates an incredibly strong gravitational pull, which influences the entire galaxy. The effects of Sagittarius A extend far beyond its immediate surroundings. Its gravitational force plays a crucial role in the structure and dynamics of the Milky Way. As stars orbit the center of our galaxy, they are guided by the gravitational heartbeat of this supermassive black hole. The paths of these stars have been meticulously tracked by astronomers, revealing how they are affected by the presence of Sagittarius A. Some of these stars travel at astonishing speeds, reminding us of the cosmic ballet taking place in our night sky. Observing Sagittarius A's tail is not without its challenges. The area surrounding this black hole is shrouded in clouds of dust and gas, making direct imaging difficult. However, advancements in technology have allowed scientists to study this enigmatic object using various methods, such as radio waves and X-ray emissions. These observations reveal the dynamic environment around the black hole, where matter spirals inward, forming an accretion disk that radiates energy before being consumed. The study of Sagittarius A also opens a window into understanding the behavior of black holes in general. This supermassive black hole serves as a benchmark for academic research on similar entities found in other galaxies. Observations of Sagittarius A provide valuable insights into how black holes may grow, evolve, and influence the formation of galaxies across the universe. It is fascinating to think about how black holes like Sagittarius A can seemingly disappear from sight, yet their presence is powerfully felt. As stars and gas clouds are drawn closer, they get caught in the black hole's gravitational pull, often producing luminous light as they are forced to accelerate and heat up. The sheer scale of Sagittarius A and its influence catalyzes thought about our place in the cosmos. We can visualize the unseen forces at play, dominating the stellar dance that unfolds across the Milky Way. This grand, invisible conductor orchestrates the movement of countless stars, shaping the galaxy's rhythm over eons. As we continue to study Sagittarius A, our understanding of the universe expands. It is a reminder that, even in the darkest corners of space, there is the potential for discovery, wonder, and a deeper appreciation of the intricate tapestry of existence. Each revelation adds a new layer to our comprehension of black holes, galaxies, and the universe we call home, inspiring curiosity and awe about the cosmos that surrounds us. Cosmic inflation theory is a fascinating concept that delves into the very beginnings of our universe. Imagine the universe, just moments after the Big Bang, still extremely hot and dense. Suddenly, it undergoes a rapid expansion, much faster than the speed of light. This astonishing growth, thought to have happened in a fraction of a second, transforms the fabric of space itself. To visualize this, think of blowing up a balloon. At first, the balloon appears small and constricted. However, as you blow air into it, it expands rapidly. Cosmic inflation proposes that the universe grew in a similar manner, stretching out incredibly fast, changing from a tiny point to something vast and complex. This rapid expansion helped resolve several issues that scientists faced when trying to understand the early universe and its structure. One of the critical insights provided by cosmic inflation theory is its role in explaining the smoothness and uniformity of the universe. Consider a freshly baked loaf of bread. When it rises, it expands evenly. The dough spreads out, giving it a consistent texture. Similarly, inflation smoothed out the initial irregularities of the universe, caused by gravitational forces after the Big Bang. This led to a cosmos that appears homogeneous, meaning that when we look at the universe on a large scale, it seems much the same in every direction. Another intriguing aspect of inflation is the concept of quantum fluctuations. During the inflationary period, these tiny variations occurred at a subatomic level. You can think of these fluctuations like ripples on the surface of a calm pond. Although the pond may seem still, tiny disturbances create ripples that eventually affect the surface. Over time, these minute variations grew as the universe expanded. They became the seeds for all the galaxies, stars, and planets we see today. Moreover, cosmic inflation provides a compelling explanation for the uniform temperature observed across the universe. If we take a look at the cosmic microwave background radiation, it's like a remnant afterglow from the Big Bang. This radiation is remarkably consistent in temperature, suggesting that different regions of the universe were once in close proximity before rapidly expanding away from each other. The inflationary period allowed these regions to equilibrate, leading to the uniform background we observe. Cosmic inflation theory also touches on the multiverse concept by suggesting that our universe could be just one of many. Just as bubbles form in a boiling pot of water, each bubble can represent a different universe, each with its own unique properties and laws of physics. This idea pushes our understanding of reality itself, inviting us to ponder possibilities beyond our single observable universe. In summary, cosmic inflation theory offers a dynamic view of the universe's growth after the Big Bang, highlighting its uniformity and the role of quantum fluctuations in shaping the cosmos. It invites us to explore the intricate patterns and vast expanses of existence, reminding us that the universe is ever evolving and filled with mysteries waiting to be discovered. Imagine the life cycle of stars, those brilliant celestial bodies that light up our night sky. Among them, white dwarfs hold a special place, serving as the remnants of stars that have reached the end of their life. These stars have exhausted their nuclear fuel, no longer able to sustain the fusion reactions that once powered them. Their journey is one of transformation and eventual stillness. When a star like our Sun runs out of hydrogen to fuse into helium, it begins to shed its outer layers. What remains is the hot core, which becomes a white dwarf. These stars are incredibly dense and small, often about the size of Earth, but containing a mass similar to that of the Sun. This remarkable density leads to extraordinary gravitational forces, making white dwarfs fascinating objects in our universe. Initially, white dwarfs are extremely hot, with surface temperatures reaching around 100,000 degrees Celsius. They emit light in a brilliant display, illuminating the cosmos in ways that are difficult to ignore. This heat slowly dissipates over time as they radiate energy into space. As they cool, their once bright white appearance begins to fade, giving way to shades of yellow, then orange, and eventually red. This process can take billions of years, during which time they become less and less luminous. The fate of these white dwarfs is intriguing. Over exceedingly long timescales, they will continue to cool until they reach a state where they can no longer emit significant light. This final stage leads them to become what astronomers call black dwarfs. However, it's worth noting that, as of now, the universe is not old enough for any black dwarfs to exist. The timescales are so long that they remain a theoretical concept. Imagine the universe filled with countless white dwarfs, each with its story of stellar evolution. These remnants of small stars keep cool under the vast tapestry of the cosmos. The longer they exist, the closer they move toward obscurity, but their presence is essential for the cosmic cycle. They enrich the interstellar medium with heavy elements, forming the building blocks for future stars and planets. In this grand cosmic timeline, the transformation from a vibrant, life-giving star to a cold, dark remnant reveals the beauty and inevitability of change. White dwarfs remind us that even in their quietude, they are part of a larger narrative, a thrilling dance of creation and transformation that has been ongoing for billions of years. As we gaze upward at the stars, it's fascinating to know that some of them are already on this journey, slow but steady, transitioning from brightness to darkness. Each white dwarf twinkling overhead is a reminder of the life that once was, and the future that awaits in the endless cycle of the universe, echoing the eternal story of creation, transformation, and renewal. At the heart of Saturn's North Pole lies a mesmerizing and puzzling phenomenon known as the hexagon. This remarkable structure is not merely a fleeting weather pattern. It is a vast, persistent cloud formation that has intrigued scientists since it was discovered by the Voyager spacecraft in the early 1980s. The hexagon spans approximately 20,000 miles across, making it larger than the entire size of Earth. Its striking shape and the complexity of its movements continue to baffle researchers. The hexagon exhibits a remarkable geometric symmetry, with each of its 6 sides being roughly equal in length. Instead of curling into conventional wind patterns, this cloud formation maintains its distinct hexagonal shape, even as the atmosphere around it swirls and changes. Scientists have noted that the edges of the hexagon are sharp and well-defined, further enhancing its unique appearance. The formation is anchored by powerful winds that can reach speeds of 200 miles per hour, which helps maintain the stability of this bizarre shape. One of the many questions surrounding the hexagon is how it can remain so stable over time. Unlike typical atmospheric phenomena, which tend to dissipate or evolve, the hexagon has persisted for decades, or possibly even longer. To better understand this, researchers have turned to computer simulations, attempting to replicate the hexagonal shape in a lab environment. These experiments have shown that under the right conditions, such as the right combination of rotation and temperature differences, it's possible to create a hexagon-like formation in a fluid. However, the specific dynamics that lead to the formation we observe on Saturn still require further study. The hexagon is not just a striking feature, it has also provided valuable insights into the planet's atmospheric dynamics. By studying the hexagon, scientists can learn more about the unique weather patterns and seasonal changes that take place on Saturn. The formation's stability may also offer clues about the deeper atmospheric processes at play beneath the planet's clouds. Additionally, the hexagon is accompanied by a rich tapestry of swirling clouds and storms that form and reform around it. These patterns are influenced by Saturn's fast rotation, which contributes to the formation of numerous jet streams and a highly dynamic atmosphere. Observations from the Cassini spacecraft, which studied Saturn from 2004 to 2017, have provided a wealth of data regarding the planet's weather, enhancing our understanding of the hexagon's role within this larger context. In conclusion, the hexagon at Saturn's North Pole remains one of the solar system's most intriguing mysteries. Its unique and persistent shape calls into question our understanding of fluid dynamics on a planetary scale. With ongoing research and exploration, the hexagon continues to inspire curiosity and wonder, reminding us of the complex and beautiful intricacies of our universe. Deep in the heart of the Orion constellation lies a breathtaking cosmic wonder known as the Orion Nebula. Among its many captivating features, one of the most fascinating is the stellar nursery, a vast region where new stars are coming to life. The Orion Nebula is not just a collection of bright stars. It is a vibrant, colorful cloud of gas and dust that serves as a cradle for the next generation of stellar bodies. Imagine a scene where clouds of gas, primarily hydrogen, swirl together with fine particles of dust, creating an environment ripe for star formation. This cosmic nursery is filled with brilliant hues of pink, red, and blue, caused by the interaction of light and energy. These colors are a testament to the incredible processes occurring within the nebula. Bright young stars, some only a few million years old, illuminate the surrounding gas, causing it to glow in a soft, ethereal light. In this stellar nursery, gravity plays a crucial role. As dense regions of gas condense due to gravitational forces, they start to collapse, creating clumps that eventually become stars. You can think of it as nature's way of sculpting something beautiful from raw materials. This process occurs over thousands to millions of years, resulting in stars forming at different stages throughout the nebula. Among these newly formed stars, many will eventually gather into clusters. These clusters become brilliant groups of stars that shine together in the night sky. Some of the stars are massive, burning brightly and quickly, while others are smaller and will take their time to evolve. The combination of these energies contributes to the dynamic nature of the nebula. Within the Orion Nebula, you can also find protoplanetary disks. These disks are made of gas and dust circling around newly formed stars. They are the building blocks of planets, much like our own solar system formed around the Sun billions of years ago. This means that within the stellar nursery, not only are stars being born, but potential planetary systems are taking shape as well. As you gaze up at the night sky, the Orion Nebula stands out as a reminder of the continuous cycle of creation in the universe. Every twinkling star we see is a piece of a larger story, one that began in these stellar nurseries. The incredible beauty and complexity of the nebula highlights the ever-evolving nature of the cosmos. Each generation of stars contributes to the stellar tapestry we observe, enriching the universe with light and energy, and reminding us of the wonders that exist beyond our planet. So the next time you look up at Orion, take a moment to appreciate the depth of the stellar nursery, where countless new worlds and stars are waiting to shine brightly in the infinite expanse of space. The Moon, our closest celestial neighbor, holds many secrets, one of which is the fascinating phenomenon known as lunar mascons. These are gravity anomalies that lie beneath the lunar surface, and they can significantly influence the orbits of spacecraft traveling around or near the Moon. So what exactly are mascons, and why do they hold such mystery? First, let's break down what a mascon is. The term mascon derives from mass concentration, and it refers to areas on the Moon where the gravitational pull is stronger than the surrounding regions. These zones are typically found beneath large lunar basins, where vast amounts of dense material have accumulated over billions of years. The concentration of mass results in a unique gravitational field that can alter the trajectory of spacecraft, creating challenges for scientists and engineers tasked with navigating in lunar orbit. Interestingly, mascons can affect the orbits of satellites in unexpected ways. When a spacecraft enters orbit around the Moon, it is subject to the gravitational pull of both the Moon itself and the mascons below. As the spacecraft moves over these mass concentrations, it may accelerate or decelerate depending on its position relative to the mascon. This phenomenon can lead to changes in the spacecraft's altitude and orbit, making precise navigation a complex endeavor. Mission planners must take these gravity anomalies into account to ensure successful maneuvers and data collection. Now, while the existence of mascons is well documented, their precise origins remain somewhat mysterious. The leading theory suggests that they were formed during the Moon's violent past, particularly during the period known as the Late Heavy Bombardment. This was a time when the Moon was bombarded by asteroids and comets, creating large impact basins. The subsequent volcanic activity that followed could have led to the accumulation of dense materials that now constitute the mascons. Yet, despite this prevailing theory, there is ongoing debate among scientists about the exact processes that led to their formation. Some researchers speculate that the mascons could be remnants of ancient lava flows that filled the basins created by impacts, while others propose that they may arise from the Moon's unique geological activity. The lack of clarity on their origins adds to the intrigue, as these mass concentrations continue to challenge our understanding of lunar geology. Exploring mascons is important not only for future lunar missions, but also for broader astrophysical research. By studying these areas, scientists can gain insights into the Moon's history and evolution, as well as the dynamic processes that have shaped its surface. As advancements in technology allow for more detailed mapping and analysis, we may uncover even more secrets hidden beneath the lunar surface. In conclusion, lunar mascons represent a captivating intersection of gravity and mystery. Their influence on spacecraft orbits is a reminder of the dynamics at play in our universe, while their enigmatic origins invite continued exploration and inquiry. As we delve deeper into the Moon's past, we may increasingly illuminate the secrets that lie beneath this ancient surface, revealing the complex story of our nearest cosmic neighbor. In the vast expanse of space, there is something truly remarkable, a phenomenon known as the cold spot. Imagine a patch of the cosmic microwave background radiation, the afterglow of the Big Bang, that is noticeably colder than the surrounding areas. This discovery invites us to explore an astonishing possibility that there could be something beyond our universe, perhaps even another universe entirely. The cold spot was first identified in data collected by the Wilkinson Microwave Anisotropy Probe, or WMAP. This satellite, launched in 2001, painstakingly mapped the cosmic microwave background, revealing temperature fluctuations that trace the early moments of our universe. As scientists examined this data, they noticed a peculiar area that stood out, a region that is about 3 degrees Celsius colder than the average temperature of the cosmos. To some, this anomaly raises intriguing questions about the nature of our universe and beyond. One of the leading theories surrounding the cold spot is that it could be the result of a collision with another universe. Think of our universe like a balloon, inflating and expanding in the vastness of the multiverse. If another universe were to meet ours, the interaction might create ripples or disturbances in the cosmic microwave background, resulting in the cold spot. While this idea seems far-fetched, it opens up a fascinating conversation about what lies beyond our observable universe. Another theory suggests that the cold spot could be caused by a large void in space, an area with far fewer galaxies and matter than what surrounds it. Such voids are known to exist and can influence the cosmic microwave background radiation. However, these voids typically should not create such a significant temperature difference. This leads to ongoing debates among scientists who explore the origins of this puzzling phenomenon. Yet, the cold spot does not just challenge our understanding of cosmic history, it also ignites our imagination. Consider the vast possibilities of what exists beyond our universe. Are there realms where different physical laws operate, or perhaps universes containing entirely different forms of life? This mystery draws together not just astronomers and physicists, but also philosophers and dreamers, all curious about the nature of existence itself. Researchers continue to gather data, using advanced telescopes and intricate models to study the cold spot in greater detail. Each new finding provides insights into the birth and evolution of our universe, while simultaneously fueling our fascination with the cosmos. As we delve into this mystery, we inch closer to understanding our place within the greater tapestry of reality. In the grand scheme of things, the cold spot represents more than just a temperature anomaly. It symbolizes the unexplored territories of science and human curiosity. Every question leads to more questions, and as we seek to answer them, we embark on a journey that may one day reveal the deepest secrets of the universe. So as we look up at the night sky, it is worth pondering what other phenomena await discovery, hiding just beyond our sight and comprehension, waiting for us to explore the endless possibilities. The Virgo supercluster is one of the largest known structures in the universe, a colossal collection of galaxies bound together by gravity. Imagine standing in a vast library, where instead of books, you find countless galaxies, each one unique and with its own story. Our own Milky Way galaxy is just one among a myriad of others within this supercluster, creating an intricate tapestry that stretches across millions of light years. Located about 65 million light years away from Earth, the Virgo supercluster contains over 100 galaxy groups and clusters. This includes famous neighbors like the Andromeda Galaxy and numerous smaller satellites. It is like an urban neighborhood filled with friendly faces, each galaxy having its own character and history. Some galaxies are spiraled, like swirling waltzes of stars, while others are elliptical, with their stars grouped closely together, resembling an oversized cosmic ball. At the heart of the Virgo supercluster lies a region known as the Virgo cluster, a dense assembly of galaxies held together by gravity. Within this cluster, galaxies are drawn together, circling around a central mass that influences their movement. However, the complete nature of this gravitational center remains a mystery. Scientists have theorized about the presence of dark matter, an invisible substance that does not emit light or energy, making it challenging to detect. Dark matter is believed to play a critical role in the formation and structure of cosmic entities. The interactions between galaxies in the Virgo supercluster are fascinating. They can collide, merge, or pass by each other, leading to the creation of new stars and the destruction of old ones. Picture a cosmic dance, where galaxies gracefully twirl and spin, sometimes embracing in a grand display of starlight, while at other times they glide past in silence. Each movement is significant, shaping the future of galaxies in ways we are still striving to fully understand. One of the most intriguing aspects of this supercluster is its relationship with the greater universe. The Virgo supercluster itself is part of a larger structure known as the Laniakea supercluster, which encompasses several other groups of galaxies. Just as a city is part of a larger region, our little neighborhood in the Virgo supercluster exists within a greater cosmic community. At the grand scale of the universe, everything is interconnected in remarkable ways, revealing an intricate web of galaxies tied together by the forces of gravity. As researchers delve deeper into the mysteries of the Virgo supercluster, they use powerful telescopes and innovative technologies to probe its secrets. This exploration has revealed a cosmic landscape filled with wonders that stretch human imagination. Each discovery opens new avenues of inquiry, like unveiling an ancient map that leads to hidden treasures. In this vast universe, the Virgo supercluster serves as a reminder of both our smallness and our potential for great inquiry. The mysteries it holds beckon scientists and dreamers alike, encouraging them to explore and question the nature of the cosmos and our place within it. There is still so much to learn, and as we gaze into the night sky, we can't help but wonder what other secrets lie waiting to be uncovered among the stars. The three-body problem is a fascinating topic in physics and mathematics that revolves around predicting the motion of three celestial bodies as they interact with each other through gravity. Imagine three stars or planets, each pulling on one another with their own gravitational forces. This scenario leads to an intricate dance of movement, creating patterns that can be mesmerizing yet unpredictable. The origins of the three-body problem trace back to the early days of celestial mechanics, when scientists like Isaac Newton laid the groundwork for understanding gravity. While Newton's laws allowed for predicting the orbits of two bodies, such as the Earth and the Moon, introducing a third body made the equations much more complex. This complexity arises because every small change in position or velocity can lead to dramatically different outcomes over time. To illustrate, think about the effect of three friends on a merry-go-round. If two friends are already pushing in opposite directions, introducing a third friend to join in creates a chaotic spin, especially if they each push at different strengths and angles. Similarly, in the realm of the celestial dance, the gravitational influences of all three bodies create a highly sensitive system. One example from our universe includes the gravitational interactions among the Earth, Moon, and Sun. While the Earth and Moon maintain a relatively stable orbit because of their gravitational relationship, the Sun's presence adds additional complexity that can lead to minor fluctuations in the Moon's path. This problem amplifies as more bodies are considered, leading to unpredictable results that challenge mathematicians and physicists alike. In mathematics, the three-body problem prompted the development of various methods to attempt to solve these complex equations. Some approaches involve numerical simulations, which use computers to calculate and visualize the motion of these celestial bodies over time. These simulations can reveal stunning patterns and chaotic behaviors that would be nearly impossible to predict with traditional analytical methods. Interestingly, the three-body problem has also found its way into popular culture and literature. Chinese author Liu Cixin explored these themes through a series of science fiction novels, where the interactions of celestial bodies play a crucial role in the greater narrative. This crossover highlights how the mystery and intrigue of the three-body problem extend beyond science into storytelling, inspiring curiosity about our place in the universe. While there is no universal solution to the three-body problem, the study continues to captivate scientists who use it to deepen their understanding of celestial dynamics. Each new exploration can teach us valuable lessons about chaos and stability, reminding us of the complexities inherent in nature. This interplay of forces, methods of analysis, and the beauty of the cosmos weave together a tale that spans centuries and unveils the wonders waiting to be discovered. Antimatter is one of the most fascinating substances in the universe. While we are familiar with the matter that makes up everything around us, rocks, trees, and even ourselves, antimatter consists of antiparticles, which are like the mirror images of the particles we know. For every particle there exists an antiparticle. For instance, the antiparticle of an electron is called a positron, which carries a positive charge, unlike the negatively charged electron. This intrinsic relationship adds a layer of symmetry to our understanding of the universe. Despite this symmetry, antimatter is incredibly rare. In fact, most of the universe is composed of ordinary matter, while antimatter exists mostly in tiny amounts. This imbalance raises numerous questions among scientists. Why is there so much more matter than antimatter? This phenomenon is called baryon asymmetry, and it remains one of the greatest mysteries of modern cosmology. When particles of matter and antimatter meet, They annihilate each other in a burst of energy according to Einstein's famous equation, E equals mc squared. This equation suggests that mass can be converted into energy, and the annihilation of matter and antimatter produces energetic gamma rays and other particles. This process releases a tremendous amount of energy in a very short time, making antimatter a subject of interest not just for theoretical physics, but also for potential applications. Antimatter can be produced in tiny quantities through high-energy collisions, such as those that occur in particle accelerators. These facilities, like the Large Hadron Collider, can create positrons and other antiparticles under controlled conditions. Yet, creating enough antimatter for any practical use is incredibly difficult and expensive. To date, the amount of antimatter we have manufactured is only enough to fill a few portable hard drives, which gives a sense of just how sparse this substance is. One striking example of antimatter in nature can be observed in cosmic rays, high-energy particles that travel through space and occasionally crash into Earth's atmosphere. When these cosmic rays collide with atoms in our atmosphere, they can produce positrons, providing a natural source of antimatter, albeit in minuscule quantities. Researchers are continuously exploring the properties of antimatter, including its gravitational interactions. There are theories suggesting that antimatter might behave differently under gravity compared to ordinary matter. But confirming these theories requires more research and experimentation. As we delve deeper into the mysteries of cosmology and particle physics, antimatter continues to challenge our understanding of the universe. It provides a lens through which we can explore fundamental questions about the origins of the cosmos, the nature of energy, and the underlying structure of reality itself. The quest to understand antimatter is not just about the particles themselves, it's about unlocking the secrets of the universe that have remained hidden for centuries. Imagine standing under a vast sky as the world begins to dim. It's not just any ordinary day, it's a special astronomical event known as the Ring of Fire eclipse. This fascinating phenomenon occurs during an annular solar eclipse, where the moon partially obscures the sun. Instead of completely covering it, the moon's position creates a breathtaking ring of sunlight around its edges, resembling a shimmering circle of fire. To understand this, let's take a moment to revisit the basics of solar eclipses. A solar eclipse happens when the moon moves between the Earth and the sun. Depending on the distance between these celestial bodies, different types of solar eclipses can occur. In a total solar eclipse, the moon covers the entire sun, leading to a moment of total darkness in some areas. However, in an annular eclipse, the moon is farther away from the Earth in its elliptical orbit, making it appear smaller in the sky compared to the sun. Therefore, it cannot entirely block the sun's light, resulting in that spectacular ring, the Ring of Fire. The Ring of Fire effect is particularly stunning. The outer edges of the sun shine brightly around the moon, forming a fiery halo. This captivating display usually lasts for several minutes, offering viewers a rare glimpse of what it feels like to be part of something larger than life. People often describe it as magical, a moment where nature's beauty reaches its peak. These eclipses don't occur every day, and when they do, they draw people from diverse backgrounds together, all eager to witness the celestial dance unfolding above them. Many travel great distances to find the perfect spot for viewing. Parks, open fields, and hilltops become prime locations, with families and friends gathering to share in the experience. Excitement fills the air as everyone waits in anticipation. During the Ring of Fire eclipse, the sun's rays create a unique ambient light that casts unusual shadows on the ground. Trees can produce crescent-shaped shadows as the light filters through their leaves. This phenomenon captivates observers, igniting curiosity about how these natural effects happen. It's worth noting that looking directly at the sun, even during an eclipse, can be dangerous, unless proper solar viewing glasses are used. In some cultures, solar eclipses have held significant meanings. Ancient civilizations viewed these events with a mix of awe and fear, often attributing gloomy supernatural forces to what they thought were cosmic battles. Today, however, we have the understanding and technology to appreciate these events scientifically, yet the sense of wonder remains. As the eclipse reaches its peak, the sight can leave a lasting impression. Whether it's the beautiful golden ring against the darkened sky, or the shared gasps of awe from the crowd, the Ring of Fire eclipse is a reminder of the wonders of our universe. It invites everyone to pause, gaze upward, and reflect on the incredible cosmic connections surrounding our existence. In the vast expanse of the universe, galaxies and galaxy clusters are in a constant dance, moving and interacting under the influence of gravity. However, some peculiar motions challenge our understanding of cosmic behavior. One such phenomenon is known as dark flow. Observations reveal that certain galaxy clusters are moving toward a specific region in the sky, and this motion appears to be unaffected by the known forces that shape their paths. Scientists first made note of dark flow when they analyzed the cosmic microwave background radiation, which is the afterglow of the Big Bang. This radiation serves as a snapshot of the universe's early moments and provides valuable insights into the nature of cosmic structures. Upon studying the movement of various galaxy clusters, researchers found that a collection appeared to be gravitating toward an area in the direction of the constellation Centaurus. This alignment puzzled astronomers as it seemed to point beyond the visible universe to areas that are not easily explained by conventional gravitational interactions. The most intriguing aspect of dark flow is that it seems to defy the cosmic expansion expected from the Big Bang theory, which posits that the universe is expanding uniformly. Instead, the clusters in dark flow show a coherent motion that suggests there might be unseen mass or forces at play. This notion has led scientists to reconsider what they know about dark matter, a mysterious substance that comprises a significant portion of the cosmos yet remains elusive and undetectable by traditional means. To understand dark flow better, imagine a current in a river. While the surface water flows with the current, other forces beneath might be at work, steering the water in ways not immediately visible from above. The universe can be similarly compared, where the apparent motion of galaxy clusters is influenced by vast structures of dark matter, or even other factors we have yet to comprehend, such as unidentified energies or gravity waves from distant superclusters. Researchers have sought to explain dark flow through various theories. Some posit that it may be evidence of an influence from superclusters lying outside our observable horizon. Others theorize that it might hint at the existence of a multiverse, where multiple universes are interconnected through complex forces, guiding the motion of galaxies in ways yet to be fully understood. As investigations continue, astronomers are utilizing advanced telescopes and computational models to delve deeper into the fabric of the cosmos. Each new finding offers a piece of the puzzle. Discovering more about dark flow may not only enhance our understanding of galaxy dynamics, but also provide insights into the underlying forces that govern the universe at its most fundamental level. One thing is clear: dark flow challenges our perceptions and compels us to look beyond our current knowledge. Each new exploration into this mysterious motion could lead to breakthroughs that reshape our grasp of cosmic phenomena, pushing the boundaries of what we understand about the universe and our place within it. The Sloan Great Wall is an astonishing cosmic structure that showcases the vastness of the universe and the complexities of its evolution. Stretching over 1 billion light-years across, this immense assemblage of galaxies has captured the attention of astronomers and astrophysicists alike. Imagine gazing into the depths of space and realizing that an entire wall of galaxies exists, bridging gaps between clusters and illuminating the mysteries of our cosmos. Discovered through the ambitious Sloan Digital Sky Survey, the Sloan Great Wall is a striking example of what we call large-scale structure. To put this into perspective, if you could witness this structure, you would see galaxies grouped together, forming a colossal, interconnected web. This web reveals not just the arrangement of galaxies, but also the forces at play in the universe, as gravity pulls these celestial bodies together, shaping their paths over billions of years. As we contemplate the formation of the Sloan Great Wall, it's intriguing to realize how it defies our expectations of space. Traditionally, we think of the universe as being relatively uniform on a grand scale. Yet, the presence of such vast structures challenges that idea, leading scientists to rethink theories of cosmic evolution. How did these galaxies come together in such a formation? What does this tell us about the distribution of matter in the universe? When we observe the Sloan Great Wall, we are essentially peering into a cosmic history book. Each galaxy within it has its own story, a narrative that combines star formations, supernovae, and the intricate dance of dark matter. For instance, if you were to focus on just one galaxy within the wall, you would uncover an entire world of stars and planets, some possibly harboring their own solar systems. It's amazing to ponder how a single galaxy could give birth to billions of stars over time, some of which may even host life. The structure also plays a vital role in understanding the conditions of the early universe. By studying the Sloan Great Wall and similar entities, researchers can gather clues about phenomena like cosmic inflation and the distribution of dark energy. The universe is not just expanding, it is doing so in ways that appear to retain patterns and structures. Further, examining these spatial giants may reveal the roles of interactions among galaxies. Are they merging? Are they colliding? Such events can trigger the formation of new stars and lead to a cascade of cosmic transformations. The mesmerizing dance of the cosmos unfolds before us as each galactic interaction adds to the intricate tapestry of the universe. Ultimately, the Sloan Great Wall is a testament to the beauty and complexity of the universe. It inspires curiosity about our place within it, and reminds us that even the vastness of space is filled with stories waiting to be uncovered. Encounters with such gigantic structures keep the minds of scientists and enthusiasts engaged, as each discovery brings us one step closer to understanding the grand tapestry of the cosmos. Consider the enormity of it all, and let it spark your imagination about the endless possibilities that lie beyond our world. Imagine a colossal cosmic structure, a web of galaxies connected by invisible threads of gravity. This is the Laniakea supercluster, our home in the universe. Spanning over 520 million light-years, it is an astonishing assembly of thousands of galaxies, all bound together by gravitational forces. Picture it as a giant cosmic neighborhood, where each galaxy is a starry house, and the vastness of space is the street we all share. Laniakea is not just a collection of galaxies. It is a magnificent tapestry woven with the fabric of the universe. At its heart lies the Milky Way, the galaxy we call home. Laniakea is as awe-inspiring as it is vast, encompassing some of the most well-known galaxy groups, such as the Virgo cluster, which itself is a massive gathering of over 2,000 galaxies. These galaxies are like tiny dots in a sprawling city, each with its own unique stories and formations. What truly fascinates scientists about the Laniakea supercluster is how it challenges our understanding of gravity and cosmic structures. The galaxies within Laniakea are not just drifting aimlessly through space, they are moving toward a central point known as the Great Attractor. This mysterious gravitational anomaly is pulling entire groups of galaxies towards it, akin to a magnet drawing in metal objects. Imagine the size of this cosmic magnet, affecting a substantial portion of our local universe. As we explore the Lania supercluster, we begin to understand our place in the greater cosmos. Our journey through it allows us to observe different types of galaxies, such as spiral galaxies like our own Milky Way, and elliptical galaxies which are more rounded and feature older stars. Each type of galaxy tells a different story, revealing the processes of star formation, evolution, and the dynamics of cosmic interactions. The scale of Laniakea is hard to grasp. To illustrate, consider that light travels at a speed of about 186,000 miles per second. Even at that incredible speed, light from the farthest reaches of the supercluster can take over 520 million years to reach us. This means that when we look at these distant galaxies, we are effectively peering back in time, witnessing the universe as it was millions of years ago. Scientists continue to study the Laniakea supercluster, uncovering new insights into its structure and behavior. The potential for discovery is immense, as each finding opens up new questions about the origin of galaxies, dark matter, and the evolution of the universe itself. Every galaxy within Laniakea is a piece of a bigger puzzle, contributing to our understanding of existence. So next time you gaze up at the stars, remember that you are part of Laniakea, a vast and magnificent structure in the universe. You are connected to countless other galaxies, all dancing through the cosmos, bound by the fundamental forces that govern everything. In this grand expanse of space, each star and galaxy is like a note in a beautiful symphony, contributing to the harmonious melody of the universe. Embrace this connection, and let it inspire wonder about the vastness of our cosmic home. In the vast expanse of the universe, there exists a remarkable phenomenon known as cosmic microwave background radiation. This faint glow permeates all of space and is an echo of the early stages of our universe, a remnant from a time shortly after the Big Bang. Understanding this radiation can offer fascinating insights into the history and evolution of everything we know today. To picture this, imagine a giant, all-encompassing blanket that stretches across the cosmos. This blanket is composed of countless photons, tiny particles of light that have been traveling through space for more than 13 billion years. Initially, shortly after the Big Bang, the universe was an incredibly hot and dense place, flooded with energy and matter. As it expanded, it gradually cooled. Eventually, around 380,000 years post-Big Bang, the universe cooled enough for protons and electrons to combine and form hydrogen atoms. This process allowed photons to travel freely for the first time. It is these freed photons that we now observe as cosmic microwave background radiation. What makes this radiation so alluring is the story it tells about the universe's formative years. By studying its characteristics, scientists can glean information about the conditions that prevailed in the early universe. The cosmic microwave background is remarkably uniform, with slight fluctuations in temperature across the sky. These fluctuations serve as a cosmic fingerprint, providing clues about the distribution of matter and energy, which eventually led to the formation of galaxies, stars, and cosmic structures we see today. Consider how every speck of this radiation has traveled unimpeded across the universe, crossing through galaxies and clusters of stars. In a sense, it is a time capsule, capturing a moment from the very beginning of existence. When astronomers examine the cosmic microwave background, they are peering back into time, observing the remnants of the universe in its infancy. A significant source of interest regarding this radiation comes from the study of its polarization. Just as a wave may ripple across a lake, the cosmic microwave background exhibits patterns of polarization. This subtle feature offers essential clues about the early universe's conditions and the processes that took place during its rapid expansion, known as inflation. By analyzing these patterns, scientists can test various theories of how the universe evolved from a hot, dense state to the vast cosmos we know today. In essence, the cosmic microwave background is more than just leftover radiation. It is a foundational component of our understanding of the universe. Its study helps bridge the gap between the fiery moments of the Big Bang and the cold, dark cosmos we navigate today. By exploring this ancient light, we can unlock mysteries that stretch back to the dawn of time, revealing a more profound understanding of our place in the universe. So next time you gaze up at the stars, remember that the light you see is not just from distant suns. It also carries with it whispers from the very beginnings of existence itself. Uranus is one of the most intriguing planets in our solar system, largely due to its unique rotation. Unlike most planets, which spin upright on their axes, Uranus is tilted at an extreme angle of about 98 degrees. This means that it essentially rolls along its orbit, giving rise to some fascinating and extreme seasonal variations. Imagine if you lived on a planet where the sun hung low in the sky for half of the year and then completely disappeared for the other half. On Uranus, this is the reality experienced by its inhabitants, if there were any. The tilt causes each pole to experience direct sunlight for about 42 years at a time, while the equator experiences a sort of perpetual twilight. As it orbits the sun, the seasons change dramatically, creating stark contrasts in the planet's atmosphere and weather patterns. During its summer months, the northern pole of Uranus may bask in sunlight, with temperatures possibly reaching as high as -200 degrees Celsius, while the southern pole experiences cold and dark, which can be challenging for any potential weather systems. These long seasons lead to unique patterns in the atmosphere, including strong winds and varying cloud formations. The clouds may also take on a bluish hue due to the methane in Uranus's atmosphere, which absorbs red light and reflects blue. Another fascinating aspect of Uranus is its magnetic field. The planet's magnetic poles are tilted at a curious angle, about 59 degrees from its rotational axis, which is unlike any other planet in our solar system. This unusual orientation means that Uranus's magnetic field is not centered in the core like what we see on Earth. Instead, it is offset, creating a magnetic environment that has complicated interactions with the solar wind and contributes to the planet's unique atmospheric dynamics. The tilted rotation of Uranus opens a window into the complexities of planetary formation and how different factors, such as gravitational interactions, might influence a planet's axial tilt. This raises questions about the past history of Uranus. One theory suggests that during its formation, Uranus may have been struck by other celestial bodies, leading to its current tilt. This would mean that rather than a smooth, serene rotation, Uranus might have a history of chaotic interactions in the early solar system. As we continue to study Uranus, we learn more about these processes and how they affect the planet today. Its tilt offers not only a captivating look at the dynamics of our solar system, but also serves as a reminder of the diversity of planetary characteristics that exist beyond our own Earth. Who knows what other secrets Uranus holds beneath its icy clouds? In the summer of 1977, a remarkable event took place that would capture the imagination of scientists and enthusiasts alike. This event is known as the WOW signal, Detected by the Big Ear Radio Telescope at Ohio State University, the WOW signal stands out as one of the most intriguing pieces of evidence suggesting the possibility of extraterrestrial life. To set the scene, imagine a massive telescope collecting the faint echoes of cosmic transmissions from spaces far beyond our own planet. The Big Ear was designed to scan the skies for radio waves, a method used to search for signs of intelligent civilizations. On August 15th of that year, a careful observer by the name of Jerry R. Eman was monitoring the data when he noticed an extraordinary signal. It wasn't just any flutter of radio waves, it was a powerful signal that lasted for 72 seconds, peaking in intensity like a bright light cutting through a dark room. The news of this signal spread quickly. What made the WOW signal particularly unique was its characteristics. It came from the direction of the constellation Sagittarius, a region teeming with stars and celestial mysteries. The frequency of the signal, approximately 1,420 MHz, is significant because this is the frequency emitted by hydrogen, the most abundant element in the universe. This frequency is often considered the, quote, universal beacon for communication, leading many to speculate that any intelligent life might choose it as a channel to reach out into the cosmos. As scientists analyzed the data, they noted the lack of any detectable echo. If the signal were a response from a spacecraft or a terrestrial source, they expected to see a repeated pattern or modulation, essentially a conversation. However, the WOW signal came and went, disappearing without a trace. This anomaly led some to speculate it might have originated from an extraterrestrial civilization attempting to make contact with us, while skeptics argued that it could have been a natural phenomenon, perhaps a comet or some other cosmic event. Despite numerous attempts to relocate the signal in subsequent years, the WOW signal has never been detected again. This mystery has given rise to endless theories and discussions in scientific communities and among the general public. Some suggest it could have been a one-time burst from a distant star system, while others propose it may have resulted from terrestrial interference that went unrecognized at the time. The encore of intrigue surrounding the WOW signal has influenced popular culture, inspiring documentaries, books, and even movies depicting the quest for extraterrestrial intelligence. Scientists continue to refine their methods of searching the skies, utilizing enhanced technology and novel approaches. The WOW signal stands as a reminder of the vast unknowns that still haunt the cosmos, inviting us to wonder about life beyond our own planet. As time goes on and our understanding of the universe continues to evolve, the WOW signal will remain a beacon in our quest for cosmic discovery, symbolizing our eternal curiosity and the belief that we are not alone in this expansive universe. Each time we gaze at the stars, we might find ourselves wondering if there's someone or something out there waiting to say hello. Gliese 581c is an intriguing exoplanet located about 20 light-years away from Earth in the constellation Libra. This planet orbits its host star, Gliese 581, which is a red dwarf star far cooler than our Sun. Gliese 581c was first discovered in 2007 and quickly captured the attention of astronomers and the public alike, primarily due to its location in the habitable zone of its star. The habitable zone is defined as the region around a star where conditions might be just right for liquid water to exist on a planet's surface. This concept is crucial for identifying worlds that could potentially support life as we know it. Gliese 581c orbits within this zone, making it a prime candidate for exploration and study. When scientists first learned about this planet, they thought its size and distance from its star could create temperatures suitable for water. Gliese 581c is classified as a super-Earth because it is more massive than our planet, with estimates suggesting it might be about 1.5 times the size of Earth. This makes it a fascinating subject of study, as its size implies a different geological makeup that may include more substantial volcanic activity or different atmospheric conditions. Scientists speculate that if Gliese 581c has a thick atmosphere, the greenhouse effect might help retain heat, possibly enabling liquid water to exist. Interestingly, the planet is tidally locked to its star, which means that one side of Gliese 581c constantly faces Gliese 581, while the other side remains in perpetual darkness. This unique characteristic can create stark differences between the two sides. The day side might be incredibly hot, likely making it inhospitable for life, whereas the night side could be much cooler and might even facilitate the formation of icy conditions. The unique dynamic between these areas raises intriguing questions about atmospheric circulation and how conditions might vary from one side of the planet to the other. Observing Gliese 581c also highlights the advances in our astronomical technologies. Telescopes like the Kepler Space Telescope and the European Southern Observatory's HARPS have played crucial roles in detecting exoplanets like this one. The study of such planets enables scientists to refine their understanding of how planets form and evolve and what conditions are necessary for life. Furthermore, Gliese 581c challenges our preconceived notions about habitability. It encourages us to think broadly about the criteria that would define a suitable environment for life. The many factors at play, including a planet's atmosphere, geological activity, and distance from its star, are vital in determining its potential. In essence, Gliese 581c serves as a reminder of the vastness of the universe and the diverse conditions that may exist beyond our own tiny blue planet. Whether or not it harbors life, this fascinating exoplanet invites ongoing exploration and fuels our imagination about what lies in the cosmos. Each discovery about Gliese 581c deepens our understanding of the intricate dance between stars and their planets, and inspires us to continue looking toward the stars. In the vast and enigmatic regions of the cosmos, scientists explore ideas that challenge our understanding of physics and celestial phenomena. One such intriguing concept is the theory of planets, or hypothetical planets, that orbit a black hole. Imagine a black hole, a place in space with a gravitational pull so strong that nothing, not even light, can escape it. Now, picture planets existing in the vicinity of these mysterious giants, maintaining stable orbits under specific conditions. The idea stems from the interplay between gravity and the intense forces surrounding black holes. Researchers suggest that if a planet were to orbit a black hole at just the right distance, it could experience a unique balance of gravitational forces. This balance could allow for the existence of these planets, which, while exposed to the extreme environment of a black hole, might also provide conditions suitable for some form of stability. To visualize this, think about how a tightrope walker maintains balance on a thin rope. Similarly, these hypothetical planets must find a perfect position in the swirling maelstrom of a black hole's gravitational influence. If the orbit is too close, the immense gravitational pull might tear the planet apart. If it is too far away, the planet might drift into the vast emptiness of space. Therefore, finding this delicate equilibrium is crucial for the hypothetical existence of planets. One of the fascinating aspects of the planet theory is its potential implications for understanding planetary formation and survival in extreme conditions. Scientists propose that these planets could develop unique characteristics shaped by the intense gravity and radiation from the black hole. High-energy environments might foster unusual geological activity, or even allow for exotic forms of matter to exist. Consider how the intense gravitational forces could create spectacular cosmic phenomena. As a planet orbits a black hole, it might experience tidal forces strong enough to distort its shape or generate internal heat through friction. This geothermal energy could result in the formation of volcanoes or vast geological structures similar to those found on Earth, albeit under completely different circumstances. Such features would make planets objects of significant interest in the study of planetary science. Furthermore, the presence of a black hole in a solar system could dictate the orbit of any nearby celestial bodies. The complex gravitational dance between the planet and the black hole might give rise to other celestial bodies, such as asteroids and comets, forming a rich tapestry of cosmic interactions. This leads us to ponder the potential for life forms existing in these extraordinary settings, pushing the boundaries of what we consider habitable conditions. The planet theory challenges our imagination and stretches the limits of our understanding. As we delve deeper into the intricacies of the universe, the possibility of discovering these exotic planets could provide insights not only into black holes, but also into the fundamental nature of gravity, planetary science, and the formation of celestial systems. The exploration of planets may help us to unravel the myriad mysteries of the cosmos, revealing the hidden wonders that lie beyond our current grasp. In a universe full of surprises, who knows what captivating discoveries await us in the dance of planets around black holes? Lunar water ice is a fascinating topic that has captured the attention of scientists and space enthusiasts alike. In recent years, significant discoveries have been made regarding ice deposits at the moon's poles. These findings hold immense potential for future exploration and habitation, making them an exciting area of study. The moon, our closest celestial neighbor, presents unique challenges for human exploration. Its harsh environment, characterized by extreme temperatures and radiation, poses risks that must be carefully managed. However, the presence of water ice on the Moon changes the narrative significantly. Found primarily in permanently shadowed craters near the poles, this ice is a crucial resource that can support sustainable exploration efforts. But how did we discover this ice? Numerous missions have contributed to our understanding. For instance, lunar orbiters and landers have employed advanced instruments to detect hydrogen signatures indicative of water ice. The Lunar Reconnaissance Orbiter, for example, has provided detailed maps of the lunar surface, highlighting areas where ice is likely present. These discoveries have fueled scientific interest and paved the way for future missions aimed at exploring these icy deposits. So why is this ice so important? Water is not just essential for drinking, it's also a critical component for various life support systems. It can be split into hydrogen and oxygen through a process called electrolysis, potentially providing rocket fuel for future missions beyond the Moon. This means that astronauts could potentially use local resources, significantly reducing the need to transport supplies from Earth. In addition to being a resource for fuel, water can support life in other essential ways. It can be used in habitats to create a comfortable living environment, assisting with irrigation for potential lunar agriculture. Imagine a future where astronauts cultivate plants on the Moon using lunar ice to nurture fresh food. Such advancements could transform the way humans interact with the lunar environment. Moreover, the study of lunar water ice could also provide insights into the history of the Moon and the broader solar system. Ice contains trapped gases, including carbon dioxide and nitrogen, which can reveal past atmospheric conditions. By analyzing these gas compositions, scientists can learn more about how the Moon formed and evolved, as well as the conditions that existed in the early solar system. As we look ahead to the possibility of sustained lunar missions and potentially permanent habitats, the significance of these ice deposits cannot be overstated. Future explorers will likely prioritize the exploration of lunar poles to establish bases that can utilize this invaluable ice. This could serve as a stepping stone for missions to Mars and beyond, expanding our reach into the cosmos. In summary, lunar water ice is more than just a frozen resource. It represents a key to unlocking the future of space exploration. As scientists continue to uncover its secrets, we stand on the brink of a new era, one where the Moon plays a pivotal role in humanity's quest to explore and inhabit other worlds. The potential applications of water ice on the Moon are vast and exciting, paving the way for innovations that will shape our journey into the unknown. Imagine a universe so vast that traveling between two distant points might take eons. Now, picture a shortcut connecting those 2 points, enabling you to traverse the seemingly impossible distance in an instant. This fascinating idea is represented by the Einstein-Rosen bridge, commonly known as a wormhole. The concept stems from the groundbreaking work of Albert Einstein and his colleague Nathan Rosen in the mid-20th century. Within the framework of general relativity, they established that spacetime is not merely a stage where events unfold, but a dynamic fabric that can be warped and curved by mass and energy. Picture the universe as a two-dimensional sheet of paper. If you fold the paper so that two distant points touch, you create a direct route between them, a perfect analogy for a wormhole. These bridges in spacetime are not just abstract ideas. They have captured the imagination of scientists and science fiction enthusiasts alike. Think about how convenient it would be if you could step through a wormhole to visit distant galaxies or peer into the past. Instead of preparing for a long journey across light years, a quick hop through a threaded tunnel could get you to the other side in no time. However, the journey through a wormhole is filled with theoretical challenges. For one, the existence of such structures relies on conditions that haven't yet been observed in our current understanding of physics. They would likely require exotic matter with negative energy density to keep them stable and open, a concept that exists primarily in the realm of speculation. But just because we have yet to observe them does not lessen their allure. Much of our understanding of these incredible formations comes from the mathematics of black holes, as wormholes can be viewed as connecting black holes or connecting a black hole to a white hole, hypothetical constructs that release matter rather than absorb it. Imagine encountering a black hole, a point of infinity where gravity pulls everything in, and at the other end, a white hole, bursting with energy and matter. The idea of a bridge connecting these two extremes is thrilling and challenges our thinking about space and time. Wormholes also spark deep philosophical questions about the nature of the universe and our place within it. If we could traverse such a bridge, how would it change our understanding of time? Would it allow us to explore alternate timelines, or even meet different versions of ourselves? Despite being firmly planted in the realm of theory, the Einstein-Rosen bridge continues to inspire engineers and scientists. The pursuit of knowledge often leads us to the unknown, and the possibilities that exist in the realm of wormholes encourage a spirit of exploration. While we may not yet have a way to create or navigate these intriguing structures, the journey towards understanding them shapes our quest to unlock the mysteries of the cosmos. So as we consider the extraordinary nature of wormholes, we embark on an adventure of the mind, a journey through the fabric of reality itself, bringing us closer to answering the fundamental questions of existence. The Sun, the brilliant star at the center of our solar system, is not a constant source of light and heat. Instead, it undergoes a fascinating cycle that lasts about 11 years. This rhythm, known as the solar cycle, plays a significant role in shaping our space environment, and can also affect our technology here on Earth. The solar cycle consists of phases that include periods of solar minimum and solar maximum. During the solar minimum, the Sun appears quieter, with fewer sunspots and solar flares. Think of this as a calm period, where the Sun's activity is low and the space weather conditions are relatively stable. In contrast, during the solar maximum, the Sun becomes much more active, showcasing numerous sunspots, increased solar flares, and more coronal mass ejections. This heightened activity can lead to spectacular displays of auroras, as charged particles interact with the Earth's atmosphere. So why should we pay attention to these changes? The solar cycle can significantly impact our space weather, which refers to the condition of the environment in space, particularly regarding the solar wind, a stream of charged particles released from the Sun. During solar maximum, the solar wind becomes more intense, and this can lead to various phenomena, particularly in how it interacts with Earth's magnetic field. For instance, when a strong solar flare occurs, it can release a huge amount of energy and charged particles into space. If this eruption happens to be directed toward Earth, it can create geomagnetic storms. These storms can disrupt communication systems, satellite operations, and even electrical grids. There have been instances in history, like the Carrington event of 1859, when a massive solar storm caused widespread telegraph outages. In today's world, where technology relies heavily on satellites and electronic systems, such disruptions could have severe consequences. Moreover, the solar cycle also plays a role in the Earth's climate. While the Sun is not the only factor influencing climate change, its cycles can contribute to variations in solar radiation, which in turn may have subtle effects on climate patterns over time. This interplay between solar activity and climate is an area of ongoing research and fascination. As we become more reliant on technology and our understanding of space improves, keeping an eye on solar activity becomes increasingly important. Experts can predict the phases of the solar cycle, allowing us to prepare for potential impacts and harness the beauty of our Sun's activity safely. Scientists continually monitor solar conditions, utilizing satellites that observe the Sun in different wavelengths, helping us understand not just the Sun itself, but also its influence on our planet. In conclusion, the 11-year solar cycle is much more than an astronomical curiosity. It is a powerful force that shapes our technological landscape and influences our environment. From stunning auroras to potential disruptions, the Sun's cycles remind us of the dynamic nature of our solar system and the intricate connections between celestial bodies and life on Earth. Keeping this in mind enriches our appreciation of the universe's wonders and challenges, inviting us to explore and understand the cosmos further. Neutrinos are one of the most fascinating and elusive particles in the universe. They are nearly massless, meaning they have such a tiny amount of mass that it is incredibly difficult to detect them. These particles are produced in vast quantities by stars, especially during processes like nuclear fusion, where they play a crucial role in energy production. Imagine the core of a massive star, where temperatures reach millions of degrees. In this extreme environment, hydrogen atoms fuse together to form helium, and during this transformation, an enormous number of neutrinos are created. What makes neutrinos particularly interesting is how rarely they interact with matter. In fact, they can pass through entire planets without any interaction at all. Picture this. If you were to shoot a beam of neutrinos through the Earth, billions of them would zipping through without hitting a single atom. This phenomenon is a result of their weak interaction with other particles. They only engage with matter through the weak nuclear force, one of the fundamental forces of nature. This weak interaction is what allows them to traverse vast distances across the universe without being affected. Due to this unique characteristic, neutrinos have been called ghost particles. They are almost invisible and can escape even the most intense environments, such as the core of a supernova. When a supernova occurs, it releases an enormous number of neutrinos, and scientists have discovered that these particles provide valuable information about these cataclysmic events. To detect neutrinos, scientists have to rely on ingenious methods and elaborate experiments. Some neutrino detectors are located deep underground or underwater, where they are shielded from other types of radiation that could interfere with their detection. For instance, the Super Kamiokande detector in Japan is a massive underwater facility that uses thousands of tons of water surrounded by sensitive light detectors. When neutrinos occasionally interact with water molecules, they create tiny flashes of light, which are then measured, allowing researchers to learn more about these mysterious particles. The study of neutrinos is not just an academic pursuit, it has real-world applications too. Understanding neutrinos can lead to insights about the fundamental structure of matter and the workings of the universe. They may also help answer some of the biggest questions in physics, such as the nature of dark matter and why the universe is made up of more matter than antimatter. In daily life, we are constantly surrounded by neutrinos. They are produced in abundant numbers from the sun, cosmic rays, and even from radioactive materials in our own bodies. Despite their omnipresence, their elusive nature keeps them shrouded in mystery, making the study of neutrinos an exciting and ever-evolving field in modern physics. As scientists continue to uncover the secrets of these enigmatic particles, we gain deeper insights into the universe and our place within it. Imagine a world where time works in a way that seems almost magical. Welcome to Venus, the second planet from the Sun. Here, things are quite different from what we experience on Earth. In fact, a single day on Venus lasts longer than an entire year. Let's break that down. A day on Venus, which is defined as one full rotation on its axis, takes about 243 Earth days. That's right, almost 8 months. But here's where it gets truly fascinating. The time it takes for Venus to travel around the Sun, completing one full orbit, is only about 225 Earth days. This means that a day on Venus is longer than its year. Picture this. If you were standing on the surface of Venus, you would experience a very slow spin of the planet beneath your feet. The Sun rises in the west and sets in the east, which is the opposite of what we see on Earth. This peculiar rotation also means that the Sun seems to take its time moving across the sky, creating a unique atmospheric experience. Venus is often referred to as Earth's twin because they share similar sizes and compositions. However, the similarities end there. The thick atmosphere of Venus is made mostly of carbon dioxide, with clouds of sulfuric acid, making it a hostile environment for life as we know it. The surface temperature can reach around 900 degrees Fahrenheit, hotter than the surface of Mercury, which is the closest planet to the Sun. As the clouds swirl overhead, there's little chance of cooling breezes. The atmosphere traps the heat like a heavy blanket. The air pressure on Venus is about 92 times greater than that of Earth at sea level. Just imagine walking through a heavy fog, but that fog is made of acid and feels like a pressure cooker around you. Due to Venus's unique rotation and atmospheric conditions, studying this planet poses significant challenges. Despite these challenges, space missions have explored Venus, sending back images and data about its rocky surface, vast plains, and volcanic structures. Scientists are intrigued by the geological features, including vast shield volcanoes, that suggest there might have been volcanic activity relatively recently in cosmic terms. Understanding the length of a day compared to a year on Venus not only sharpens our perception of time, but also reveals the complexities of planetary phenomena. It shows how diverse our solar system is. Each planet dances to its own rhythm, and Venus's peculiar rotation adds to the music of the cosmos. So as you ponder the wonders of our universe, think of Venus and its long days. It invites us to marvel at the mysteries hidden beyond our home planet, illustrating that there's so much more to discover and understand in the great expanse of the cosmos. Stephan's Quintet is a fascinating group of galaxies nestled in the constellation Pegasus. This collection presents a vivid example of the dynamic and sometimes tumultuous interactions that occur between galaxies in the cosmos. Discovered in 1877 by the French astronomer Edmond Stephan, these 5 galaxies provide a rich canvas for astronomers to study the effects of gravitational forces and the complex behaviors that arise from their proximity to one another. The ensemble includes 4 prominent galaxies: NGC 7317, NGC 7318A, NGC 7318b, and NGC 7320, along with a 5th galaxy, NGC 732OC, which is more distant from the others. Although they seem closely grouped together, these galaxies are actually at varying distances from Earth, making the study of their interactions even more intriguing. The closest galaxy, NGC 7320, is approximately 39 million light-years away, while the others are much further, located about 250 million light-years away. One of the most captivating aspects of Stephan's quintet is the way these galaxies interact. As they drift through space, their gravitational pulls influence each other, causing distortions in their shapes and triggering bursts of star formation. This can lead to the production of new stars in regions where gas and dust collide. For example, when 2 galaxies come close together, their gravitational forces can pull material from one galaxy into another, creating brilliant bursts of star birth that can illuminate the surrounding space. Observations of Stephan's quintet have revealed intricate details about these galactic interactions. Astronomers have captured stunning images showing long tidal tails of stars and gas that stretch between the galaxies. These tails are a result of gravitational interactions, stretching and distorting matter as the galaxies pass each other. As a result, the site offers a glimpse into the processes that sculpt galaxies over time and how they evolve in the vastness of the universe. Additionally, Stephan's quintet serves as an excellent laboratory for studying the pervasive phenomenon of dark matter. The gravitational effects observed, beyond what can be accounted for by visible mass alone, provide valuable insights into the invisible substance that composes a significant portion of the universe. Astronomers have utilized various instruments, including optical and radio telescopes, to explore the intricacies of this quintet. These observations have broadened our understanding of how galaxies merge and interact across cosmic timescales. Stephan's quintet is not just a stunning visual spectacle, it's a key piece in the larger puzzle of galactic evolution, highlighting the dynamic interplay of forces in the universe. As we continue to explore the wonders of the cosmos, groups like Stephan's quintet remind us of the extraordinary complexity and beauty that exists just beyond our planet. Each galaxy tells a story of resilience, transformation, and the ever-changing fabric of space, inviting us to ponder our place in this grand tapestry. The study of these galaxies will undoubtedly yield more questions and discoveries, revealing the secrets of the universe with each new exploration. Imagine a spectacular cosmic event unfolding in the vastness of space. The Andromeda Galaxy, our nearest galactic neighbor, is on a collision course with the Milky Way galaxy. This breathtaking occurrence is not merely a distant possibility. It is an impending reality that scientists predict will take place in about 4.5 billion years. To understand this grand collision, let's first explore the 2 galaxies involved. The Milky Way is a spiral galaxy, home to our solar system and approximately 100 to 400 billion stars. Andromeda, on the other hand, is slightly larger, boasting roughly 1 trillion stars. The sheer size of these galaxies is astonishing, with each containing countless star systems, nebulae, and celestial wonders. As Andromeda approaches, the 2 galaxies will not crash into each other in the way that solid objects do. Instead, they will dance gracefully through space, their massive gravitational forces interacting. During this cosmic ballet, their stars will not collide, as the distances between stars are incredibly vast. However, the gravitational forces at play will dominate, reshaping the structure of both galaxies. Over the course of several billion years, scientists estimate that Andromeda will collide with the Milky Way, beginning a process that will take hundreds of millions of years to complete. During this time, the galaxies will merge, forming a new, larger galaxy often referred to as Milkomeda or Milkdromeda. This merging is not just a collision. It's a transformation that will give rise to new star formation as gas clouds compress and ignite. Picture a night sky illuminated by the spectacular birth of new stars, a beautiful result of the merging galaxies. As the 2 galaxies come together, their original shapes will be lost, replaced by a more complex structure. This phenomenon offers scientists a unique opportunity to study the evolution of galaxies and understand the cosmic processes that shape our universe. In addition to the awe-inspiring visuals of the night sky in the distant future, The collision will also have profound effects on the stars and solar systems within the galaxies. Some stars may find themselves ejected into intergalactic space, while others will settle into new orbits around the newly formed galactic center. This transformation can lead to new planetary systems emerging, and who knows what kinds of celestial bodies will form. The intriguing aspect of this cosmic event is that it serves as a reminder of the dynamic and ever-changing nature of the universe. Galaxies are not static entities. They are continuously interacting and evolving. The Andromeda collision reflects the ongoing dance of gravity, time, and cosmic architecture. It is a tale of transformation, chaos, and rebirth, painting an exhilarating picture of our universe's future. As humanity looks to the stars, we find our place in this grand narrative. While 4.5 billion years may seem distant, the thought of two mighty galaxies merging sparks curiosity and wonder, reminding us of the beauty and complexity of the cosmos surrounding us. So, in contemplating the future, consider the stories written in the stars, waiting to unfold across the unfathomable depths of time. Imagine a region in space where gravity is so intense that it warps the very fabric of the universe. This phenomenon is known as a black hole, and while it may sound purely theoretical, the idea of spaghettification leads us into an intriguing discussion about the effects of extreme gravitational forces. Spaghettification is quite a fascinating term that describes what happens to objects as they get too close to a black hole. Picture a giant cosmic vacuum cleaner, pulling everything in with an unyielding force. As an object approaches a black hole, it experiences a sharp difference in gravitational pull between its closest and farthest parts. This variance creates a stretching effect. To visualize this, consider a simple example. Imagine holding a rubber band in one hand and gently pulling it with both fingers. As the tension increases, the rubber band elongates and narrows. In this case, the black hole's gravitational force is the fingers pulling the rubber band. If an object, say a star or even a spaceship, ventures too close, the gravity at its nearer side becomes much stronger than at its farther side. This difference leads to an incredibly dramatic stretching, like turning the object into a long, thin strand, hence the term spaghettification. As the object draws nearer to the black hole, this process intensifies. The gravitational pull increases exponentially the closer it gets, resulting in an extreme state where stars may elongate dramatically before being engulfed by the black hole. Imagine a massive star, many times bigger than our Sun, gradually distorting under this powerful force until it resembles nothing more than a slender noodle spiraling toward the event horizon, the point of no return. Interestingly, some scientists believe that spaghettification does not just happen to enormous objects. It could also occur on smaller scales, such as with smaller asteroids or comets being drawn into a black hole's embrace. Each of these objects would face its own unique experience of being stretched, depending on its size and distance from the black hole. This extraordinary effect illustrates not only the bizarre nature of black holes, but also the limits of our understanding of physics. For every element of science that we grasp, new concepts like spaghettification open doors to further questions and investigations. Ultimately, spaghettification reminds us of the dynamic universe we inhabit. It is a vivid representation of gravitational forces at play, showcasing nature's ability to stretch and transform. As we delve deeper into the mysteries of the cosmos, phenomena like these challenge our perceptions and ignite our imaginations. The universe is full of wonders, and spaghettification is just one of the many remarkable tales waiting to unfold as we continue our journey into the stars. Imagine a world where two tiny particles are intricately connected, communicating with each other in ways that challenge our understanding of reality. This fascinating phenomenon is known as quantum entanglement. At its core, entanglement occurs when two particles become intertwined, such that the state of one can influence the state of the other, regardless of the distance separating them. Consider this scenario. You have two entangled particles. Let's call them particle A and particle B. If you perform a measurement on particle A and find that it has a certain property, say its spin is up, something remarkable happens. Instantly, particle B, no matter how far away it is, whether it's on the other side of your room or in another galaxy, will be in a state that is directly correlated to the measurement of particle A. If particle A spins up, particle B must spin down. This connection is maintained even over vast distances, defying the intuitive concepts of communication and locality that we experience in everyday life. Quantum entanglement is often illustrated using a pair of gloves. If you take one glove out of a box containing a left glove and a right glove, you will immediately know the type of the other glove without looking. However, in the quantum world, this connection is not as straightforward. It's as if the glove knows what you have selected. This instantaneous knowledge echoes the peculiar nature of entangled particles. They exist in a remarkable state until measured, and only then do they reveal their properties. The implications of quantum entanglement reach far beyond intriguing thought experiments. Scientists are exploring its potential in the fields of quantum computing and secure communication. With quantum computers, information can be processed at unimaginable speeds, as entangled states allow qubits to perform multiple calculations simultaneously. Additionally, quantum entanglement promises to revolutionize encryption techniques, creating systems that are virtually unbreakable, ensuring that messages remain secure from any adversary. Entanglement has also challenged our understanding of reality itself. Albert Einstein famously referred to it as spooky action at a distance, expressing skepticism about how one particle could instantaneously affect another, defying the speed of light barrier established by his own theories. Yet numerous experiments confirm that entanglement is not just theoretical. Researchers have repeatedly demonstrated this phenomenon, even using particles separated by great distances in their tests. In essence, quantum entanglement bridges gaps in our understanding of the universe, inviting us to rethink popular notions of space, time, and causality. As we delve deeper into the implications of these mysterious connections, we find ourselves on the brink of revolutionary advancements that could fundamentally alter the way we understand and interact with the world around us. Through the lens of quantum entanglement, we glimpse the interconnectedness of all things, suggesting a universe where everything is more intimately related than we could ever have imagined. Saturn is a magnificent giant in our solar system, famous for its beautiful rings that have captured the imagination of humankind for centuries. But what is truly fascinating are the tiny moons nestled within these rings, known as shepherd moons. These small celestial bodies play a crucial role in maintaining the structure and integrity of Saturn's spectacular rings through their gravitational interactions. Imagine Saturn's rings as a beautifully woven tapestry. The shepherd moons are like skilled artisans, carefully positioning individual threads to ensure the entire piece stays intact. These moons, although small in size, exert a significant gravitational pull and influence the particles that make up the rings. They help define the boundaries of the rings, preventing the tiny particles from drifting away or merging into chaos. One of the most well-known shepherd moons is Prometheus. This moon orbits just outside the F ring, one of Saturn's most prominent rings. As Prometheus travels along its path, it causes gravitational disturbances that keep the F ring narrow and well-defined. It is as if Prometheus is using its presence to gently nudge the ring particles back into place, preventing them from spreading out. This interaction creates what looks like waves along the edge of the ring, giving it a dynamic and fascinating appearance. Another noteworthy shepherd moon is Pandora, which works in tandem with Prometheus on the other side of the F ring. Pandora's gravitational influence complements that of Prometheus, providing stability to the ring structure on both sides. Together, these moons act like guardians with a vital mission, ensuring that the exquisite beauty of Saturn's rings remains unmarred. In addition to Prometheus and Pandora, there are other smaller shepherd moons, such as Epimetheus and Janus. These tiny moons orbit near each other and pass close together, exchanging their orbits in a unique way that contributes to the ring's ongoing stability. Their interactions are a dance of gravity that further enhances the complexity and beauty of Saturn's ring system. The shepherd moons do not just maintain the rings. They also shed light on the complex processes of celestial dynamics. The gravitational embrace they have with the ring particles reveals how celestial bodies interact with one another. By studying these moons, scientists glean insights into how larger systems in our universe function, translating these findings to explore other planetary bodies and their rings. Saturn's rings and their shepherd moons tell a remarkable story of balance and harmony in the vastness of space. The way these tiny moons maintain order amidst a swirling mass of ice and rock particles is a testimony to the elegance of gravitational forces at play. Each moon, with its unique characteristics and role, is an essential player in the intricate ballet of Saturn's ring system, illustrating the beauty and complexity of our universe. Through their interactions, these celestial bodies create lasting patterns that captivate our imagination and deepen our understanding of the cosmos. In the realm of theoretical physics, few topics have generated as much intrigue and debate as black holes and the information paradox proposed by Stephen Hawking. This paradox invites us to think deeply about the very nature of information, reality, and the fundamental laws that govern our universe. To begin with, consider what a black hole is. A black hole is a region in space where gravity is so strong that nothing, not even light, can escape from it. This occurs when a massive star collapses under its own gravity at the end of its life cycle. Now, if something were to fall into a black hole, it seems logical to assume that it would be lost forever. This idea challenges our traditional understanding of physics, which holds that information cannot truly be destroyed. Hawking's groundbreaking work introduced the idea that black holes emit radiation, now known as Hawking radiation. According to his theory, as black holes evaporate over time, they slowly lose mass and eventually shrink away. But here lies the crux of the paradox. If a black hole eventually disappears, what happens to the information about the matter that fell into it? Does it vanish with the black hole, leading to a scenario where information is lost forever? This contradicts a key principle in quantum mechanics, where it is believed that information is preserved. Various physicists have put forth different theories, attempting to solve this paradox. Some argue that the information might be stored on the event horizon, the boundary surrounding a black hole, possibly encoded in a two-dimensional manner. This theory suggests that while the information is no longer accessible in three-dimensional space, it could still be preserved in some form, offering a glimmer of hope in reconciling the conflicting views of black holes and information preservation. In contrast, others propose more radical ideas, such as the concept of black hole complements, which implies that everything might still be intact in another universe or dimension, but simply veiled from our perception. This brings us to questions about parallel universes, the fabric of reality, and our understanding of space-time. While the debate surrounding Hawking's information paradox remains unresolved, what is truly captivating is the way it compels us to reevaluate our understanding of the universe. It draws connections between gravity, quantum mechanics, and the nature of reality itself. As scientists continue to delve into the mysteries of black holes, they not only push the boundaries of our knowledge, but also inspire a sense of wonder about the cosmos. The explorations sparked by this paradox remind us that the universe still holds many secrets. The very idea that hidden information could be trapped within a black hole challenges us to think creatively and opens up an expansive field of thought in theoretical physics. It urges us to question our assumptions and consider possibilities that may seem beyond our grasp. As we continue to explore these profound questions, we are reminded of the beauty and complexity of the universe we inhabit. Proxima Centauri, the closest star to our Sun, is a fascinating celestial object, located just over 4 light-years away in the constellation of Centaurus. This red dwarf star is not only intriguing for its proximity, but also for its dynamic behavior, particularly its powerful stellar flares. Understanding these flares can offer insights into the environment of the planets orbiting this star, especially Proxima Centauri b, a planet that lies within the so-called habitable zone. Stellar flares are bursts of energy released when magnetic fields around a star's surface get twisted or tangled during stellar activity. When these magnetic structures realign, they can release massive amounts of energy in the form of light and radiation. In the case of Proxima Centauri, these flares can be particularly intense, much more so than the solar flares we experience from our Sun. Imagine a firework exploding in the night sky, bright and energetic, except these fireworks are happening on the surface of a distant star. For Proxima Centauri, these flares can last from seconds to even several hours, emitting a spectrum of radiation that can be several times more powerful than the normal output of the star. This poses interesting questions about the environment on the nearby planets. Proxima Centauri b is one of the most studied exoplanets because it lies in a region where liquid water could exist, which is often considered a vital ingredient for life. However, the intense radiation from Proxima Centauri's flares could have significant impacts on the planet's atmosphere. Think of how a storm can change weather conditions on Earth. Similarly, frequent and powerful flares could strip away the atmosphere of Proxima Centauri b over time, creating a hostile environment for potential life. Furthermore, these flares can also affect the planet's surface conditions by increasing the radiation levels. Unlike Earth, which has a magnetic field that protects us from the Sun's flares, Proxima Centauri b's magnetic field might not be strong enough to provide similar protection. This raises intriguing questions about the potential for life on the planet and how organisms, if they exist, might adapt to such extreme conditions. Scientists are keeping a close eye on Proxima Centauri and its flares, using advanced telescopes and technology to monitor their intensity and frequency. By studying these stellar bursts, researchers can gather valuable data that informs our understanding of habitability around red dwarf stars. This knowledge not only helps us understand Proxima Centauri, but also contributes to a broader understanding of how life might exist on planets orbiting other stars. In conclusion, Proxima Centauri and its unpredictable flares present a unique case in the search for life beyond Earth. The dance of stellar energy, and the possible consequences for nearby worlds, invite us to consider the vast complexities of the universe. Each flare offers a glimpse into the powerful processes shaping the cosmos, making Proxima Centauri an object of endless curiosity for astronomers and space enthusiasts alike. As we continue to explore the possibilities of life in the universe, the study of such phenomena remains an exciting frontier in our quest for knowledge. Nestled in the arid landscape of northern Chile lies one of the most remarkable astronomical observatories in the world, the Atacama Large Millimeter Array, or ALMA. This extraordinary facility consists of 66 high-precision antennas, working together to explore the universe in ways that were once thought impossible. The ALMA Observatory is particularly powerful for studying the millimeter and submillimeter wavelengths of light, which are vital for understanding the cold universe that is otherwise invisible to standard optical telescopes. The Atacama Desert, with its high altitude and exceptionally dry climate, provides the perfect location for this type of research. The thin atmosphere allows for clearer observations, reducing the interference that can hinder data collection. Imagine standing at a site where the stars seem much closer and the air is crisp and clear. This is the environment in which ALMA operates. One of the most fascinating aspects of ALMA's work is its focus on molecular gas and dust. These components are essential for understanding the life cycles of galaxies, stars, and even planetary systems. The telescope enables scientists to peer into dense clouds of gas and dust, revealing the processes that lead to star formation. For instance, ALMA has captured stunning images of regions like the Orion Nebula, providing a glimpse into the birthplaces of stars and their planetary companions. Beyond star formation, ALMA also investigates the chemical composition of other celestial bodies. By observing the specific wavelengths emitted by various molecules, researchers can deduce what elements and compounds exist in distant galaxies. For example, ALMA has been pivotal in identifying complex organic molecules, raising intriguing questions about the potential for life beyond Earth. Moreover, ALMA has the capability to observe the early universe, shedding light on cosmic events that occurred billions of years ago. By examining the redshift of light from ancient galaxies, scientists can piece together the timeline of the universe's evolution. This revolutionary perspective allows us to understand how galaxies merged and evolved over time, further enhancing our grasp of cosmic history. The insights generated by ALMA are not restricted to distant phenomena. They also inform our understanding of our solar system. The telescope has observed comets and asteroids, providing information on their composition and behavior as they traverse their orbits. This knowledge is crucial not only for planetary science, but also for future exploration endeavors. In addition to its scientific contributions, ALMA serves as a perfect example of international collaboration. Built through a partnership among several countries and organizations, it represents a collective commitment to advancing our understanding of the cosmos. Researchers from around the world come together at ALMA to analyze data and share findings, fostering a global exchange of ideas and innovation. In a world where the mysteries of the universe often seem out of reach, the Atacama Large Millimeter Array stands as a beacon of knowledge. As we continue to explore the vast expanses of space, ALMA's insights into molecular gas and dust help us unravel the complex tapestry of the universe, one observation at a time. Through its powerful observations, ALMA illuminates the unknown, guiding humanity's quest to understand the cosmos, its origins, and our place within it. The Chandrasekhar limit is a fascinating concept in astrophysics that defines the maximum mass a white dwarf star can have before it can no longer maintain its stability. A white dwarf is the remnant core of a star that has exhausted its nuclear fuel and shed its outer layers, leaving behind a hot and dense core composed primarily of carbon and oxygen. These stars, while incredibly dense, must adhere to strict conditions in order to remain stable. At the heart of the Chandrasekhar limit is the understanding of electron degeneracy pressure. In very simple terms, this refers to the pressure exerted by electrons when they are packed together closely. When a white dwarf forms, the electrons in its core are forced into a small volume. According to the principles of quantum mechanics, these electrons cannot occupy the same state if they are confined to a very small space, creating pressure that counteracts the force of gravity trying to collapse the star. The Chandrasekhar limit is approximately 1.4 times the mass of our Sun. This specific value results from a combination of quantum physics and the principles of thermodynamics, establishing a delicate balance between gravity and electron degeneracy pressure. If a white dwarf's mass exceeds this limit, it will be unable to support itself against gravitational collapse. When a white dwarf exceeds this limit, interesting scenarios unfold. It can result in the star collapsing into a neutron star, where electrons combine with protons to form neutrons. This dense object is incredibly compact, making it even more extreme than a white dwarf. In other cases, if the mass continues to grow, it can eventually collapse into a black hole. White dwarfs can gain mass through various means, such as accreting material from a companion star in a binary system. As they accumulate more matter, they can develop the potential to surpass the Chandrasekhar limit. This process can lead to explosive scenarios known as Type Ia supernovae, where the white dwarf undergoes a runaway nuclear fusion reaction, creating a brilliant explosion that can outshine entire galaxies for a brief period. Understanding the Chandrasekhar limit has significant implications for our comprehension of the universe. It provides insights into the life cycles of stars, the evolution of galaxies, and the formation of exotic objects like neutron stars and black holes. This limit serves as a fundamental criterion in determining the fate of stellar remnants, influencing the dynamics of the cosmos and the formation of heavy elements essential for life. So, the next time you look up at the night sky filled with twinkling stars, remember that the delicate balance of forces that govern them is rooted in principles established by scientists such as Subrahmanyan Chandrasekhar. His contributions continue to illuminate the cosmos, showcasing the wonders of astrophysics and the remarkable lives of stars. The Milky Way is a vast and intricate galaxy, but much of its beauty and complexity remains hidden from our eyes. When we look up at the night sky, we see only a fraction of what our galaxy truly is. In fact, most of the Milky Way is obscured by clouds of dust and gas. This interstellar material blocks visible light and prevents us from seeing many of the fascinating structures and phenomena that lie within. Imagine standing in a lush forest. The thick canopy of leaves overhead casts shadows on the forest floor, concealing the vibrant life that thrives beneath it. Similarly, in our galaxy, the dust and gas act like that canopy, hiding the stars, nebulae, and other celestial bodies from our view. This is where astronomers step in, employing different methods to peer through this veil. To unveil the hidden wonders of the Milky Way, scientists use various wavelengths of light beyond the visible spectrum, such as infrared, radio, and X-rays. Each type of electromagnetic radiation offers a unique perspective. For example, infrared light can penetrate clouds of dust and reveal the warm, glowing cores of star-forming regions. Observing in this wavelength, astronomers have identified areas where new stars are born, sometimes in dense clusters that would otherwise remain obscured. Radio waves, on the other hand, provide insight into the structures of our galaxy. By studying the emission of hydrogen atoms, the building blocks of stars, researchers have mapped the spiral arms and the overall shape of the Milky Way. What they discovered is a dynamic galaxy with swirling arms that stretch out like tendrils into space, brimming with potential for new stars to ignite and shine. X-ray observations delve into even more dramatic aspects of our galaxy. They've revealed the remnants of supernovae explosions, where massive stars have ended their life cycles with violent outbursts, leaving behind hot gas that radiates in X-rays. These remnants contribute to the recycling of material in the universe, providing essential elements that can eventually form new stars and planets. Another exciting aspect of studying the Milky Way involves our galactic center. Hidden behind thick clouds of gas and dust lies a supermassive black hole, known as Sagittarius A Nort. It's astonishing to think that an object so dense can exert such a profound influence on surrounding stars and gas. Astronomers have observed stars orbiting around this black hole, revealing information about its mass and the dynamics of the center of our galaxy. The more we explore with various wavelengths, the more we learn about the unseen parts of the Milky Way. Each discovery adds to the grand narrative of our universe, reminding us that what is not immediately visible often holds the greatest mysteries. So while we gaze up at the starry night, It can be comforting to know that even the things we cannot see are filled with wonder, waiting for us to uncover their secrets. Each layer of obscured beauty beckons, sparking curiosity and inspiring the quest for knowledge about our celestial home. The Higgs boson is a crucial piece of the puzzle when it comes to our understanding of the universe. Discovered at CERN in 2012, this elusive particle plays a vital role in the Standard Model of particle physics, which explains how the fundamental particles that make up everything around us interact with one another. To grasp the importance of the Higgs boson, we need to delve into the world of particles and mass. In the universe, everything we see, from the stars in the sky to the chair you might be sitting on, is composed of atoms, and atoms are made up of even smaller particles: protons, neutrons, and electrons. But why do these particles have mass? That question leads us to the Higgs field, an invisible field that permeates the entire universe. Imagine walking through a crowded room filled with people. The more people you bump into, the harder it becomes to move quickly. In this analogy, the room represents the Higgs field, and the people represent the Higgs bosons. When particles pass through this field, they interact with the Higgs bosons. Some particles, like electrons, interact strongly, which slows them down and gives them more mass. Other particles, like photons, do not interact at all with this field, allowing them to travel at the speed of light and remain massless. The presence of the Higgs boson confirms the existence of the Higgs field. It is like a ripple in the ocean. While most of the ocean remains calm, the ripples show that something is happening beneath the surface. The discovery of the Higgs boson was pivotal because it validated the concept of the Higgs field and its role in providing mass to particles. Without the Higgs boson and the associated Higgs field, most fundamental particles would be massless, rendering the universe a very different place. Atoms would not be able to form. Matter, as we know it, would collapse. Stars and galaxies would never coalesce, and life would not exist. The Higgs boson plays a significant role in allowing the universe to hold itself together and enables the formation of the complex structures we observe. This fascinating discovery at CERN has opened up new avenues in science, encouraging researchers to delve deeper into the mysteries of the cosmos. The Higgs boson has raised further questions, prompting discussions about other fundamental forces in particles. Scientists are now looking into aspects like dark matter and the unification of forces, exploring how they are intertwined with the Higgs mechanism. In this vast universe, the Higgs boson stands out not just as a particle, but as a fundamental underpinning of the reality we experience. The journey of understanding this particle is just as important as the discovery itself, as it shows us how interconnected our universe truly is. Each particle, every force, and their relationships paint a broader picture, inviting us to marvel at the complex dance of creation that surrounds us every day. In the vast expanse of our universe, there exist fascinating celestial phenomena known as stellar black holes. These intriguing entities form from the remnants of massive stars when they exhaust their nuclear fuel. When a massive star reaches the end of its life cycle, it undergoes a dramatic transformation. At its core, nuclear fusion processes slow down, and the outward pressure that previously countered the force of gravity diminishes. Eventually, the gravitational pull takes over, leading to a catastrophic collapse. Imagine a gigantic balloon, full of air and floating lightly in the sky. The balloon represents a massive star, and every breath of air corresponds to the energy produced by nuclear fusion. Once the air is released and the balloon deflates, it succumbs to gravity, collapsing in on itself. In a similar manner, the star collapses under its own weight, compressing its core into an incredibly small volume, leading to the formation of a stellar black hole. These stellar black holes are typically several times more massive than our Sun. However, their defining feature is not just their significant mass, but also their extraordinarily dense nature. The gravitational pull of a stellar black hole is so intense that it creates a region of space-time from which nothing can escape, not even light. This is why they are termed black holes. They are invisible against the backdrop of space. As a stellar black hole forms, it can emit an extraordinary amount of energy. Surrounding matter, often drawn from a companion star, accelerates and becomes heated in the process. This results in the generation of high-energy X-rays that scientists can detect, allowing us to identify the location of these black holes in the night sky. When you look up at the stars, you might not see the black holes themselves, but you can certainly observe the effects they have on nearby stars and gas. Interestingly, stellar black holes range in size. While they can weigh between a few to tens of times the mass of the Sun, they are considerably smaller than their supermassive counterparts. Supermassive black holes, found in the centers of galaxies, can possess masses equivalent to millions or even billions of suns. This stark contrast emphasizes the expansive variety of black holes that exist throughout the cosmos. Research into stellar black holes also sheds light on other astrophysical phenomena. For instance, the study of their collisions can provide vital insights into gravitational waves, ripples in spacetime that are created when massive objects accelerate. These waves have captured the attention of astronomers and physicists alike, revealing a deeper understanding of the universe's structure. In summary, stellar black holes are remarkable objects formed from the incredible gravitational collapse of massive stars. Though they may be small compared to supermassive black holes, their dense nature and the energy they emit provide a treasure trove of information about our universe. As we continue to observe and learn from these enigmatic entities, we uncover the compelling stories that stars and their spectacular end-of-life events tell us about the cosmos. Trojan asteroids are a fascinating phenomenon in our solar system, serving as cosmic companions to larger planets. These are groups of asteroids that share the same orbit as a planet, particularly Jupiter, and they are located at specific points known as Lagrangian points. These points are areas where the gravitational forces of the planet and the Sun balance with the centripetal force felt by the asteroids, allowing them to maintain a stable position as they travel along the same path. Imagine riding a bicycle in a circle while holding a balloon. If you let the balloon go, it will float away unless you catch it just right. The Lagrangian points are like spots where you can hold that balloon without having to chase it. For the Trojan asteroids, these points are located about 60 degrees ahead of and behind Jupiter in its orbit. This unique positioning allows them to travel alongside the giant planet while remaining stable even as they move through space. Jupiter has a particularly large number of Trojan asteroids, with estimates suggesting there are over 10,000 of them. The largest and most well-known of these is 624 Hector, which measures about 370 kilometers across. These asteroids vary tremendously in size and composition, providing a wealth of information for scientists studying the early solar system. By understanding these celestial bodies, researchers can learn more about the building blocks of planets and the processes that formed our cosmic neighborhood. Trojan asteroids are thought to originate from a region in the early solar system known as the Kuiper belt, where many small icy bodies exist beyond Neptune. It's believed that as the planets formed, some of these bodies were captured by Jupiter's immense gravity, leading them to become the Trojans we see today. The process of capture is a bit like fishing. Jupiter's gravitational pull is so strong that it can reel in these icy and rocky bodies and keep them in its orbit, creating a dynamic interaction within our solar system. Not only do Trojan asteroids offer insight into the past, but they also provide a window into the potential future of space exploration. Their stable orbits make them interesting targets for spacecraft missions, as they could serve as stepping stones for exploring deeper into space or examining the resources available within the asteroid belt. Future missions could include robotic explorers that will study their composition and characteristics, unlocking more secrets about how our solar system came to be. The Trojans also present an intriguing opportunity for amateur astronomers and enthusiasts. Observing these asteroids can be a rewarding experience, revealing the wonders of our celestial neighborhood. Because of their stable orbits, some Trojans can be tracked over time, offering a unique glimpse into the dynamics of the solar system. In summary, Trojan asteroids are not just random rocks floating in the void, they are remnants of a bygone era, locked in a gravitational dance with Jupiter. Each one holds stories of the birth of our solar system, waiting for us to discover their secrets. As we continue to explore the universe, these cosmic companions will play a vital role in expanding our understanding of the cosmos and our place within it. Deep in the heart of our Milky Way galaxy lies the breathtaking Carina Nebula, one of the most magnificent regions of star formation. This immense nebula is easily visible to the naked eye from the southern hemisphere and is often regarded as a cosmic wonder. You can find the Carina Nebula roughly 7,500 light-years away from Earth, nestled in the constellation Carina, which means the keel in Latin, referencing the ship Argo of Greek mythology. The Carina Nebula is a mesmerizing display of young stars, swirling clouds of gas, and dark dust lanes. Among its brightest stars is Eta Carinae, a massive star system that is one of the heaviest stars known, with about 100 times the mass of our Sun. Eta Carinae is not only renowned for its size, but also for its unpredictable behavior. It has gone through dramatic outbursts, making it a fascinating object of study for astronomers and stargazers alike. When you gaze upon the Carina Nebula, you are witnessing a cosmic cauldron of activity. This region is home to some of the hottest and most luminous stars, which are born from the thick clouds of gas and dust. As these new stars ignite, they release ultraviolet radiation that shapes the surrounding materials, creating beautiful pillars and structures that fill the nebula with breathtaking forms. These towering pillars of gas, known as the Pillars of Creation, are some of the most recognized features in the nebula, with their stunning shapes resembling fingers reaching toward the stars. The Carina Nebula is also an excellent example of how nature creates. As stars are born, they can create shock waves that compress nearby gas and dust, triggering the birth of even more stars in an endless cycle of creation. This process leads to star clusters, tightly bound groups of stars that can number in the thousands. Observing these clusters is like witnessing a cosmic nursery bustling with new life. As you continue to explore this celestial wonder, consider the composition of the Carina Nebula. It contains a mix of hydrogen, helium, and other elements, which serve as the building blocks for new stars and planets. The nebula's intricate structure captures light in various ways, revealing different colors to our eyes, from deep blues to vibrant reds. These colors represent the various temperatures of stars and the gases they are made from, forming a breathtaking tapestry that enchants anyone who gazes upon it. In conclusion, the Carina Nebula is not just an immense cloud of gas and dust. It is a dynamic and ever-changing testament to the forces of nature. It showcases the cycle of star formation and the beauty inherent in the universe. Whether you view it through a telescope or simply observe it with your naked eye on a clear night, it invites you to explore the cosmic wonders that lie beyond our home planet. The Carina Nebula serves as a reminder of the beauty, mystery, and vastness of the universe, inspiring generations of dreamers and explorers to look up at the night sky in awe. Welcome to the fascinating world of subatomic particles, where mysteries abound and discoveries can change our understanding of the universe. Today, we will delve into muons, intriguing particles that share similarities with electrons but possess a much greater mass. This heavy cousin of the electron is not just an oddity. It holds secrets that tantalize physicists and might even provide insights beyond the established framework of particle physics, known as the Standard Model. To understand muons, let's first consider what is familiar: the electron. Electrons are tiny, negatively charged particles that orbit the nuclei of atoms, playing a crucial role in the formation of chemical bonds and the behavior of matter. They are lightweight and abound everywhere around us. In contrast, muons are about 200 times heavier than electrons. This heavier mass affects how muons interact with other particles and the forces around them. Muons are produced in high-energy interactions, such as when cosmic rays, particles from outer space, collide with particles in the Earth's atmosphere. When this happens, a cascade of reactions occurs, and amongst them, muons are born, allowing scientists to study them through specialized detectors. Despite their involvement in these energetic events, muons are surprisingly short-lived, typically decaying into other particles within microseconds. This fleeting existence adds a layer of complexity to their study and makes their discovery intriguing. What makes muons particularly captivating is their relationship to one of the great challenges in modern physics. The Standard Model has been a robust framework, successfully explaining how particles interact through fundamental forces. Yet, it has its limitations. For instance, it does not account for gravity, or the mysterious dark matter that seems to make up most of the universe. Muons could offer a window into physics that extends beyond this established model. One area where muons are making waves is through anomalies seen in their behavior. Experiments have revealed that muons do not behave exactly as predicted by the Standard Model. This discrepancy suggests that there might be new physics at play, perhaps even the existence of undiscovered particles or forces. Such findings can reshape our understanding of the universe and lead to a deeper comprehension of how everything functions at the most fundamental level. In addition, muons can penetrate materials more effectively than electrons, making them useful for practical applications such as imaging, similar to X-rays but with higher penetration capabilities. For example, researchers are exploring their use in creating detailed images of structures like volcanoes or even pyramids, providing insights that remain hidden from conventional imaging techniques. The quest to uncover the mysteries of muons highlights the excitement of exploring the unknown realms of particle physics. As scientists continue to investigate these heavy, elusive particles, each new piece of data could unlock further secrets of the universe, shedding light on the fundamental principles that govern all matter. As we ponder how these small particles could lead to monumental discoveries, we can appreciate just how much there is to learn in the vast, intricate tapestry of our universe. Each discovery, fueled by curiosity and exploration, pushes the boundaries of knowledge just a little further, revealing a world that is both complex and breathtaking. The freeze-out scenario is a fascinating cosmological model that describes a future state of our universe. Imagine a vast expanse of space, filled with galaxies, stars, and cosmic debris, all moving apart from each other. This scenario begins with the observation that the universe, which has been expanding since the Big Bang, could eventually experience a significant change in its pace of expansion. Initially, the universe expanded rapidly, influenced by dark energy, a mysterious force thought to account for the relatively fast rate of expansion. However, as time goes on, this dark energy may undergo changes that slow down the universe's growth. Picture this slowing expansion as if a car, once speeding down an open road, gradually decreases its speed as it approaches a red light. The universe's expansion slows, and over vast periods, it could come to a complete stop. Now, one might wonder, what happens after the universe stops expanding? This is where the freeze-out scenario becomes particularly intriguing. It suggests that at some distant point in the future, all galactic movements cease. The stars that once shined brightly in the cosmos could begin to dim, as they exhaust their nuclear fuel. The once vibrant neighborhoods of stars in our galaxy might turn into dark voids, eventually leading to an incredibly cold, quiet existence. As the stars fade, celestial bodies continue to drift into oblivion, undergoing what astronomers term heat death. This term may sound alarming, but it merely signifies a state where the universe reaches thermodynamic equilibrium. In this state, temperatures become uniform across space. Energy is evenly distributed, as entropy, a measure of disorder, has increased to its maximum. Picture a room that has become so evenly distributed in temperature that you can no longer determine where the heat sources once were. In this tranquil yet chilling future, galaxies will be isolated from one another, light from stars will no longer traverse the vast distances of space, and the universe may become a cold, dark place. Instead of the vibrant collection of galaxies we observe today, spanning our observable universe, we could find ourselves in a realm where only remnants of the past exist. The freeze-out scenario illustrates the beauty and inevitability of cosmic evolution. It serves as a reminder of how dynamic our universe is, continuously changing through epochs marked by various processes. While this idea may sound foreboding, it also evokes wonder about the cycles of existence, how central elements of the universe transform over eons, leading to new states of being. The ultimate fate of our universe, whether through the freeze-out scenario or another process entirely, encourages contemplation about time, space, and existence itself. Through this lens, we can appreciate the delicate balance of forces at play and recognize how the cosmos reflects the transient beauty of all things within it. The freeze-out scenario invites us to consider what it truly means to be part of such a magnificent universe, and how every moment we experience is a fleeting dance between light, energy, and time. The Hubble constant is a fascinating topic in the field of cosmology, and it deals with one of the most essential questions about our universe: how quickly is it expanding? The universe has been growing since the moment of the Big Bang, about 13.8 billion years ago. The Hubble constant provides a numerical value for the rate of that expansion, which is crucial for understanding the structure and evolution of the cosmos. To help visualize this concept, imagine blowing up a balloon. As you blow air into it, the surface of the balloon expands, and everything on it moves away from one another. The Hubble constant is somewhat similar. It indicates how fast galaxies are receding from us as the universe grows larger. The debate around the Hubble constant stems from different methods used to measure it, resulting in varying values and sparking discussions among scientists. Two primary approaches to measuring the Hubble constant are the cosmic distance ladder and the observations of the cosmic microwave background radiation, or CMB. The cosmic distance ladder involves measuring distances to nearby astronomical objects, such as Cepheid variables, which are pulsating stars whose brightness is well understood. By determining how far away these stars are, astronomers can estimate the distances to galaxies and the speed at which they are moving away from us. This method has produced a value of about 73 kilometers per second per megaparsec. On the other hand, the CNB, which represents the afterglow of the Big Bang, allows scientists to calculate the Hubble constant in a different way. This technique, rooted in the study of the early universe, has yielded a lower value of approximately 67 kilometers per second per megaparsec. The discrepancy between these two measurements has raised important questions in the scientific community. Some physicists speculate that this difference might indicate new physics beyond our current understanding, hinting at possible interactions involving dark energy or the existence of new particles. Others suggest that there could be systematic errors in the measurements. Regardless of the reason, this debate emphasizes the dynamic nature of scientific inquiry, where questions lead to deeper exploration and new discoveries about the universe. Moreover, this discussion deepens our appreciation for the vastness of the cosmos. As we attempt to comprehend the rate of expansion, we realize that we are part of something much greater. Each time we look at the stars, we connect with the history of the universe, the light that has traveled across billions of years to reach us. The ongoing exploration into the Hubble constant not only seeks to solve a mathematical question, but also ignites a sense of wonder about the mysteries that lie beyond our own planet. Through this journey of discovery, scientists continue to analyze data and refine their methods, pushing the boundaries of our knowledge. The quest to resolve the Hubble constant debate is a reminder of the infinite complexities of the universe, providing insights that may illuminate our understanding of time, space, and everything in between. Each new finding brings us one step closer to grasping the true nature of the cosmos and our place within it. Starlight is one of the most beautiful phenomena we can observe in the night sky. However, there is an intriguing aspect of it that can alter our perception of the vast universe around us. This concept is known as starlight extinction, which primarily occurs due to dust and gas present in galaxies. Imagine a beautiful painting hidden behind a veil. The vibrant colors and fine details of that artwork may not be visible because of the obstruction in front of it. Similarly, dust and gas in the cosmos can obscure starlight, affecting how we perceive celestial structures. In our galaxy, the Milky Way, vast clouds of interstellar dust and gas float throughout the space between stars. These clouds can consist of tiny particles made of carbon, silicates, ices, and even organic compounds. When light from distant stars travels through these regions, it can get absorbed or scattered. This interaction diminishes the intensity of the light that reaches our eyes, altering our view of stars and galaxies beyond. The effect of extinction can vary depending on the wavelength of light. For example, shorter wavelengths like blue light are scattered more effectively than longer wavelengths like red light. This selective scattering can lead to intriguing phenomena, such as the reddish appearance of distant stars and galaxies. To visualize this, think of how the sky appears at sunset. The lower angle of the sun's light passes through more atmosphere, scattering the blue light and resulting in vibrant oranges and reds. In the cosmos, a similar process is at play when starlight travels through dust. Astrophysicists have developed various ways to study and quantify these extinction factors. By examining the light from many stars and galaxies, they can estimate the amount of dust present in different regions of space. This also sheds light on the composition and structure of galaxies. For instance, in regions with heavy dust concentration, the light from young, hot stars may be completely obscured, while older stars, which emit light in longer wavelengths, can be studied more easily. Understanding these extinction factors is crucial not only for mapping our galaxy, but also for studying distant galaxies and their formation. When we look at images of distant galaxies, the vibrant colors and structures can sometimes be misleading due to the influence of dust. By compensating for extinction, scientists can gain a clearer picture of stellar populations and their development over time. Consequently, the interplay of dust and gas in galaxies provides valuable information about the universe's history and structure. Each star's journey through these cosmic clouds tells a unique story, revealing how our universe has evolved and the fundamental processes that govern it. By peering through the veil of obscured starlight, astronomers unlock mysteries that resonate across vast distances in time, adding layers to our understanding of the cosmos. This dynamic relationship between light and matter allows us to appreciate not just what we see, but also what lies beyond the visible, hidden in the depths of space. In the vast and intricate tapestry of the universe, there exist extraordinary phenomena that hold a captivating charm and scientific significance. Among these are the galactic bubble blowers, which are massive young stars that play a vital role in shaping their cosmic surroundings through an enchanting process involving stellar winds. Imagine a young star, burning brightly and radiating immense energy. These stars, some much larger than our Sun, unleash powerful stellar winds that propel charged particles into the surrounding interstellar medium. As these winds collide with the surrounding gas and dust, they create intricate structures that resemble bubbles in a cosmic ocean. These bubbles, though vast and seemingly ethereal, are made of gases that allow us to glean important insights about star formation and the life cycle of materials in space. As the winds from a single massive star sweep through the interstellar medium, they push the surrounding material outward. Over time, this action carves out a cavity, creating a large bubble in space. The size of these bubbles can be astounding, often stretching several light years across. Within these bubbles, the temperature can be incredibly high, resulting in a shimmering glow that can be detected by telescopes from great distances. The formation of these cosmic bubbles is not a solitary event. It often involves groups of stars, creating a cascading effect. When several massive stars are born in a cluster, their combined stellar winds can lead to a series of interconnected bubbles, forming a breathtaking and complex structure in the night sky. Observing these clusters can be a stunning visual experience, showcasing the interplay between gravity, light, and the materials that make up our universe. Beyond their aesthetic beauty, galactic bubbles serve as crucial laboratories for studying the dynamics of star formation. Within the bubbles, the interplay between the stellar winds and the surrounding medium can trigger the collapse of pockets of gas and dust, giving rise to new stars. This process highlights the cycle of matter in the cosmos, demonstrating that destruction often leads to creation, illustrating the marvelous dance of existence in the universe. As stellar bubbles expand, they also contribute to the enrichment of the interstellar medium. The massive stars eventually go through life cycles that might end in supernova explosions. When this occurs, they disperse elements created in their cores back into the universe. These materials are essential for the formation of future generations of stars and planets. The study of galactic bubble blowers and their magnificent workings offers a glimpse into the complex and ever-evolving nature of our universe. From births of stars to the ebb and flow of cosmic materials, these celestial phenomena remind us of the beauty and complexity that lies beyond our planet. Peering into the vastness of space, one cannot help but feel a sense of wonder at the dynamic forces at play sculpting the very fabric of the cosmos.